ExcelR. We don't just train, we build careers.
Hello everyone, welcome to the Cybersecurity course by ExcelR. But cybersecurity isn't a skill, it is a mindset. Mindset about identifying patterns, preventing us from the attackers, and building a safe environment around us. So in this course, we are going to build your foundation step by step to understand what is happening during a cyber attack and gradually level you up on how to respond quickly, how to limit the damage, and how to control when the incident has already happened. And yes, you don't need to be a tech expert to learn this. This is for everyone. Before we move ahead, please like, share, and subscribe our channel to ensure you don't miss out on any of the informative content. Alright, now I'll hand it over to our subject matter expert who will be taking you through the course in a structured, user-friendly way, which will give you lots more insights on each of the topics and will clarify all your doubts about the course. So let's begin.
Welcome everyone, faculties, for this FDP on cybersecurity. Today we are going to start with day 1 of day 5, maybe for the next 2 hours, right? So we have just sorted out somewhere around 10 hours is a whole coursework, right? And we have split it into 15 minutes slot. So obviously we have landed in fine-tuning somewhere around 40 topics. And in academics, when we teach, we'll be just talking about foundation. See, in the university, in the college, we talk about foundation. We give you foundation, you go to industry and do something. We give you foundation and you go to industry and take to the next step, right? So when it comes to cybersecurity, right, we need to just know the basics of hardware, networking, network security, then move on to any XYZ cybersecurity concept. Because being in academics and being in also industry, right? So when we go out and search for a certificate on cybersecurity, there will be a catchy keyword, ethical hacking or hacking, right? So they'll just give some certificates, ask you to do one things, just like landing on step number 3 or 4. We need to start with step 1, 2, 3, and 4, right? So even when I interview quite a good number of candidates for companies, right? So we'll ask them, hey, he'll be saying like, hey, I'm a bug bounty, I have taken some bugs in some website, I have done something X, Y, Z, greater achievements. We'll just ask him, hey, let me know what is port number 2021. If he's not able to answer saying that what is 2021, corresponding to FTP, right? So we might not be able to give him a job, right? He might be learning something not from the scratch, something on an intermediate level, just like talking in faculty terms, right? You cannot do a MTech or PhD without a graduation, BTech or your high school. Same way, we have slotted this into 40 slots. Maybe today we'll be covering the basics of network security, and what is needed in Windows and Linux. At the end of the day, someone goes, maybe our students goes to industry, they work, they'll be working on a infrastructure, right? Networks connected on Windows system or Linux system. It can be servers, it can be Apple devices and on. The most common are Windows and Linux. So the foundation concepts which we need to know is, we need to know what is hardware, network security, and some basic commands of Windows and Linux. So we will be starting with this on day 1, on the first 8 topics. Then we'll be quickly walking through in a chronological order, right? What is AAA principle? What is CAA principle? What are all the layers of security? What is a breach? Right? If someone says, hey, my mail ID is hacked, one mail ID, username or password or some sensitive information is leaked. That is called a so-called hack. But if it is a bigger case, maybe you might be a part of a college or a university, right? So 6,000 usernames and passwords of your university or college is leaked. So that will be tagged as a breach. We call it as a data breach. Humongous amount of sensitive information that have been leaked by so-called XYZ hackers on the internet. We'll be talking about that. Then we'll come back to the foundation part. Ports, protocol, what is a packet? What is security? When someone talks about security, they'll talk about firewall, IDS, IPS. The extended tools will be SIM, XDR. We see about cyber threat landscape, attack vectors, attack maps, and security means passwords. We'll see what is password. Password is one method of authentication. Then we'll see what are all the authentication methods available. When we talk about security, we talk about cryptography, lock and unlock. See, we both are using WhatsApp. I send a message to you, you receive. The message is locked in my WhatsApp, in my Android phone. It is received in your iPhone, in your WhatsApp. It's so-called end-to-end encrypted. So what is the security basics behind that? Cryptographics, fine. Steganography, OWASP top 10. This all after maybe day 3. We'll quickly move on to some technical topics, right? Top 10 attacks, DNS, cyber kill chains, CVE, CVSS scorings. And the last day, hopefully we'll concentrate on the domains. Being a faculty, maybe I was also teaching, I attended quite a good number of FDPs, I've delivered quite a good number of FDPs. The take home for faculties will be, hey, I have a paper, maybe I have 2 or 3 papers at the university, which I need to prove them saying that I can take this paper, take this elective paper in cybersecurity. Or else I'm going to apply for a proposal for a government. So I need to prove them skillful saying that, hey, I know something, I've done some research, I've put some papers, I've taken some courses on cybersecurity, right? So the last day we'll be covering about the domains in cybersecurity, different domains. So participants, if you have any questions, queries, right, we can very well put in the chat box, right? So I've opened my chat box. If you want an answer immediately, you can raise your hand or unmute and speak, right? I'm happy that you can just stop me in between. I hope someone have raised your hand. Yeah. If you have any questions, queries, you can put in the chat box or you can unmute and speak also. Fine. So the next 5 days, 2 into 5, 10 hours, we are just going to walk through from what is cybersecurity till maybe the top 10 domains on cybersecurity, right? So I'll just be sharing my experience, what I was teaching at the university, what we are doing in the industry. It's going to be a hybrid model of just bits and pieces of my experience over a decade on this cybersecurity teaching and consulting. So before we start with the main topic, right? So today is day 1. So we have got some 8 slots, 8 15-minute slots, right? So we'll be talking about the first 8 topics for today. If you want, I'll just show you the same, right? Starting from slot 1 to slot 8, we'll be covering today. Network devices, IP and subnet, network topologies, Linux basics, Windows basics, file permissions, and Sysinternals Suite, right? Typically covering the foundation of what is needed for a cybersecurity. You see, like whenever a student goes to an interview for cybersecurity, information security, or anything related to network security, the common questions will be asked, right? You know, at the university, we teach students, we train them for getting some good marks or getting passed at least, right? So we just train them for, hey, attend this 2 8 marks or attend this 10 16 marks, something like that. We'll just give them some scope on attending the questions, right? So we don't want to give them a 2-mark definition, right? At the industry, what we expect is like someone says, sir, I know a network is connected. We'll just say, hey, I'm just giving you a file, send the file from this system to this system. If you're able to send it successfully, okay, we'll move on to the next round of interview, right? Currently, interviews are happening like that. No more traditional methods of interview, tell about yourself, GDs and on. That's a part of interviews, right? But in cyber, trending areas like cybers, you talk about AI, you talk about data science. It's all about practical things. You know a concept, well and good. We don't want you to memorize and repeat. If you know the concept, let me know your understanding. What is network? What is cryptography? That is fine. Then we'll ask about like what is your exposure. Fine. So we'll quickly walk through. We'll start with the first topic. Network fundamentals, right? I believe all the faculties here, majority might be computer science major. Some mixed ECE, EEE or some other majors may be there. So for the matter of fact of understanding of everyone, I'm just starting from the scratch, right? So we know networking. Before networking, there's a concept called computer hardware, right? I've not touched on that. Sir, maybe even when I teach my students, they'll ask, sir, why I need to know about hardware? I'm going to go for a hardcore cybersecurity job. Why you are teaching me RAM, hard disk, these sort of devices, right? Nowadays, attacks are getting sophisticated, right? No more attacks are going to come as a link. It can come in a pen drive, it can come in a hard disk, it can come in some routines to your motherboard and on. So we need to know how it works. So before networking, there should be some foundation understanding about the hardware, typically computer hardware. Starting from when you type a key A, what happens? The input goes from your input unit to the so-called CPU, then something processed in the RAM, something has been cached in your storage, and something has been displayed on your output unit, right? If an attacker wants to do something in cyber terminologies, the so-called XYZ hackers, right? They will put a tool called keylogger. That's a tool called keylogger. Just a minute. I hope my screen is visible. I'll open it. I'll open a notepad for understanding so that whatever keywords I'm typing. At the end of the session, I hope I'll share this Word document, the PDF document, which I'm just showing you in the background, right? So there is something called as a keylogger. If you are hearing this for the first time, right? Keylogger is a type of a malware, malicious software. In older days, we called it as a virus, right? Which is going to store all the keys which I am typing. For example, if I am typing start button, right? If I'm typing start button and I'm just typing Chrome, I'm opening Chrome, I'm typing gmail.com, then I'm typing abc@gmail.com, then I'm typing password, something like that. Everything, whatever is typed on the keyboard will be stored in a notepad like this, and that will be sent to an attacker. These keyloggers can be of two types, hardware based, what I said. It can be inserted like a pen drive in your system, or else it can be a software keylogger, just like we see yet another virus. Click next, next, finish, right? The keyloggers can be hardware and software based. So that's what I said before. Knowing on to the whole of networking concepts, we need to have the basic understanding about hardware, right? So we'll start with the basic networking concepts. Everyone knows network. So we are here to network. 200, 250 or even greater people are here to network. I'm going to say something, you're going to reply something, you're going to take home, learning something, sharing something. Network among computers, or else in traditional terms, we call it as a www, World Wide Website, right? So all these things are going to be the basics one. So whenever we talk about network, if any one of you had a chance to teach a course at the university or college, computer networks, or some colleges will have cryptography and network security, or network and cryptography, some papers, mixed names in this, right? We'll start teaching them about layers. Here, there is a protocol. If you say protocol, I'm speaking in English, you understand English, that's well and good. We follow a protocol, right? So if I'm talking in my native language, some of you are not able to understand my native language. That's a miscommunication, right? That should not happen on the internet. So internet, you can be from India, you can be from any other country. Everyone using internet will follow the same protocol, right? Protocols, or we call it in the other name as standard. One such global standard is called ISO, International Organization for Standardization. We call it as ISO, even if it is called iOS, right? We call it as ISO. And they have a model, how we can send the data from the sender to receiver. That's a reference model that is called OSI model, Open System Interconnect. The current model which we use is TCP/IP model, right? So anything on the network, want to send a data and receiver data, network is not going to be one-to-one. If it's going to be peered or one-to-one, we can just share the data only within your system. You don't want a network. Network means you're sending a data from a sender to one or multiple receivers, and you're getting it back, connected on the network over wires or wireless, over satellite and on. So we'll just start with this basic ISO OSI TCP/IP reference model. Fine. I remember we had 7 layers, right? ISO OSI layers. TCP/IP reference model will have 4. We'll stick on to the standard ISO OSI model. Fine. So it was so hard. I remember way back 15 years ago. 15 years ago when I did my graduation, BTech, right? It was so hard to remember all the 7 layers in order. There's a 8 mark or something coming in that layer, right? Memorizing something, mugging up, keeping some jargons and on. Those days, like even when we were at college, we might have written it using memorizing or keeping some keywords. But keep in mind, industry wants you to walk through the ISO OSI layers. I don't want you to put a 2 mark on ISO OSI layers. Industry wants you to walk through the ISO OSI layers. You are sending a mail, I am receiving a mail. Each and every layer, we need to say, or a student who is sitting for the interview have to say how the data is going. It can be converted from one format to another format, one standard to another standard. Size can be amplified, size can be reduced, encryption, decryption can be done, encoding, decoding can be done. So that's how it goes on. Fine. So we'll see the basic commands also, basic network commands. So I hope, again, in the interview when we ask, right? So we'll ask a candidate, hey, just get the IP address and MAC address of your computer and let me know what is the make and model. i3 computer is going to have this much RAM. Just say me in a couple of minutes. You give a computer to a candidate, asking him, what is your IP address? What is your MAC address? What is your computer domain name? And say me how much RAM you have in bytes, right? The candidate have some basic skills of command prompt. he or she will be able to answer that, right? I lately had an interview and asking 100 students the same question. Roughly 5 people were able to say, sir, I was able to do this. They just gave the command. So we just took the 5 students for the next set of interview. All the other 95 have put a goodbye. Hey, you can just learn and come back for the next year or the next set of interviews. So basic networking commands or basic Windows commands we need to know. Let me open my command prompt. Okay, I'm zooming in. I hope this level zoom should do good. Okay. So I'm typing something called who am I? It will say, hey, welcome. I have a i3 Dell PC and my computer name is Ashok. As the introduction was given, I work bit and pieces of forensic investigation. In real world terms, we call it as cybercrime or cyber investigations. Don't believe whatever you see. Who am I says, what is the computer name? What is the make and model? As per the output here, it says I'm using a i3 Intel processor and I'm using a Dell computer. Fine. This is the first command. So let me type another command, system info. Fine. This command will clearly say, that's what we talked about, the connection between hardware and network. This command from my OS will go to my hardware and fetch the information. Hey, who's the manufacturer, who's the make and model and everything. Let's walk through what is the result. The result says host name is i3 Dell PC. That's how I renamed it. That's well and good. I have a Windows 10 Pro. Fine. Let's walk down. Registered organization is HP. It clearly says, hey, I'm using a HP laptop. Really, I'm using a HP laptop. Fine. And I'm using a AMD processor. Right. AMD is exactly a competitor for Intel. You know, AMD Ryzen 5 is the processor which I'm using. So what I've done, I've just gone to my command prompt. Intentionally, I've just changed my identity. Just like changing your photo or name on your ID card. Right. I've just changed this. So in cybersecurity, in investigation, or anywhere on cyber industry, do not see whatever you believe. Right? With the who am I command, if you are doing an investigation, your report will have, hey, the victim or the attacker is using an i3 Dell PC. If you are able to give this command, the system info command, and really find what is the actual processor, what is the actual OS, what is the actual make and model, you'll be able to get the details. So the general thing, whatever you see on the window, whatever even I teach, right? You don't blankly believe on that. You practice it, check it, and then you just move forward because you are going to teach quite a good number of students. They are going to sit for the interview. Fine. So just let me clear the screen. CLS. Okay, CLS is a screen clearing the Windows screen. Fine. So I'm just starting with the basic networking, IP CON IP config. The command will let you know, hey, how I'm connected to the internet now using my laptop. Fine. It's going to give a lengthy description. I'm interested in it. I'm not connected over Ethernet. Ethernet is a wired connection. I've connected to my Wi-Fi. Let me check. Okay, I've connected to my Wi-Fi. And I'm having an IP. If you're seeing this lengthy number for the first time, don't get panic. This is an IPv6, right? 128-bit version 6 IP. On my local area network, I'm having an IP called 192.168.1.20. So this is my IP address, and I've connected to a router. I have it in the office, Apple router or BSNL, right? So the router is having this IP. So any connections from my computer will go via my identity, like my name and roll number. Sorry. So my IP is my unique identity. We call it as a virtual address in computers. 192.168.1.20. This is my IP. And I'm connecting to the internet via a gateway. This router sitting at my office, 192.168.1.1 is giving me the internet. And in between, there's a concept called subnet. We'll be discussing it maybe when you're going in depth on networking, right? So my IP, when I type IP config, it shows me IP version 6, IP version 4. What is the default gateway? Fine. If I want to go further, like I'll just go to the same command IP config /all. It's going to be a bit descriptive, a bit lengthy, right? It will show me what is my IP address. Fine, well and good. It's also going to let me know something called as a MAC address. So just a minute, let me type it here. Computers or networking devices are identified using IP address, right? IP address, and there is something called MAC address. In layman term, if you want to explain, we'll say like this is my name and roll number. Have anyone felt like, hey, you're working at the college, you have students at the college, name is unique, roll numbers is yet another unique. What is the need for name and roll number both? Someone asks a question, we'll have a justification. Hey, name is used for these identities. Roll number is used for these identities. Even they are two unique identities for the same person, they are meant for a purpose. Same way in computers or over the networks, IP address is a number. Let's say if I'm connected on the internet, my 192.168.1.20. This is my IP address, right? This is, if I'm not wrong, IPv4 is 32-bit address, right? Fine. 128 divided by 8, 32, fine. So this is called IP address. We call it as virtual address. Okay. There is something called MAC address. We call it as a physical address. So in computer terminologies, if you got a chance to teach paper on computer organization, computer foundation, or Syllabus CATS operating systems, right? Anything when we address something in computers, we address it in two formats. Something that is available physical, something that is virtual, right? For example, you have a pen drive. Physically, you call it as a 2 GB pen drive, but virtually, it can store only 1.9 GB of data. There will be a difference between physical and virtual. Anyone teaching operating system might know the difference between paging, segmentation, and on, right? So in computers, networks, the virtual address is called IP address. It can be IPv4 or IPv6. It can be IPv4 or IPv6, right? So if I'm not wrong, IPv4 should be 32-bit address. IPv6 should be 128-bit address. Fine. And another identity is called MAC address. For your understanding, I'll split it into 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 6. Okay. So you see here, each one is called as an octet. OCTET. Octet means 8, right? So we have how many 8s? 1, 2, 3, 4, 5, 6. So 8 into 6. If I'm not wrong, it's going to be 48. So 48-bit address. So we're just, let me maximize. So we are going to have a 48-bit MAC address, either 32-bit or 128-bit IP address. The most common question asked in any interview for a candidate claiming that, hey, I know cybersecurity, give me a job in cybersecurity. Define IP address, define MAC address. That's out of the box. We ask at the university for grading and things. Industry will ask something like this. Yeah, someone have raised your hand. Yeah, if you have any queries, you can ask in the chat box. If you have an options to unmute, you can unmute and speak. Mr. Venkata Varma. I'm not able to see anything in the chat box. Okay, fine. We'll continue. If you have questions, you can unmute and speak, or you can put in the chat box. So that's the main difference between IP address and MAC address. The most common foundation any candidate should have when they go for a cybersecurity interview. Okay. So we are in this ipconfig command, right? So the command used for checking IP. Fine. There is another command called ping, P-I-N-G. It's a connectivity checking protocol. I want to check whether there's a connection between me and www.google.com. Fine. It says, hey, welcome, google.com is hosted in this page. If you're seeing this, this is an IPv4 of google.com. It's going to be sent, it sends 4 packet. The protocol is ping. The technology involved here, or the yet another protocol, is ICMP, right? So what I'm doing, I'm trying to do a ping for connectivity check. Ping follows a protocol ICMP protocol. As per the protocol, it will send 4 packets. The 4 packets are received, right? It will say, hey, there's a connectivity. That's what it's doing. Reply from packet number 1, 2, 3, and 4. Fine. So I'm trying to ping something different, right? Let me check. Instead of google.com, I'll type google.com. It says, hey, welcome. You're trying to find a website. This website does not exist on the internet. Or at least in my domain or subdomain, I'm not able to find this website. It clearly says I'm not able to ping. If I'm asking a person, you have a student, 50 students in your class, you know their names, you're calling someone who doesn't belong to this class. They may be a part of other class. You call someone in their names, what the students will do? No one will reply. That candidate you're searching is not available in that class. Same way, right? So you need to ping a website or an IP. For example, I'm pinging 127.0.0.1. It's an IP of my network card. We call it a home address in cyber, right? So I'm checking my network card, wireless card has this home IP. So I'm getting a reply. It's a proof of concept. Because of this network connected using my network address, I'll connect it to use my Wi-Fi over Airtel over Zoom. That's how we are connected. Fine. So ping is a connectivity checking protocol to check the connection between the sender and the receiver, right? Okay, there is another command called nslookup. Whatever I'm showing now are the top 10 Windows commands. Any candidate who claims to know cyber need to know this, or else we need to teach them. We need to teach students about this is the command, how it works. We call it as a syntax. You give nslookup is a syntax, space, you give a parameter. For example, I'm typing www.amrita.edu, maybe an university ID. It clearly says, hey, welcome. The university has an address, maybe a IPv6 address that is hosted on a public IP, a couple of public IPs, IPv4, right? So nslookup is a command to change the name of this domain, right? For example, I know this domain. Amrita.edu is the domain name. Computer or devices on the internet knows only IP address. See, we might have taught to students saying about human readable language, machine readable language, right? Same way, I know ABC, domain.com. Computer knows IP address, right? So there will be a translation between this domain name and this IP address. In layman terms, you take an example of your contacts. You have your contacts in your mobile. You have 2000 contacts. You know all the 2000 names. If you have been collecting for the past 15-20 years, you might remember all the 2000 names, but you might not remember all the 2000 phone numbers, right? But when you search something on the things for your name, there will be a corresponding phone number listed, right? The same thing happens on the internet, right? This concept that is happening on the internet or the protocol is called DNS, the most common protocol everyone knows, corresponding to port number 53. We'll talk about ports later for an understanding I'm typing, right? DNS, domain name system, fine. So the purpose of DNS is to convert whatever human readable domain names you're typing to go search on the internet and get you the corresponding IP where the website or the server is hosted. So that is called DNS. There's a concept called reverse DNS, right? There's a concept called reverse DNS in which I'll give the IP. It will go and search for the domain which is hosted on the IP, right? All of the internet works based upon this concept called DNS, right? If I'm giving this IP, it will start from the back to front, right? So it will search what is the top level domain, edu. There will be a registry, imagine like a telephone book or a yellow pages book or your mobile contacts listed on every state, every city, every country or every continent on the hierarchy. That list will have, hey, I have a list of edu websites. If you want to find edu websites in India, there will be a domain registry, will have all edu websites in India. Inside that, I'm searching for a website on this name, okay? It will search for the website in that specific name and later it will go back to the hosting provider. You might have put, see, you live in a house, you pay rent for the house. Same way, website should be hosted in some place. So there will be a place on the internet, right? You get some storage and host a website there, right? So that's a concept of DNS, fine. Okay. So that is on this. Now let me take you to a command called NET, netstat is the command. As the name goes, it is going to let me know what are the active connection going in and out of my computer now, fine. So that's what this is going to say. Netstat will say, I'll put some parameters, -ANO. Each one will have a meaning, unique meaning. I'm typing enter. It's pretty loading fast. It's done. It's a one-time reply, right? So this is replying to me. I'll zoom out, right? Zoom out a bit. Okay, see, this is replying to me saying that these are all the connections going in and out of my computer. So let me take, for example, I'm not sure to which IP Zoom is connected. For your understanding, I will take this number or this row. Fine. The connection is TCP, everyone knows. TCP is a connection-oriented protocol. After three-way handshake, the connection is set. My computer, local computer, you saw it in IP config. My IP is 192.168.1.20 and it is connected to Zoom. Let us assume it is hosted on a public IP and it is connected to 443. When we talk about this, just a minute. Everyone knows HTTP, Hypertext Transfer Protocol, normally operates on port number 80, right? Sometimes 80, sometimes 8000 on proxy or 8080. 80 is most common, right? 80 is the most common port of HTTP. Then we talk about the so-called secure connection, HTTPS. I don't call it completely secure, we call it so-called secure, right? 443, right? So that's what you're able to see here. See, from my local computer, 80 is not here because it's a random port. The sender will have a random port. From my computer, from a port to the receiver's computer to a port, a connection is established. We have a process ID. The process ID is listed here, and the connection is a TCP connection. Fine. So now what it have done, this netstat, as the name goes, it is network statistics. That's what is abbreviated as netstat, right? What is the protocol? What is the local address? You see my local IP address and port number. What is the foreign address? To which website on the internet or outside I am connecting? What is the state? It's listening, established, closed, wait, whatever it may be. Process ID. Computers, operating system we call process thread. So each process is unique. See, if I'm finding a virus process, number 1832, I'll go and kill the virus process, right? Same way. So when you establish a connection over the network, what all the things that are involved? There's a protocol involved. There's a local address and local port, foreign address and foreign port. There's a state of the connection. There is a process ID involved. So that is to bring that out, right? We use a command called netstat-ano. These parameters are there, right? If you want to give netstat/h, it will let me know the help file. Why I have given A? A is to display all connections and listening port, okay? N is to display all address and port numbers in numerical form, okay? O is to display the owning process ID. Fine. Got it. This is about netstat. And we saw ping. Ping is a connectivity checking protocol. There is something called ARP, Address Resolution Protocol, -A. It will just give us a combo of whatever we are discussing now. The unique ID, your name and roll number, right? Same way IP address and MAC address. So it's saying that, hey, you're connected over an interface. This is my wire. May I have a virtual machine? There is a virtual interface. Leave this. Interface in protocol is a connection. It's a bridge between the sender and the receiver. I am having a wireless interface. The interface is having an IP address. It is connected in my local network. Let's say this is my Apple router, the router's MAC address. This is my mobile device MAC address. This is my employee or colleague sitting in another room, their computer IP, their computer MAC address. And you leave these numbers. If you study a course on networking, CCNA or network advanced courses, they'll talk about this reserved IPs. It's not like reserved. Every bus will have a driver and conductor for a purpose, right? Same way you don't talk about this 224 IPs. Whatever is given here on this first is the usable. So in my network currently 4 devices are connected. One is my router, second one is this laptop, my mobile, and another laptop in the next room. Fine. So to find this, we do something called ARP. ARP-A, right? So even if you are not doing anything on the network, every device connected on the network will regularly send the ARP packet on the network. You see, like you have a contact, your friend gives you a contact, you add the contact. You have a contact, you change the name and number of the contact. You need to update it, right? And everyone knows we use something like Truecaller, right? So how they operate? When you sign in, they get permissions for your name and contact, and they keep it in a common registry. Whenever you change a name, whenever you change a number, it will be updated to the registry. So any new person calls, that person is not in your list. That person might be in someone else's mobile's list. It will show the recommendation, the name recommendation. So and so calling from this city or this company or this college, right? Same way, ARP is a small table. Imagine like your contacts table, right? In every device, in your mobile it will be there, in your switch it will be there, in your router it will be there, in your computer it will be there. That is going to maintain What is my IP address? What is my MAC address? What are the devices connected to me now? What are their IP address and MAC address? In regular intervals, you take it like every 10 seconds, every 30 seconds, depending upon the protocol, the devices, the OS which you use. This will be updated every now and then, right? So that is called ARP-A, Address Resolution Protocol, right? It's going to list the local address or else your virtual address, that is called your IP. Okay, your IP address, then your physical address, that is your MAC address, right? Okay. So host name, you remember like we started with this. Host name will say, yeah, I3DLPC. You remember we started with this conversation. I've intentionally renamed my system with a different name and different processor to confuse someone who wants to identify me. Fine. Okay. So then get MAC, we are talking about IP address and MAC address. I've not shown you what is MAC address, right? Get MAC in any Windows computer will list you the MAC addresses available. Let me check. Down. I've given you an intro. What is a MAC address? Let's go back and check that. This is a MAC address. Okay, MAC is an octet. It is going to have 8 into 6, 48 bits. Let's check. 1, 2, 3, 4, 5, 6. 6 into 8, 48. Fine. Okay. So this is my MAC address. So 1, 2, 3. Let me take this MAC address. I'm selecting that. When I click on enter, it will automatically copy. I have copied that. Let me go back to the browser. Fine. I'm typing MAC address identifier. Fine. Okay, MAC address vendors. That's a website. There are many websites online. When you give the MAC address, it will say whom it belongs to. Let's say like you are giving my roll number. If I'm not wrong, I'll give you an example. My roll number at the university when I was doing my master's was CBN P2 CYS 12007. Yeah. See, this was my roll number at the university when I did my master's in 2012, 12 to 14, right? Okay. So this first part says, right, which is the campus, Coimbatore campus, Etimadai. And P2, it's a 2 years master's degree course. And this is my department, cybersecurity, and this is my roll number. So anyone who's working at the university or a college will be able to decode this. On seeing the roll number, you can say which candidate and from where they belong to. Same way, when we talk about something like a MAC address, as you see here, a 48-bit MAC address, you can get the MAC address, go online and check for MAC address vendors, put it there, search. It says, hey, welcome, Chongfeng Electronics Co. Limited. When I type it, right, it goes to a vendor who have manufactured that chip, right? I'm using a HP laptop. HP laptop is using this device, network card, and the network card is having this MAC address. Fine. So if you want to try something different, I have a couple of MAC address, 55 and 56. One is disconnected. Maybe this might be my wired. I'm not connected over wired. It is the same from same manufacturer. But you see here, the first three, 74, 123, B3 will be the same. Now in my case, the second is also same, right? Let me copy this. Let me paste it here. Let's paste it here. Yeah, where we are discussing about MAC address. So when you talk about MAC address, we split it into two. The first part will say like who's the owner of the MAC address, the manufacturer, right? Second part will say the serial number, right? Fine. MAC address is hexadecimal, right? So it's going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Right? It's going to have any of these values. Let's check. See, it's going to 74, 1, 2, B, C. It won't go above F, right? So in this, the first three octets will say owner. This is manufactured by a Chinese chip that belongs to HP, right? It belongs to the thing, it's HP. My serial number, unique serial number of my network MAC address device is this one. So the second one, let's check. I've got a laptop with two MAC addresses. Maybe one is wired and wireless. I have connected to you over my wireless connection. So if I'm not wrong, this might be my Wi-Fi. And this might be my Ethernet, ETH0. That is, we call it as wired connection. Right? They're having the consecutive serial numbers, right? Just like I talk about a serial number, my serial number is 12007. My other person will have 12008. There was many serial numbers available, right? There were, I remember, 12032. 32 candidates were there. If I put 12033, university will say, hey, there was no candidate. It's an invalid, right? Same way, if you're giving an invalid MAC address in any website, let's check. Instead of this, I'm typing something like, instead of 1, I put an F and change. It clearly says not found. Hey, you're trying to type something random, right? That MAC address is not found, right? Yeah. So that is the understanding about MAC addresses. System info, you remember we have seen earlier itself. What is system info? So these commands 1, 2, 3, 4, 5, 6, 7, 8, maybe another 2. The top 10 commands, I've taken the top 8. Fine. Okay. So these are the basics. Whenever a candidate claims that they know cybersecurity, they know networking, they know how to connect between one Windows to another Windows, they should know how to troubleshoot. A virus comes, an infection comes. These are the basic things like a first aid or health checkup sort of things, right? So these basic Windows commands we need to know. Quickly, we'll see the Linux commands. After checking onto the ISO part, we'll check some basic Linux commands that every candidate has to know. Right? Okay, we'll walk through something on this, the interesting part. Fine. So everyone knows, right? Everyone might have taught, those who have taught some computer networks paper. ISO SLAS, right? Layer 1 to 7, that is bottom up. Physical, data link, network, transport, session, presentation, application. If you talk top down, application to physical, right? So each layer has some protocols, n number of protocols. They will follow a standard, right? So the data will be transferred or hand off from one layer to the other layer. I'm opening my mail, I'm typing a mail, sending it to you. In my computer, there will be an application layer, there will be a till physical layer. In your computer, you are the receiver. You will have a physical layer in which the data comes in, and it will be displayed on your application layer. So center side, application to physical. The receiver side, it will be physical to application, right? So that's how it works in the model, right? To make it a bit descriptive or a bit clear, right? I have opened a tool called Wireshark. It's a network monitoring tool. I am selecting my Wi-Fi and I'm click on start. I'm capturing the packets. In network terminologies, you might have heard of packet, right? So you see here, it started populating. You see the packets are on the rise. 3000, 4000. See, I'm just connected over Zoom here. I've not done any other connections. But you can see UDP, TCP, ARP, different packets will be going here. Fine, let me stop it for a while. I've stopped it. TCP packets will be more descriptive. So I'm taking a TCP packet. Fine. And we'll understand ISO SLAS. And if I'm not wrong, right? I just recommend you to teach to your students about network ISO SLAS using this tool and the diagram which we regularly teach at the university, the 7 layers tools, hand in hand, parallel. Fine. So let's assume I've sent a mail in application layer. Let me zoom in. We'll initially see what is there on each layers. Fine. See, I have a browser, laptop, browser, Google Chrome, open gmail.com and type login. Fine. So the first layer, the top layer, application layer will say, hey, what the user is going to do, like the end user thing, right? You see the protocols that is named DNS, WW, HTTP, P2P, email, SMTP, fine. So that's the first layer. I want to send a mail to you. I'm opening my browser and started typing the mail. Fine. The next layer will do, that's not the work of the browser to take it to the sender and deliver it. Browser will do whatever you type and it will send off. It's a handoff to the next layer. The next layer is called presentation layer, right? It manages data representation and encryption. Let us say I'm using a Gmail. I'm not allowed to attach a exe file in Gmail. You see, 10-15 years ago, we can attach it. But lately, when they increase their policies on security and all, they restricted attaching a .exe executable file, the most common file a virus comes in, right? And all Windows uses executable files, right? So Gmail blocks exe files. When you try to attach an exe file, Gmail says, hey, wait, I don't allow you to just put this email file in the attachment. The second layer is called presentation. Presentation layer will decide the data representation. What data has to be there, what is allowed, what is not allowed. Either Gmail is allowing, your operating system is not allowing, your application is not allowing, right? So that is data representation. It also follows encryption, decryption, encoding, decoding. We call it as the whole of family of the data representation. We call it as MIME, M-I-M-E, right? So MIME is all about HTML, doc, JPEG, MP3, all file formats, right? So you write a mail, you check what to be added, what not to be added. You do encryption, decryption, encoding, decoding. That's on the second layer, presentation layer. Next layer is a session layer. It's not an actual session. It's a virtual session. There should be a connection between sender and the receiver. Then only the data can go, right? So it's not a continuous connection. It's not a physical connection. It's going to be a bits and pieces of virtual connection. Between the sender sending the mail, between the receiver receiving the mail, there should be a connection at some point of time so that the mail travels from the sender over the network and gets delivered onto the receiver. So session layer, we can imagine it to a movie ticket. What will be there in a movie ticket? Nowadays, we started putting movie tickets online, right? You get it in an SMS or a screenshot or an app message, right? What it is, we have a printed tickets. The tickets will have the theater name, the show, the timing, validity, something, right? Same way the session will say, what is the session, between whom the session is established, what is the validity of the session, any other parameters for the session, right? So the most common session protocol or SIP, session initiation protocol. When you take a traditional course like Cisco course, CCNA or something, right? You get to learn all these things. SIP protocol, RTP protocol, different protocols which facilitates the connections between the sender and the receiver. Fine. So that is on the session layer. Fine. After session layer, we talk about transport layer, right? The most common are TCP and UDP. And I remember way back 15 years ago when I started studying this, TCP means connection oriented. UDP means connectionless. I gave an example of TCP as wired connection, UDP as wireless connection. I got only 1 mark for the 2 mark because the second point was wrong. TCP is not fully wired, UDP is not fully wireless. TCP is connection oriented because it establishes a 3-way handshake, SYN-SYNAC ACK. UDP is connectionless because it doesn't have a handshake. It just throws the packet on the internet. Fine. So in transport layer, you'll be relying on the connections between the sender and the receiver. You might have seen this in the command which we typed earlier. Maybe in this command. Right. Netstat -ANO command. We have seen this. See, the connection is TCP. Now it is UDP. So many TCP and UDP connections are going in and out of my computer now. Fine. So that is on this transport layer. Next comes the network layer. In computer networks, we talk about packets, right? IP packet, ARP packet, ICMP packet. Just before some time we saw ICMP, right? Ping uses ICMP packet. We saw about ARP packet. We saw about IP config, IP packets, right? So network is between the devices talking. One networking device will talk to other networking device with the help of IP address, something the logical address so unique on the network layer. But that is not enough to complete the connection. We need to move further down to a layer called data link layer, where the IP address in conjugation with a MAC address. We say name and roll number. Same way your IP address and MAC address, both combined will create a connection established between the sender and the receiver. The final layer is obviously the physical layer. Zeros and ones, bits and bytes. The data goes on the wire, data goes on the Wi-Fi. You see at the bottom we use RJ45. So the RJ45 is the normal network card we use in colleges or companies or computers. Fine. So 802.11 is IEEE protocol. If you have got a chance to read about it, right? 802.11 is an IEEE protocol used for wireless connection. 802.11.5 is for, or 15 is for Bluetooth. Fine. So 802.11 is a networking standard. RJ45 is a physical standard for connecting devices. So I send an email in my application. The email attachments, encoding and everything is done in the presentation layer. A session is initiated from my side in session layer. It will choose which transport layer, TCP or UDP in this layer. It will choose which IP to use in this layer. It will choose which MAC address to use in this layer. Finally, it goes out of my computer. It travels all the internet in all the devices in between. It comes to you. You are the receiver. You are sitting in the US. Your computer will have a physical address, wired or Wi-Fi. Data comes in. Your computer will have a MAC address. It is recognized there. Your computer will have an IP address. It's recognized there. Your computer will say whether it's a TCP or UDP. Fine. Your computer will get a session, a virtual session between you and me. A virtual session is established. If the session is active only, the connection, if this session is active only, the whole of the connection will be active. So if the session is active, so you have received my mail, fine, well and good. In presentation, you are opening it in your Gmail. It says, hey, the sender have attached a JPEG image. So you can open that image. And finally, on your browser, on your Gmail, the mail is displayed. Just like a fraction of a second, I send a mail, you receive a mail, maybe not less than a few seconds. This is how it works on the ISO-OSI layers. We teach what is application layer, give an example of a protocol. Fine, that's well and good for a 2 mark, an understanding of what is this networking layer. But keep in mind, either you or your students who want to get into cybersecurity profession, come into industry or do some R&Ds, right? So this is going to be the foundation. You need to clearly know what happens in these 7 ISO-OSI layers. So we'll just walk through the tool which I opened, a Wireshark, a network monitoring tool. I'm taking a packet, an exclusive packet. Just a minute. For your understanding, I'm opening a magnifier so that it will be easy. I'll zoom in a bit. Okay, this should do 200, should do. Okay, fine. We are going to take a packet called 11,862. Time is 22 seconds. The packet came in. Source IP address is there. Destination IP address is there. It's a TCP packet. Packet length is 56. It is coming from my port number 7498 to your port number 443. If the packet is having acknowledgement, a sequence number is there. Acknowledgement for the previous is there. Window size is there. Length is there. This is a packet. So I'll come down the tool. And whatever you see here on the bottom, 1, 2, 3, 4. This is the extended version of ISO-OSI, the TCP IP reference model, right? The 7 layers is split into 4 categories, right? So now let us walk through how it works. So the first layer is the application layer, right? So let's see what's there in the application layer. Okay, no, we'll go bottom up. That will be interesting. That's how it works. Physical layer, the data is there, right? So let me check what is the physical layer data. Each layer will have a protocol. Each protocol will follow a standard. Each standard will have different naming conventions, right? So the same data you have sent, the same email you have sent, in each and every layer, we call it as a PDU, protocol data unit. In each and every layer, this data, the so-called zeros and ones, bits and bytes, the data you send, will have a different naming convention. So on the last layer, the physical layer, the naming convention is called frames, right? Frame number 11,862, 56 bytes of data went in, 56 into 8, 448 bits, right? So how it went via the physical interface or the encapsulation, the time when it came, see it's showing the current time, maybe 4:21 when the packet was captured, fine. So that will be there on the first layer, just like you see on the physical layer, right? The second layer is data link layer corresponding to MAC address. The second layer will have this one, Ethernet, fine. Source address, if you can correlate this, just a minute, let me zoom a bit. Okay, if you can correlate this with what we have seen before in the command prompt. We have seen the command prompt, right? Get MAC address. You see, the source, the sender's MAC address is this 7890 A2 EA 8D DA, fine. The destination MAC address is Chong Quing Fu. You remember this? This is my computer's MAC address, the HP MAC address, right? This is my MAC address, 55 ending it with this. So this packet is sent from someone else MAC address, some devices on the network, it will show the adjacent device, right, to the receiver's MAC address, sender and receiver. And keep in mind, when we talk about networking devices, this is not, the sender's MAC address is not going to be the MAC address of the end user. Networking devices communicate to the neighbor device only. So when we communicate on the network, each and every layer, application layer, another data is added over presentation layer, another data over session layer, another data over transport layer, another over data link, another over physical, like a bulge one. Then in the receiver side, physical is removed, data link is removed, network is removed, transport is removed. Likewise, you peel the layer of the onion, it will be removed. Fine. So you see on the first layer, frames, bits and bytes, data is there. Second layer, Ethernet. Yeah. Second layer is the physical layer. Sorry, second layer is the data link layer. In data link layer, we have this sender's MAC address, receiver's MAC address. Fine. Third layer is network layer. Hopefully, it should have an IP address. Let us check. Internet Protocol v4, that's a layer. Source IP address 170.114.110.52. Destination IP address 192.168.1.20. Here I am the destination. I've got a packet from a source on the internet. IP version 4. I have something like a flag. You keep this in mind. Flag. Reserved is 0. Set to 0. Offset is empty. So this flag we'll be discussing in the upcoming classes. Attackers use this flag to do some attack. So-called XYZ cybercrimes or so-called XYZ hacks, right? Attacker used to manipulate IP headers. They modify the flags so that they can do some attacks, right? Keep this in mind. We'll discuss when we are talking about flags. So that is about the third layer. Frames, first layer, physical layer. Second layer from the bottom, data link layer, Ethernet address. Third layer from the bottom, IP layer, IPv4 or IPv6, here IPv4. Then we have the top layers. Let's check who are they. Transport, that is TCP and UDP. Session, presentation and application. All these things will be clubbed together. And in packet we call it a payload. This is my whole payload. Payload says TCP. That what's the layer? Transport layer, right? TCP protocol, fine. Then it will say source port is port number 443. Destination port is 749. These are all not the logical ports. Fine. Just a minute. Before we get deep into ports, we'll be seeing that anyhow. I'll just save here. PORTS. Computers operates everything in zeros and ones, right? Either in terms of binary 0 or 1. 2 power 0. So 2 power 0. 2 power 1. 2 power 2, it goes on like that, right? So there is a value for 2 power some x. The number corresponds to 65536. In computer, we treat it with starting 0. So 0 to 65535. This many number of ports are available in any device. It can be computer or network or mobile or whatever it may be. 0 to 1023. The first 1024 ports are called well-known ports. You know your receiver. Right? So whenever you send the data to a receiver, you select the well-known ports from them. I am sending a file over FTP to you. I select the port number 21. I am sending a HTTP to you. I will select the port number 80. I am selecting HTTPS, the so-called secure protocol. I will select the port number 443. I am sending a DNS request. I will select port number 53. I am receiving the mail. I am sending a mail, SMTP. There are different IPs for mail addresses. I am typing the common IPs. Sorry, there are different port numbers for IPs. Mail addresses, SMTP. By default, they follow 25. The sender, POP3, the receiver of the mail will follow 110. Right? So these are the well-known ports within 1024. Right? So then 1024 to the X values will be the random ports. Fine. So this is about ports. A computer or any device will have this many number of ports, virtual connections. Imagine like a window. Your computer is having 65,000 windows to open. That's what a security device firewall will do. They will close all the ports and keep. They don't want the attacker to peep in or jump in, right? Yeah. We'll zoom in here. So TCP protocol, port number 443, that is my sender, the sender's computer port, and the receiver, my port number is 7498. I have a sequence number, acknowledgement number, like you send many things. Packet will have a sequence number, acknowledgement number, and all. So that will be available here. And you see whole of the details. You see in the flag, finish, SYN, reset, push, acknowledgement, urgent. I mentioned about the flags, right? These are all the flags with which the attacker will play to steal some data, do some XYZ cyber attacks. Right? So to teach someone about network basics, typically the network foundation, we need to walk them through what is ISO ASA, just like you see on this PDF, right? All the 7 layers, that's well and good, fine. But we need to walk them, not by definition. What is that layer? What is the purpose of that? Give an example of a protocol and say how it works in real world. We can just clearly map it within Wireshark. So if I'm taking another packet, 17142, right? You see this packet is from 170 to 192. I take the other packet from 180 to 170. See, it's a UDP packet. It's not a TCP packet. It won't have much of data here. The UDP packet will have only port numbers, sender and receiver. If you have taught a course on networks, TCP is connection oriented, UDP is connectionless. That will be clearly seen here. Why it is UDP, why it is broadcasting all the packets, why it is TCP, why it is sending from one device to another device with unique identifier based upon IP address or MAC address or port numbers and all. Fine. Okay. Let's get back to the PDF. Okay, meanwhile, I've just covered one major part of this session. Basics of network, basic commands, and ISO ASLIS. Till now, if anyone have a question query, I'm happy to answer. There is something populated on the chat box. Let me check. Okay, some instructions from the organizers. Fine, that's good. So is it good to go? Any questions, queries till now? Because this is going to be the strong foundation. Maybe in day 2, day 3, day 4, we'll be talking about attack, defense, and on. Every now and then I'll talk about MAC address, IP port, protocol. So obviously you need to know what is this, how it works. Fine. Any questions, queries on this? If there is a no, at least you can put a N in the chat box so that we can continue. I believe everyone is active. Or if you have any questions, you can also type in the chat box or unmute and speak. So the basics, the first part which we are going to cover on today is cybersecurity foundation, network and network security. We're not touching on network security, but the basic networking, right? So we need to know computer host name, IP address, MAC address, the NS lookup, the ports and protocols, these ISO ASLIS, right? So this is going to be the foundation on the first line. Okay, anyway, as I said, I will share you this document. Fine. The team have curated some websites that works on live. You can check on to that. Fine. Okay, now we'll move on to the next concept. Okay, we have talked about networking. Everyone knows. So you have talked about the standard ISO, OSA, TCP, IP models from the sender to the receiver, how the data goes, how this is facilitated, right? How it works. Fine. So networking devices, fine. If you ask individual to talk about a networking device, I regularly ask in some interviews, right? Hey, give me some example network devices. Students will say, sir, switches, routers, hub are in the order, router, switches, and hub. So all are networking devices. Then what's the purpose of this, right? So there's a router available on the gateway level. There's a switch available, maybe on the building level. There's a hub. Nowadays, we don't use hubs, right? There's a hub available on individual level, right? So routers, switches, that's what I said, hub is not mentioned here. Routers, you imagine it like a 4-way. Hope everyone lives in some city. We have a 4-way. You go and stand on the center. You come from road number 1. There will be 3 other roads, right? Imagine, right? There will be 3 other roads. You are coming from road 1, either you need to move left, right, or straight. You have 3 possibilities. Let's assume, see, there's a police standing there. You want to say, hey, I want to go to Chennai, I want to go to Mumbai, or I want to go to Calcutta, right? They will redirect you. Hey, this route takes you to Mumbai. This route takes you to Chennai, right? Same way in networking, either it can be within the network. Mostly we don't use multiple routers within the network. Routers are to communicate between different networks. We use it on the internet. So imagine router like a four-way. So you go and stand from one interface or one road. You ask which one to go next, right? You talk in terms of IP address and MAC address. You ask about which IP you want to go, which MAC address you want to go, right? And keep in mind, IP address, IPv4, IPv6, MAC address, as I said, like your name and roll number. IP is unique, MAC is also unique. Each one will have a purpose. If you go in depth, right? So obviously it will get converted to a traditional CCNA course. But there are lots of things to discuss on the foundation of IP and MAC address. But whatever you have seen till now about IP and MAC is more than enough for understanding the upcoming cyber concepts. Right? So router is a networking device that's available on the gateway. To come in one interface, we call this interface is a connectivity. The router might have 4 interfaces. It will let you know which interface you want to go next. Let's say I'm in Madurai, down south in Tamil Nadu, right? I want to travel to Delhi. From Madurai, I go to Coimbatore, I go to Chennai, I go to Hyderabad, I go to, what is the next stop? Maybe directly to Delhi. Fine. So each and every place, imagine there's a router. A router will say which direction you want to go, right? Switches, imagine I want to go from one street to other street. I'm in this street number 1. I want to go to my city, another street. I search between the roads within my city. That is called switches, right? So switches typically talks with MAC address. Switch will store an ARP table, IP address and MAC address, but they will start, hey, which switch, which port, right? See, let us see some examples. Let me open it live on the internet. Find routers. Routers. Nowadays, routers are becoming fancy. We see some wireless routers, right? Let me check about routers wired. Okay, this is how it works. Fine, router will have an interface. Okay. See, these are the devices. If you're a faculty in your college, at specific places, you'll see a network room. In that network room, you will be seeing devices, something like this, right? Mostly routers and switches, right? For example, routers, network room. You might be like astonished to see some LEDs, right? Amber, orange, sometimes red, blinking on the devices, right? Something a box like this, fine. Yeah, something like this, fine. So these are all called routers. Again, the lightweight version, the downfall version of the routers are switches. Router has a purpose. Wherever you want to use a router, you need to use a router. Switch has a purpose. Wherever you want to use a switch, you need to use a switch, right? So routers, network room, right? Network, switch. Let me take, I want to take a 24 port switch, right? 24 physical ports, right? Fine, just a minute. Let me zoom in, zoom. Okay. So this is a D-Link 24 port gigabit Ethernet switch. 4 into 2, 8. 8 into 2, 16. 16 plus 8, 24. See, 24 ports are there. So what we do? 24 devices on the network can be connected to this. I am connected in port number 1. You are connected in port number 20. I want to send the data from my computer to your computer. So when the protocol exists, when the hardware devices are configured, switches, routers, computers, IPs, MAC, everything is configured in the right way. Data will directly go from my computer to port number 1 on switch. It will identify what is your computer, MAC address and IP address. It will send to the port number 22 or 24, exactly to which device your computer is connected. That's the purpose of switches, right? So let me talk about network router. 4 interface. Maybe default routers will have some 4 interfaces. They are showing mostly wireless routers here. Fine. So let us check on to this. Okay, see here. The router is there. Getting PC1 wants to communicate to PC2. Sorry, 0 wants to communicate to PC1. PC0 goes to the router, asks where is PC1, goes to the another router of the PC1 and goes to PC1. In between, there may be switches and other devices might also be there. Just a minute. Okay, this is the purpose of routers, switches, firewalls, right? We are just slowly migrating to security concepts, right? Firewall is a networking device, yet another device. Nowadays, switches will have a firewall. Switches is integrated with firewall. Router is integrated with firewall. Firewall is going to monitor the traffic, incoming and outgoing traffic based upon some policies or protocols. Let us assume your college has a security. Security will allow someone who is having an ID card. Security will block someone who don't have an ID card, right? And they will take some actions, or else they won't allow them. Because the security have a rule saying that, hey, if there's an ID card, allow. If there's not any ID card, don't allow them. Block them and put them there, right? Same way, firewalls. Firewall can be hardware devices, just like you see a router and switch. Firewalls can be hardware devices. Firewalls can also be software, right? Windows has a Windows firewall. Different vendors, right? Let's check. Like, if you are seeing this for the first time, let's check firewalls companies. There's quite a good number of common companies. You see here an extensive list that's available. Fine. Let me open. Most of your colleges or educational institution might be using any one of these. Fortinet, Cisco, Checkpoint, Juniper, Huawei, Barracuda, Sonic Wall. I remember my previous institution, they were using Sonic Wall firewall, right? So these are all different hardware and software based firewall, right? So what is the purpose of firewall? Let's check on to a 2-mark definition. Monitoring and filtering incoming and outgoing network traffic. Why it is done? To help secure network from unauthorized access. What does it mean? So-called hackers. It doesn't want any unauthorized. Authorization means you have a username, you have a password, you have the permission, you access it, right? So firewalls are the first of a kind of security device. Just a minute. Yeah. Just like your physical security standing in front of your college, right? These firewalls are going to allow and block. For example, I'll give you a small example of a firewall rule. I'm writing a sample rule. Allow any connection from 192.168.1.0/24. Fine. If I'm writing a firewall rule like this, I'm writing a simple rule for understanding. I want to allow any connections coming from this network. I'm not selecting a single IP/24. I'm selecting the whole network. Fine. So if I'm, for example, if I'm typing deny any or all connections that are coming from 10.10.10.0 network/24, and I want to exclusively block the FTP connections, right? You know, right? FTP is for file transfer protocol. Fine. So this so firewalls will be there. Firewall rules will be, it will allow or deny or take some actions based upon the rule. Hard-coded rules, right? That's what firewalls in nowadays are called dumb devices. No more we rely only on firewall for security. After firewall, there is an IDS, there's an IPS, there's a SIM, there's a SOR, there's an UTM. Nowadays, we use so-called XYZ AI-enabled security devices. But firewall is the first and the well-known common security device. Still, we use it in our computers, right? But it's meant for a purpose, right? For basic security, we use firewalls. Fine. Okay. Access points and modems, right? Another networking devices. I have an access point in my office, Apple, for giving internet. It acts as a hybrid modem, you know, modulator, demodulator, right? Access points, wired and wireless. Fine. The generic devices. Okay, this typically looks like an interesting network diagram. Fine. So I'm connected on the internet. You see a broad scale laptop, 3G network, WAN, connected to a router. A router is going on the left, one company, going on the right, maybe another company. They have a firewall. Nowadays, we use extended versions of firewall called NGFW. Next generation firewalls. We'll be seeing this when we are discussing in depth about firewall. For time being, keep in mind, firewall is a network device or a security device. It can be a hardware or a software used for basic security. Firewall is a dumb device or dumb application which can allow, deny based upon permission. Fine. If the student is using I'm not a student of your college, I take a ID card from someone else from your college, I put it, I walk into your college, the security has a general rule, allow anyone who has an ID card, he might not block me. Every day, thousands of students are going in and coming out. If there's an ID card, the security will allow. So the attacker knows clearly how to bypass firewall, right? Basic firewalls, fine. So that is on this networking devices, fine. See, use case, routers connected, routers connect networks, direct data from switch packets, and on, fine. Okay, so all these devices, routers, switches, firewalls, if you use a hub, and everything is used by end user. I have a laptop, I have a mobile, I have a PC, I have a server. We call it as endpoints. You see, whatever is connected at the bottom are endpoints, end devices. Even a printer might be connected on the internet, right? So these are all end devices. These are all networking devices. These are all security devices. Fine. No. So you have a couple of websites, right? We'll check this mininet.org. Okay, website to simulate this virtual environment. Fine. Let's check out the walkthrough. Okay, it's showing the same thing, right? Starting the Wireshark and just copying it and doing it. I remember whatever I showed in the demo, right? So if you're doing it for the first time, you do it step by step. Open the Wireshark, enable it, give the command, check the packets, go on, fine. Same way a couple of other. For every topic, I hope we have listed some reference websites. If you're seeing this topic for the first time, you need to go to the website and check how it works. For example, app GNS3, right? App GNS3.com. As this is a part of an FDP, we have taken mostly, let me check, like some of the domains doesn't work. App GNS3. Yeah, the domain is gns3.com. Fine. See, for every topic, we have given some sample websites that works. Fine. You can just go and check what are the concepts. It will show you how a router works. Sometimes it will allow you to ask you to download and install. Sometimes it may be available live. Okay. We'll quickly refresh whatever you have seen, right? IP address and subnetting. Okay. IPv4, 32-bit address. IPv6, 128-bit address. Again, IPv4 we are using till date. We were using ago, some years ago, right? But IPv6, right? So nowadays, you know, right? I remember a phone number. Let me type. Maybe 10-15 years ago, 20925 was our old phone number in our house, right? After that, they converted to 620925. Fine. Then they converted to 620925. Fine. You see, way back in 2000, it was something like this. Way back in 2005, it was something like this. Way back in 2010, it became like this. 20925, 620925, 26200925. Fine. See different numbers, just an extended versions, right? Same way IP address is also IPv4 was there. 32-bit address, right? If you want, let's Google. 32-bit means it's called value of 2 power 32 is, let's check. 2 power 32, there's a number, you see a lengthy number. Okay. So 2 power 32, IPv4, see the number 42969679296. These many devices can be connected using a 32-bit IP address. Maybe till 2005 or 10, we were using IPv4, right? But lately, after internet got growing, we connected many devices. IPv6 came into existence. That's a study you can go and check in the Wikipedia page. Why IPv5 doesn't come? That's an interesting story behind that, right? So IPv6, currently we are using the current standard after v4 is 128-bit. It's going to be something lengthy like this. We'll see what is 128, right? Again, everything in computer is 2 power something. So 2 power 128 is, you will see a pretty lengthy number. You see here. Even everyone who's available on the internet, you see this number 340, if I'm not followed by 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Yeah. 3.4 into 10 power 38, right? This many number of IPs can be used. Currently, we are using IPv6. There's a tunneling between IPv4 and IPv6 on the internet. If you are using an IPv4 in your system, it may go to your college network using another IPv4. But if it goes to Airtel or BSNL on the next level, they may be using an IPv6. There's a protocol to tunnel between IPv4 and IPv6 on the internet. It exists. So only there is not much transparent. We are not able to see IPv6 at all times. In local computers, we use only IPv4. Fine. But they coexist. When you keep ipconfig /all, it will show both your IPv4 and both your IPv6. Fine. Yeah, this is IPv4 and IPv6. Subnetting, calculating subnets, yet another networking course. I'll quickly explain you with the website, right? Online subnet calculator. Visual subnet calculator. Okay, what is the need of subnet? Subnet is typically splitting a network into multiple subnetworks. Your college has 100 faculties, 24 computer science, 24 mechanical, 24 civil, 24 arts, and 24 law. Suppose the faculties are categorized or split in based upon their expertise, right? The whole of 100 faculties is subnet into 5 different categories or 5 different departments. So subnetting on the internet, irrespective IPv4 or IPv6, is splitting the whole network into subnets. For example, let's say you're paying and getting. IPv4 is, public IP and private IP. Private IP is only within your network. Anyone have a private IP? 192.168, 172, 10. Public IP is you pay as you use. If you want a public IP, let's say your college will have 1 or 2 public IP, they will be paying it for the telecom. I will have a public IP, 192.168.1.20 is my IP. Your computer might have, 192.168.1.20 is my private IP. Your computer also will have a private IP, right? It's not meant for pay and use. See, public IP is you pay and use, right? Just like your telephone numbers. Let me give you an example of public IP. I'll give a fancy number, 12.13.14.15. Again, this also has a limit. The IP ranges between 0 to 255, totally 256, right? So it can be from 0.0.0.0 to 0 to 255.255.255.255, right? So public IP, let me remove this subnet part. This is a public IP, right? I'll have a private IP, right? That is anyone can use, but it can be used, anyone can use, but it is only within the network, Imagine like an intercom. I remember I stay in the university where I was there working. We had an intercom number, intercom, phones within used in the network. Intercom number 2000, it will take me to the canteen. I go outside for FDPs, right? I stay at another university. I was staying in their guest house. There I go and type the intercom number 2000. It will take me to the VC office. See, both phone numbers, intercom numbers, different places, take you to different places, because this canteen is accessible only within the subnet. This VC office is accessible only within the subnet. Same way in computers, private IP 192.168.1.20 is my private IP. You might have the same IP in your network, but I cannot speak with this IP outside my network. This private IP has to be converted to a public IP. When I'm using let's say I'm using Airtel, right? This is called NAT, network address translation, converting between one to other. Fine. So we are discussing about this subnet part, right? Fine. So this is private IP. Mask is given, update is given. So mask, you remember I gave it as 24, right? I'll give it on update. Okay. Divide. You see here, I'm giving a subnet. It is splitting me into 2 subnets. Imagine like the whole building is split into 2 classrooms, or whole floor you split it into 4 classrooms. So instead of 24, I give something like 31. Okay. It's going to have only this. When I split, you see the difference in the host and things. Host means in this subnet, I can use only one computer. In the first subnet, one computer in second subnet. Instead of 31, I give 28. The subnet mask and update, divide. I have two networks, and first network I can use 6 computers, other network I can use 6 computers. This is one IP, 192.168.0.0. I give another IP, 10.10.0.0. Another class of IP. I update it. Divide. You see here, 2222, right? So the IP is also meant for a purpose. We call it as a classes of IP, class A, class B, class C. If I want limited networks, I use 122 network. If I want a greater network, I use 172 network. Fine. If I want even greater network, I use 10 dot network. Fine. So that is on this subnetting. There will be many websites for subnetting. Fine. The same subnet, I give it as 8 and go. See, it clearly says, hey, you are splitting a network size as 8, subnet address is given. What is the range of the IPs? What is the usable IPs? How many hosts I can have? These many hosts I can have in this IP range in this subnet. Instead of 8, I give 24 and give go. See, host is only 254. I give 30 and give go. Only 2 networks. If I give 31 or 32, go, it will become 1. Right? We don't want to use one device in a network, right? Normally we use 24 subnet. Fine. So each device, each network, you see, like you have a first year, second year, third year, right? In your college, let's say like you have CSE, first year, second year, third year. First year will have a class of 192.168.1.0/24. What does it mean? 192.168.1.0 to 255, right? So in the second class, you give 192.168.2.0. So second class will be using 2.02. They will be using something called 2.02, 2.255. Fine. Same way you can fit this principle of, again, IP addresses are virtual IP address, right? IP addresses are always virtual. They are not physical. Virtual IP address, right? IP addresses are virtual. Right? So we are having a class of IP. So I am having 192.168.1.0 to 100. Let us assume I am having 100. I want to split it into 5 classes. What I will do? 192.168.1.0 hyphen 192.168.1. If I'm not wrong, it starts with 0, right? So it should end with 19. Maybe it will have 20 IPs. Then 192.168.1.20 to 192.168.1.39. Likewise, it goes on. Fine. So manually, I can write it. Fine. It's well and good. I know some basics of networking. I can this is called subnetting, splitting into subnets. But if you do it for bigger network, like say you are a network admin or your student is going to go in as a network admin for a company. It's a brand new company. They are going to have a branch, 10 floors, each floor 100 computers, 1000 computers. They want to have 20 departments. They split it into 20 subnets. The student, those who join as a network admin or network security engineer, if they are going to start it from the scratch, they need to do this. They need to do this subnetting part, right? How to do a subnet. Nowadays, there are quite a good number of tools, GUI tools, or even AI tools available for subnet calculator. But keep in mind, when you go for an interview, the interviewer will ask about this. How many computers can be used in this subnet? How many networks can exist in this network, right? For that, we need to have a clarity about this IP and subnetting. If I'm not wrong, this will be taught in a traditional CCNA course, right? Subnet calculators, fine. There are a couple of websites as I showed for calculating subnets, fine. Network topologies, you remember? Yeah, I still remember some 2 marks or 8 marks. Bus topology, star topology, ring topology. These are all in pen and papers, right? Bus, star, ring, mesh. Let me check. bus or even still we have a traditional networks course, we teach it at the college or university, right? These types of different topologies. But in real world, like in interview or in real world, like we don't use this. We don't ask questions on this. Very few ask on this because these are all not into existence. We are in the next level of networking and network security or not. Right? But still, the student has to have a foundation. What is the ring topology? They'll be having connection left to right. They transfer it from one to other. Nowadays, we use bus topologies. Networks will be bus topology. World Wide Web is a mesh topology. Every device will have a one-to-one or one-to-many connections to all the devices. Fine. Packet flow. You see packet. And there's a misconception. Packet is not all about network. Packet is in one layer. Right? We call it as a packet for identification. Like I have two Tiffin box. Same way you call it as a packet 1 and packet 2. That is only for the identification. See here on this. See frame number. Here you see the frame number 1 to 11,000 or something like that in Wireshark. So in habituated, right? So we got habituated saying everything in network is packet. But packets is available in only one specific layer, right? Other layers, the PDU will be different. It will be called as datagrams. It will be called as frames. It will be called in different other names. Okay, DNS, you remember, I hope we discussed about DNS. DNS is the translation between the domain name and the corresponding IP address. Most probably the IP address on the internet will be a public IP. Fine. Okay, the network topology, beautiful diagrams. Okay, dnschecker.org. What is my DNS? Let us check this. dnschecker.org. Let me see what's there in that. I accept the cookies. Obviously, I need to. I am typing www.akmohan.in, my personal website. I was hosted on that. I want to know the IP address of that. I'm checking on the internet. See, my website is available all over the internet because this DNS server is in San Francisco, Berkeley, somewhere on Canada, somewhere on South Africa, somewhere on Austria. Everywhere they are able to resolve. Resolve means they are able to find the IP address corresponding to this akmohan.in. Let us check it in the command prompt. Fine. Let's look up. Sometimes it might work. www.akmohan.in. If I'm behind a firewall or I use a security device, it might not clearly show my actual IP address. I hosted in a hosting provider. Fine. Let me check. Trace RT. Traceroute is a command. www.akmohan.in. It's going to trace and let me know from my computer sitting in my office. You remember this my IP. It's I found the IPv6 of the server where it is hosted, right? And it's taking from my local IP. If I'm not wrong, it will take my IPv6 of my local machine, and it wants to go to akmohan.in. Hop means it will go one by one. Like say I go to Chennai to Delhi, I want to go. It will go from one station to other station, right? So trace route, it will take some time. It have n number of intermediate routes and on. Right? If I'm going a trace route for my IP, I'll show you trace route for 192.168.1.1, my router, right? Loading. 10 microseconds, 2 microseconds, 3 microseconds. Just a minute. See, its trace route is complete. It has directly taken to my nearby. I have connected to my Apple router. Within a hop, it is connected on the next node. It have taken. But this address which I hosted on Hostinger might be available in US or Singapore. It will take some time to trace the IP, right? So that is on the DNS part, right? DNS is between domain name and the IP address. Fine. Online DNS checkers, you can check it. Use. Okay, we have seen the basics of Linux, right? So there are some online courses available for Linux. We have covered the Windows. I hope top 8 or top 10 commands in Windows we have seen.
How has your learning journey been going so far? Did you get to learn something new? Please like this video and subscribe to our channel. Let's continue with our learning journey now.
So as you can see here, this is an online portal, NDG Linux. They offer free courses. Typically, this is an interesting course I recommend to all of my students. Those who come and ask me, sir, I want to learn cybersecurity, right? Because it's a complete course. We'll walk you through the first command in Linux till an intermediate level of command in Linux. Anyone who claims to do so-called hacking or information security or anything related to cybersecurity or information security, they need a mandate. They need to know these commands to put in place. But all they are doing a research, they are doing something, developing a tool, or at least they are just using a security tool, right? They need to know these Linux commands. So I'll just quickly walk you through the dashboard. So the registration and other things, I hope today's class notes will be released. In that you will find the link for that, or else in yesterday's class note itself you might have found the link, right? The NDG Linux portal. So it will have commands on the left side. Let me open this course, Linux Essentials. If I'm not wrong, they have somewhere around 18 modules, fine. Bits and pieces, this is completely 30 to 60 hours course. I'm just going to walk you through the top 10 or top 20 Linux commands, right? So chapter 1, 2, 3, 4 will be somewhere on the theoretical part. Chapter 5 starts with the lab. I opened it, fine. So you see here on the left side, they'll say what command you want to practice. Okay, you see the first 5.2 says, okay, just press an enter. I'm pressing an enter here. It's going to take me, hey, welcome, system admin is the username and localhost is the system name or the user whom I have connected. And you see the root is the username, netlab at 123 or netlab 123 is the password. Sysadmin is the username, netlab 123 is the password. So yesterday we have seen networks and something on Windows, right? Linux typically so-called secure, fine. On Linux, everything is treated as a file. Most of the security tools are built over Linux, right? So we'll see some basic commands on Linux. You see, yeah. So I'm just clicking onto this. In Windows, we had CLS, right? Clear screen. Here CLEAR is for clearing the screen. Fine. So ls list short, it will say how many files are there in the current directory. ls-l, it's typically list long. It's going to say what are the each and every files that's available. Instead of that, you can even type ll, list long. Fine. So just to see what you in Windows, you open a file and see. Mostly why we recommend command liners for Linux systems or Unix systems or server-based systems is most of them run headless. What does it mean? Like they don't have a GUI mouse. Most of the Linux servers don't use mouse. They use only a keyboard on a server system, right? So you will be forced or you will be mandated, or else the only option you have is to type in the command prompt. You don't have a mouse to click and open the folder. You need to give a ls, you need to give a ll to check what is inside the folder. You check pwd, your present working directory, home and sysadmin. Who am I? What is the current user? I am the user called sysadmin. Fine. So these basic details you'll find in all of the 5 series. Basic. So I am in pwd, sysadmin, home, sysadmin user. Fine. I want to check the folders options in some other folder. You see, ls-l/home. I want to check what is there in the home folder. You can check it there. See, it's showing what is there in the home folder. In home folder, there is only one user that is created here called sysadmin. Fine. And you see on the left side, I'm typing it. I've tried it quite a good number of times. So I'm just typing it fluently. Fine. So you can just read it. If you're seeing for the first time, it will say what is ls? What is the meaning for ls-l? The same command which you see here on the left side screenshot, you can type it on the right side. Whatever you see on the right side of the system is typically a virtual machine, Ubuntu PC, right? A virtual machine that is running, and the OS is giving us an option, shell to run and check the commands. So 5.3, who am I? We have checked uname, right? Uname. Typically, we'll say what is the Linux version we are running. Fine. Same way for uname -n or uname -node name. The same command will be available in different options. Then the command for type cd. cd is a shell bulletin. So again, these are the basic commands. I will quickly walk you through. I have just opened 2 or 3 other tabs because today we will cover maximum 5 to 10 minutes for this, right? So this is on 5. I have taken you to 8. There's another lab, managing files and directories. Fine. We'll see what is inside that, right? Echo star sign. It's typically a search. Echo space star will say, hey, okay, what all the directories available? Fine. So instead of you give echo space D star, there's no results, echo space D star. See, desktop documents downloads, echo is to search, right? You give a star, star means search all, right? But you keep in mind, yesterday Windows commands are not case sensitive. You can make it in caps, full small, or else hybrid. But Linux commands are case sensitive. If it is capital D, for sure you need to give the capital D to fetch the results. So we'll just move back to this. So we discussed about Linux basics. What was that? On the top Linux command, see, this is what we are trying to do, right? I have checked ls, pwd, touch is just to create a file. If I'm giving touch Ashok, it will create a file called Ashok. You can check it in LL. See, a new file called Ashok is created at the bottom. Fine, just like you create a notepad, you can create a file using touch command. Tar grep. Grep is interesting. You'll be seeing the grep command, grep, number 18 here. Grep is used to search something. You have a Word document, 100-page document. You want to say how many, you want to find how many locations the keyword Ashok is there. You give a control F and type Ashok, it will say, hey, welcome. In this 100-page Word document, 18 locations Ashok is there. Same way, grep is the most common search syntax for Linux system. You can search anything and everything inside the Linux systems. Fine. So then, you see, in Windows, we type something called ipconfig. I am trying that here. It might not work here. So it say, hey, welcome. You're typing a command called ipconfig. Let me increase the size of the screen. Okay. Fine. Yeah. You're typing a command called ipconfig, but I'm not able to find the command because Windows ipconfig works. Linux, that's something different. To check the IP, instead of IP, we type if. ifconfig. Simple, hey, welcome, Ethernet. My IP address 192.168.1.2. If you can remember what we discussed yesterday on track, I still have the document, the text file. So we discussed about IP, IPv4, IPv6. This is a private IP. Fine. So you can see here, that's a private IP set for this system. Netmask is there. Broadcast is there. Ethernet address. What does that Ethernet address means? It is typically the MAC address, physical address, or else we got as Ethernet address. Fine. So 1, 2, 3, 4, 5, 6. 6 into 8, 48-bit Ethernet address. Fine. So ifconfig in Linux is to check the IP address. Fine. Same way you can do trace route. I'm checking where it is, www.google.com. It will go on the internet. I hope the trace route is not installed here because we are using a virtual machine from that course. If you're using a Linux system on your own, obviously you can install it. You see at the command at the bottom, sudo apt install trace route, sudo apt install inet utilities trace route. You can install that and that should work. Right? Then you see the common things, the common commands we use will be something like date, check what is the current date, time, check what is the current time. And that's an important command called sudo, right? Typically in Windows, we call it as an admin user. You are a guest user, you have very less permission. You are an admin user, you have a greater permission, right? Sudo in Linux is used for super user. With that, you can run some high-end admin level privileged commands. Fine. So that is on 8. So my agenda for showing this free course here is just a minute. Yeah, this screen. So in Linux, you see here, Linux, everything is treated as a file. So obviously file permissions are so strict. That's how they just enhance their security. They claim is on that. Fine. So you see 1, 2, 3, 4. The same thing you will be seeing on that screen. You see here, let me type, let me clear it. Sorry, let me clear it. Again, typo, let me clear it. Fine. I'm typing ls, list short, only show the files. If it is a file, it will show in a color, and if it is a folder, it will show in color. Desktop is a folder. Inside that folder, many files and folders will be there. But Ashok, which I created, is a single file, so it goes different colors. Same way when I type ll, list long, it's going to clearly show, right? And you see here D, whichever starts with D is a directory. Whichever starts with hyphen is a not a directory, it's a file. In Windows, we call it files and folders. File is a single one, folder is a collection of something, right? So if D will represent whether it is a file or folder, first one. If it is a file, it will have hyphen. If it is a folder, it will have D. Fine. The second and third and fourth, you see here, RWX, RWX, RWX. What does that mean? It's a permission. User writes, hey, I created this file, Ashok. My username is system admin here in this computer. So system admin is the user of the file. User means like typically the owner of the file. Owner will have R for read, W for write, X for execute, execute or run the file, right? So owner has read, write, execute permission. I am a part of the computer science faculty group. So my group members also will have, all faculties in computer science will have read, write, execute permission. Other members, maybe some other faculties, some other students who's not me, who's not a part of my group, who has access to this file or folder, will have the permission on the last one, right? So that is on this permission level. So just a minute, let me open. Okay. So we have something like D space RWX, RWX, RWX. This is how it works. Fine. And you can just set the permission as RWX, or else there are some numerics equivalent is also available. 421, not 421, 4 plus 2 plus 1. 4 plus 2 plus 1. Fine. For example, I'm having a file ashok.txt. Fine. So if I'm the owner, I'll be having 4 plus 2 plus 1. 7 will be the permission. Fine. For one. Second set, if the users, let's say my faculties can read, write, but they can execute, that will be 4 plus 2. 6. Other members, 0, 0, 0, right? If the permission of this file, right, is called 760, what does it mean? 7 belongs to 4 plus 2 plus 1. 6 belongs to 4 plus 2. Then the last one belongs to 0. So you can have all permutations and combinations of this 4 plus 2 plus 1, 4 plus 1, 4 plus 2, 1, 2, 4, everything 0, fine. But in Linux, right, if everything is 777, that is not good. If everything is 0, that is not good. What does that mean? See, this file have anyone can do anything with the file, all permission. That's not recommended. 00 means no one will have permission. Even the owner of the system won't have permission to edit that file. Most of the times when a Linux system, a virus comes in, they used to try these sort of different permissions. Fine. So that is on this permissions on Linux systems. Fine. So that's what we are seeing now, demo on the NDG Linux systems, right? So I've created a file called touchsecure.txt. Let's go back, right? I'm creating a file touchsecure.txt. Fine. LL, let us check. Okay, the touch file, secure.txt file is at the bottom. The permission is RWR, right? The permission for this file, secure.txt, we created now. The default permission is RWR. It's not a directory. RW, R hyphen. I hope that's the same. Yeah. So what does it mean? The user of the file, this is called user. We have user, or we call it as a owner. Let me check. Owner of the file. Then the group members of the file and others. So they use others here. So let me mean it as U here. UGO. Users, group and others. User has read and write permission. Fine. Group members have read, write permission. Fine. Other members have only read permission. So what is the permission value? It's going to be RWX. R is equal to 4. W is equal to 2. X is equal to 1. So if we put it in numbers, it's going to be 6, 6, 4. The permission of this file. Fine. So you can set all combinations. As I said, from 000 to all permissions to 777. We can set it. Fine. So that we'll be seeing this in this module number 17. Let's check. I'll try a couple of commands here. File permissions. If you're doing it for the first time, right? This is a comprehensive course. You can do it. You can complete every module. you can complete the exam and you will get a free certificate from this Linux Essentials, DG Linux. Fine. So if you're doing it for the first time, I recommend everyone to try all the commands. It may take you 5 hours or 10 hours, but whenever you find some time, you can try that. If you are into academics, you are going to teach or teaching cybersecurity or information security, this is a mandate for you. Whenever a student comes to us and asks, sir, I'm doing a grep on this statement, let me know this syntax is not working. Initially, we need to know what is grep. We need to know what is the hyphen parameter. Then only we'll be able to answer to students' queries. Right? Okay. Okay, we'll get back to the document. So then Windows has something called Sysinternals, right? Sysinternals is a troubleshooting for Windows system. Fine. For example, if I'm opening Windows Run, I'm typing EVENT event viewer. A window will pop up saying that, hey, welcome, I am the event viewer of Windows. What do you want me to do? It will just typically a logging mechanism, will log everything. If I'm taking Windows logs, security logs, it will clearly say, hey, how many times I have logged into this Windows computer? It's my personal PC. You remember yesterday we discussed about i3 Dell PC, but actually it was a HP PC. Fine. So it's my HP PC. I am using an AMD Ryzen 5 processor. Fine. So it will say how many times the user have logged in. You see here the level is information. If I sort it by the level, information, it will have critical, warning, error, different logs will be there. So you select one log, at the bottom it will say, hey, 13/10/2157, this time the user have done this activity, event ID 4799. Let us check. 4799 event viewer ID. We'll get a result saying that what does that 4799 means? Yeah, a security enabled local group membership was enumerated. Something enumerated means some changes. Some changes was made to the group. So I'll give you something like 4624. I remember that number. Event ID 4624. There's an event ID. It will clearly say, hey, welcome. You have logged into your computer. Successfully, you give the username and password. You logged in. It will be logged on this Sysinternals Suite inbuilt in Windows, saying that when you logged in, whether it is correct or wrong. If you have not logged in correctly, 4625 will get you the result. 4625 will say failed login. See, someone have tried logging into your laptop. Maybe another fellow faculty doesn't know your password. Whenever you are not available, they have tried to type the password 2 times, 3 times. Then they failed and they went out. But if you want to check like anyone have tried in your laptop over the prolonged duration of 1 month, 3 months or 6 months, depending upon the availability of the logs in your system, you can check it in the event viewer, right? Same way, there are many things, Process Explorer, Auto Runs, TCP View, Process Monitor. All these things are, it's built for Windows diagnostic. Any problem with Windows computer or computer, you can use it for troubleshooting. In information security, we use it for identifying an attack that have happened. Fine. We have used command prompt regularly. You remember yesterday we tried command prompt ipconfig. It shows my IP. Fine. There is something else in Windows called as PowerShell. When you type start and power, it will take you to something called PowerShell ISE, blue color screen, like yet another command prompt, but they have some higher order permissions, right? If I want to change, let me say like, I'll check it here. Yes. I'm checking net space user. How many users are there in this computer? I have some demo users called mal or malware, right? I'm trying to net space user space malware space char. Type the password 123 123. System error. It's not allowing me to reset the password. Fine. Let me try the PowerShell. Same PowerShell running as administrator. Yes. Okay, let me try the same command. You see, previously it was C users Ashok. Now it is C Windows System 32. Let me try the same command, net space user space malware space char. I'm giving a new password 123 123. Welcome. The password has been changed. Fine. Simple. A user connecting into your system, they have a privilege to change their password using the same can be done in command prompt also, right? But advanced extended versions of commands, you want to run 2 commands, multiple commands. We can run it in a window called PowerShell. Maybe after certain versions of Windows XP or Windows 7, this PowerShell is available in all the Windows, right? An extended version of command liner used for scripting. This PowerShell is mostly used by attackers, so-called hackers, to create a script, malware script, so that when you double click, it will run in the background. Obviously, the virus might have entered. It might have just put a copy on the system, right? So that is on the PowerShell syntax. I hope till this we had the plan for yesterday. That was completed, the pending part. Now we'll move on to day 2's topic. Okay, 1 to 8 is done. Today we are going to see some core cybersecurity principles, right? We call it as theorems, right? Right? We talk about Newton's principles, Pythagoras theorems, right? Same way, these are all the basic principles of cybersecurity, or else we, in a broad scale, we call it as a information security principles. CAA, AAA, security principles, security layers, what is a data bridge, then continuation of network, what are the port and protocol, how to analyze a packet, what are the security devices, firewall, IDS, IPS, SIM, XDR. I hope 9 to 16 is the agenda for today's session. We'll walk through that. Okay, CIA, if you're hearing this for the first time, confidentiality, integrity, and availability, right? That is called CAA. Okay, we call it as a triad, information security triad. Sometimes they call it as pillars of information security. See, if an attack is happening, the attacker has to compromise something. They want to do the so-called hack or XYZ attack, right? They will compromise your confidentiality of your data. They will compromise the integrity of your data. They will compromise the availability of the data. Let's say there is a score of 100. Confidentiality may be compromised for 40, integrity for 40, availability for 20, availability for 80, integrity for 10, confidentiality for 0. The ratio differs, but all these 3 are mandate. How you can categorize a cyber attack, or else how we can tabulate, or else we need to give a scale, right? Scale or calibration, right? So this, then attack happened, how much of confidentiality is compromised, how much of integrity is compromised, and how much of availability is compromised. Putting all together will give you a result saying that what is the attack, what is the severity of the attack. Fine. I will give you an example of a bank. Let's say everyone has a bank account. Confidentiality means you have 10,200 rupees in your bank account. You are the owner of the account. You know how much you have. You are an authorized person. And say your bank manager is yet another authorized person. He can see how much balance you have. It's okay. Another faculty tomorrow comes to you and asks, hey madam, give me some 5,000 for Diwali. You say, hey ma'am, I don't have. I have even only 2,000 in my account. If he or she says, ma'am, I know you have 10,200 in your account, the confidentiality of your data is done, compromised, right? So there is a confidentiality factor. Only the authorized person or individual or entity have to know what is the data. It can be a normal data, it can be a secret data, whatever it may be. Second part is integrity. I am saying, hey, tomorrow we will meet at the same time, 3 p.m. But you are getting the message, hey, tomorrow we will meet at 7 p.m. What is the conclusion? The integrity of the data is changed. I am sending you a message, meet me at 3. You are getting the message, meet me at 7. Something is changed in between, or something is changed from the sender to receiver, right? So that is called integrity. You have the same 10,200 rupees in your account, fine. One fine day, you go and check your balance, it will say 7,500. You have not taken any money. Bank also might not taken 2,500 rupees as charges or something. Before and after, your data is modified, changed. Either something is added, even if you have 10,200 earlier, now you have 15,000, the integrity is compromised. Either any addition, a removal, or modification is typically called as compromise of integrity. Fine. And the final thing is availability. You go for a movie, you have a ticket, you stand in the crowd. Even if you say, hey, I have a ticket, they won't allow you, right? That will be crowded. The same bank example, you have 10,200 in account. You go to the ATM, swipe it, you give the correct correct PIN, and you give all the correct numbers. From 10,200, you want to withdraw 2,000. Bank says, the ATM says, hey, no money. What is the conclusion? You have an active account, you have 10,200 in your account, but currently using that ATM, you are not able to take the money. What does it mean? The data is not available for you at that moment. Fine. So that is called availability. An attacker might do any XYZ attacks, denial of service attacks, right, to compromise the availability of your data. It can be in a system, it can be on the network, it can be on the bigger worldwide front, right? So this is called CIA. I hope I'll share the document with you. I'm not going to read the definitions, right? So you can use it for your understanding purpose. Confidentiality, sensitive data using only authorized person. Integrity, the accuracy of data and trustworthiness is not modified. The availability, your data should be continuously available at all times. Right? So that is called as CIA, the first principle of information security, confidentiality, integrity, and availability. You see yet another diagram that's given for CIA. Okay. Now we'll move on to the next principle called AAA model or AAA principle. Let's see what is AAA. Okay. We saw confidentiality, right? Your confidential data can be accessed only by you. Your bank, you will have a username and password. Your bank manager will have a username and password. So that is called authentication, authentic person or verified persons, right? So authentication is who gets it. People need a secure manager login, right? With some authentication. It can be single or multi-factor, fine. So authentication is only the authorized person or only the actual verified owner of the data can access. Like you see a key is given here. Your classroom has a key. Morning when you go early, you just go sign and collect the key and you use it. Same way in computers, what we have username, we have password. If you have mobile or tablet, you have your biometric, you have your face scan. You can have a swipe a card, right? Anything. There are different types of authentication. Authentication is verifying you are the authorized person for that. Then second thing is authorization, right? So authorization is, right, you see here, you're authentic, you're logged in, fine. You are a faculty from computer science department. You're going to upload a question paper. In the question paper folder or another folder, you find the question paper of EEE department. You're an authentic person, a faculty of the college, well and good. But you're not authorized to take the question paper of the other department. If you try to take that, you're not monitored, you're not given a message saying that access denied. If you're able to take the question paper of the other department, the authorization is compromised. You're not an authorized person. You know, right, even I had a decade of experience on working into university, right? So there will be an exam cell. Not all people, even faculties, are not allowed to exam cell. Maybe a notice may be put at the front, right? So that is called authorization. Even after you give a username and password or you have an ID card as a faculty, you log in. Whether you are authorized to open that folder, you remember the permission which we saw earlier, read, write, execute permission. Whether you have a read permission or write permission or execute permission. If you have an execute permission, only you can execute. You're not allowed to read and write. So that is on this authorization. The final thing is accountability. See, there's a common computer in your college. The same computer in your department is used for all faculties to upload the question paper. Accountability will be there when you logged in and when you uploaded. The faculty says, sir, I uploaded last Friday itself. The question paper went only on next Monday to the exam office. The accountability of the system will clearly say when you uploaded. Either you upload on Friday evening at 5 p.m. or Monday morning at 8 or 9 p.m. Right? Accountability. So that's what we saw in this event viewer. Event viewer is one of the good example of accountability. Event viewer will say what your application have done, what your security events have done, what the system events have done, what a system event have done. Each and everything which we do on the system will be logged on to a logging mechanism in Windows. It's an inbuilt application or inbuilt feature in Windows called event viewer. So that is called accountability. Fine. So these are the common principles. Again, when we go for interview, the most common question, say me what is CIA, say me the AAA principle. At least students should be able to say confidentiality, integrity, availability with a definition and an example, authentication, authorization, and accounting with a clear definition and an understanding. We don't want to book back 2 marks, right? We want an understanding. They need to understand the difference between authentication, authorization, and accounting. Fine. Yeah. So that's on the AAA model. Okay. You see here a single diagram might explain you what are these three. User is giving a username and password, logging in, request is going to the server, verifying your username and password, coming back and saying, hey, welcome to the attendance management system. You are a verified faculty. That is called authentication. In attendance management system, you open a file, you write a file, but you are not allowed to modify the file. You can open the attendance management system, you can enter the attendance, but you are not allowed to download the file. So that's counted as authorization. Even if you are a verified user, what you are allowed to do, what you are not allowed to do is called authorization. Final thing, accounting. You logged in, you see the example which I said, that day morning 9:34 you logged in and you uploaded the file A. Accounting of what you have done on the system, add, delete, modify, login, logout, everything, right? So this is AAA principle, and the first one was CAA principle. These are called as pillars of information security. So anyone who wants to get into cybersecurity, obviously they should be able to have a strong foundation of these, because upcoming days and upcoming topics, whenever we talk, say, hey, ransomware have attacked your computer. I'll say, hey, your computer is infected by a ransomware, a virus. Your availability is done, right? Your integrity is the same. Your confidentiality is done. If a ransomware is infecting, confidentiality 50% modified, integrity 0 modified, availability 100% modified, something like that. So whenever we talk about an attack, they will be counted in terms of CAA. Sometimes when you want to monitor them, it will be counted in terms of AAA principles. Okay, we'll fine. So AAA, authentication, authorization, accounting, they will be facilitated by some servers. Your college might have a Windows server, Linux server, or something hosted on the cloud. So these servers, I don't want to go deep into the server part, but I'll let you know the names. Radius, TACAX. If I'm not wrong, you might have taught this in any of the network security papers, right? Radius is one server, remote authentication dial-in user service. There's yet another server called TACAX and TACAX v2. Fine. So these are all different types of authentication servers. You go to your college, you have your college Wi-Fi, you open it, you give your faculty ID, you give your faculty password, it will allow you to log into your college Wi-Fi. You have complete access to all of the internet. But if a student comes, they open college Wi-Fi, they give student ID, they give student password, they're not allowed to open Facebook, they're not allowed to open WhatsApp. Those permissions, security things will be set in a server, typically an authentication server called Radius or TACAX, different versions of server. There are technical differences between Radius and TACAX, but keep in mind, Radius and TACAX are the authentication server. They do this AAA in real world. Fine. Okay, there are some quizzes and other things should be available. If I'm trying this, we won't be able to complete the topics in 2 hours. I'll leave it up to you, right? You can just, when you go through the topic, you just check that link. Fine. If the link is important for the demo, I'll open it and show you live. These are all awareness links. Let me go to the next principle. Okay. We have seen CAA, AAA. The principal part, the foundation part doesn't end here. There is some extended principles based upon CAA, based upon AAA. There are some extended principles available. Least privilege, defense in depth, separation of duties, fail-safe default, security by design, accountability, many. Maybe for the matter of fact of time, I'll explain one principle, the extended principles, clearly. Fine. The principle is called POLP, Principle of Least Privilege, POLP. What does it mean? You work for a college, your college owner, let's say your chairman is there. He has a username and password in your college. Even being the chairman of the college, he or she should not have the permission to delete all the files in the server. He's the owner, fine, let it be, fine. Why he wants to delete all the files in the server? Let's say the head of the department having permission to delete all the question papers. That's not recommended, right? So that principle is called principle of least privilege. Sometimes an attack might happen due to a virus or a malware or a hacker, external. Sometimes the attack might happen due to internal. You see here at the bottom, human error. Ma'am, unknowingly I deleted the file. I selected all, and instead of clicking enter, I clicked delete. Fine. So that is called principle of least privilege. You see, whenever you want to do some sensitive operations, it will ask, hey, are you sure you want to delete? Yes or no? Maybe another confirmation it will ask, right? So that is called principle of least privilege. Fine. Okay, that was it. A 2-mark definition. Users and systems should only have the minimum access necessary. Even if they are owner of the system, fine. They should have only minimum access to do something or destroy something or delete something, right? Difference in depth. You see, we take an onion and peel it, 4, 5, 6, 7, 8 layers. There will be a core. Your data is something at the core. Above that, just like we saw ISO OSI layers, 7 layers. In all the 7 layers, we'll have attacks. So in all the layers, we need to do some, or we need to put some security mechanism, right? So that is called difference in depth. Fine. Separation of duties. You see, like in college, we do. See, they will put an faculty in charge for exam duty for computer science department, or putting the timetable or putting the faculty schedule. The same faculty won't do for the next semester. The same faculty won't do for the other semester. That's called separation of duty. You should not give the single duty to an individual, because sometimes the person wants to do something wrong, they can do, right? They can commit an offense, right? So that is called separation of duties. Fail-safe defaults, what does it mean, right? If something happens, what to do? Also, to prevent something, what to do? So most of the security system, you know, right? When an intro was given to me, I was working for some security projects for agencies, right? So there will be a fail-safe duty saying that deny everything. You remember yesterday's chat? I'll open the document. When we are discussing about firewall rules, I typed something. Let me check. It should be here. Okay, deny. Deny any all or deny any. What does that mean? It's typically they are just setting up a deny access. So anything coming onto the network, let's say you're going for a defense agency, military, army, navy, they might have this permission by default. I know how to copy the file and give it to the next department. I don't want anyone in the network to come inside. The default deny all permission. We call it as a blacklisting. You're not allowing anything. Fine. Complete blacklist. Security by design. I hope most of the computer science faculties here, even ECE, EEE faculties, we teach, right, how to write a program, how to fabricate a chip, how security by design. The first and few lines of the program have to be secure. You're creating a program to make a website. Username and password. Username should have only 32 characters. Password should have only small caps and special character, right? So security by design is need of the hour in industry today, IT industry, right? We don't want people to write a C, Java, Python code. We want them to write a code in order so that security in place each and every phase of the development. You remember 10, 15 years ago, we'll develop an application, finally we'll give it to a security engineer and test it. But nowadays it's a cycle. Every now and then we call this a sprint. Every 5 days, every 1 day, every 2 days, right? Whenever a piece of code is built, the security of the code is tested every now and then, right? And finally, we have seen this accountability, the same accountability that was discussed earlier. Limited access, default deny, need to know who did what, just enough access, same way limited access or enough access. Finally, access control. Every system in security will have ACL, access control. Firewall is a security device, it has access control. What does it mean? It has a rule, what to allow and what to deny, right? Fine. WASP top 10 ISAC practice quiz. These are all reference quizzes. I'll take this WASP top 10. Fine. I want to say it at this place. WASP top 10. Hope all the faculties here might be familiar with IEEE, right? You publish a paper in IEEE, you publish a paper for PhD or masters. Everyone knows IEEE is a society, right? Built for some purpose, some research, right? Same way, OWASP, OWASP, is a society. It's a non-profit society built by a group of security experts. It's a foundation, you see here. It's used to improve the security of the software applications. It's not only software, it takes software, hardware, or application. You have a vulnerability in your Windows system, it will list you. You have a vulnerability in your Android, it will list. You have a vulnerability in your pen drive, chip, hardware, it will list. So OWASP is a foundation, a forum which regularly finds and lists the vulnerability. In layman terms, if you want me to say, maybe 10 years ago, 15 years ago, we might have seen top 10 movies, top 10 songs every Friday or every Sunday. Same way, OWASP top 10 will say, hey, I'm going to list you the top 10 vulnerability. Or in attacker terms, the top 10 attack. You see, it will be revised every 3 years or every 4 years. Fine, it's 2017 and 2021. 2017, the top one attack is injection. Let's say in the worldwide, millions of attack happened. Maybe like majority of the attack might have happened using injection attack. Second one is broken authentication. You see in 2021, the broken access control which was there in 5 came to the top. Fine. So this fluctuation is different. Fine. Every 3 years it will be revised and used. But if you are a security professional, right? If you go to the company and say, hi, I can do a security audit, security report. Fine. So the report should have something on this. And the report should clearly say what is the vulnerability, what is the attack. You need to categorize the attack, right? So the attack can be found and categorized using this OWASP top 10. Broken access control, cryptographic failure, injection, insecure design. These are all top 10. There are hundreds and thousands of attacks. But see, 100 attacks are happening. More than 90% of the attack happen within this 10. Fine. So that is called OWASP top 10. You see here simple statistics. 94% of the application. Let's say your college has attendance management, it will have employee management, it will have HR management. At an average, 94% of the application, right? Maybe 9 and a 10, right? Have something called broken access control. Just before some time we were discussing about access control, right? Authentication, authorization, who can access, what can access. Broken access control means there's an access control, but that is not so strong. Fine. And there will be something called weak passwords. Using a weak password, vulnerable and outdated components. Fine. And the top 10 list goes on, right? So OWASP, just like IEEE, you keep in mind, OWASP is a foundation which is listing the top 10 vulnerabilities, and they are learning day in and day out. It's an open forum, so I can contribute for OWASP. You can contribute for OWASP, right? So that is on this OWASP. Okay. Security layers, defense in depth. That's what we say. Peeling the layers of an onion. You need to have layers of security. Don't confuse this layer with ISO voice layers. That's a standard ISO protocol. Application, presentation, session, transport, network, data link, physical. That is ISO voice layers. This layer is typically defense in depth layers. Physical layer, you have, if we don't want to name it as layer. Physical, you have a CCTV. Perimeter level, you have a gateway or things. In network level, you have a firewall. In endpoint, computer level, you have an antivirus. In application level, secure coding. In data layer level, encryption and decryption. In user level, that's what we are doing now. Security awareness, knowing about authentication and on. So I hope we'll have a single pictorial representation. The mission critical assets are the core you see at the bottom. That is your data. Your data can be attacked by an attacker in hundreds of ways. As you see here on the screen, your data can be safeguarded in thousands of ways, right? So policy management, left side, a company will have a policy. You have a Wi-Fi, Wi-Fi should have minimum 8-character password. You have a faculty, you are not allowed to share the faculty password with students. Your management will have a policy. Operations, right? You see here, there will be some security team, physical security team. In college, you'll have discipline committee, right? Same way, the operations are maintained by a team of security professionals. Whatever you see on the left side and right side, green colors are something techno-managerial, mostly managerial level, cybersecurity teams. But data security, you see here, let's zoom in. It's not much clear, fine. Data security, it's actually, you can secure the data using any of these. PKI, public key infrastructure, we'll be seeing this in cryptography. DLP, data loss prevention, fine. The data is missing, deleted, how to recover that, it will talk about that. Application security, when you develop an application or you run an application, what has to be done? Endpoint security, how to keep your computer secure, how to keep your mobile secure, how to keep your printer secure. Network security, your networking devices, switches, routers, intranet, how to keep it secure. Final thing is perimeter security. Maybe like your organization level, citywide, statewide, countrywide, how to make it secure. So this we call it as DID, defense in depth. Any attacker have to crack all these layers and come to your data. You cannot directly land onto your data. Break the perimeter, bypass the network, find some vulnerability in endpoints, then find older versions of applications, then know where your data is stored, uncopy or change or modify the data. Fine. Okay. Bitwarden, password strength, not password strength. Okay, when you're talking about authentication, right? I want to just give a simple example here. Security org, there's a website where you can go and check the strength of your password. If you have a password like your 10-digit mobile number, that's not going to be safe anymore. Let's check. Let's check. 9791839. I'm typing my mobile number, 10-digit mobile number. It clears. Hey, welcome. Your mobile number can be cracked. If it is a password, it can be cracked with 200 milliseconds. Fine. So let me show you a website with security org password meter. It will show the passwords also so that you can not password security. Let's check onto this. Okay, let me open. I want to display that, so I have just kept this option. Fine. I am typing a password ASHOK. It is weak, can be broken in. It is weak, it can be broken in 10 seconds. I am giving my mobile number. It is again weak. You need to run a password cracking algorithm. It can be cracked in some 9 hours using any password cracking tool. The speed of this depends upon the server. You are using a high-end server, CPU, GPU. Nowadays, Quantum is changing the dimension of passwords, right? But this is a common server with which you can crack the password. If I'm typing Ashok, it's weak. Ashok Kumar, it's weak again. I'm typing an @ See, just by putting an @ it became moderate. I give 1987. It became secure. I add, let's say I'll replace this O with 0. 31 years. This K with a caps. You see here, the strength is increased. It's even greater. Fine. And you see here, leaks also there. It will say whether the password is available on the internet. ASHOK. Weak. Number of times the password, 8,000 times on the internet. This password is available. The name called Ashok. Fine. We'll check the common password we use. Let me try something called admin@123, the so-called secure password. You see here, even greater. Maybe like 14,35,400 times. Admin@123 password is available on the internet. Fine. So where they find it in some. We'll discuss about this in data breach in the upcoming topics. Fine. So this is how to keep a password or a secure password. Fine, because the whole of your security is authentication. Authentication means password. Password means a lengthy and a strong password. The next topic is data breach. In layman terms, we call it as a hack. One mail ID is hacked, or all the faculties, all the college mail IDs hacked. Hacked means someone have leaked your username and password. Fine. See, let us check something called as have I been found? That's a website that's available where you can go and check. Fine. Let me go there. I'm checking my old ID, Ashok for galaxy@gmail.com. I no more use this. It's a 20 years old ID. Let me check. This website will go and check and let me know, hey, on the internet, there are thousands of websites. I had account with this mail ID maybe 5 years ago, 10 years ago. Let me verify whether I'm a human. CAPTCHA. It works. Fine. So it's going to let me know this mail ID, how many breaches? 15 data breaches. Data breaches means in 15 massive group of hacks, this mail ID is associated. It doesn't mean the Gmail password of this mail ID is leaked. Using this mail ID, you have gone to another website, you have created an account. That website, either the mail ID might be leaked, the password might be leaked in plain text, the password hash value might be leaked. You see here, let's come down and check. IndiaMart, LinkedIn, Twitter, Citode, Nitro, different websites. Let's say if I'm checking this website in September 2020, maybe 5 years ago, I had an account in this website using the Gmail. This company's database or server have been compromised. We call it a data breach. The result of the data breach is 70 million email address. Let's check what is 70 million in numbers. That's the difference between million and billion, right? 70 million, 70 followed by 6 zeros. So these many usernames and passwords have been leaked online. One such is having this Gmail ID as the username. Fine. So that is called as a data breach. You see, this is in India, there is a security group, right, called CERTIN, Cyber Computer Emergency Response Team, CERT-IN. CERTIN is Indian Government Information Security Team. You know, right, we have police, we have people for fighting, police fight for something, maybe firefighters, you see ambulance do some operations, right? Same way, CERTIN in India is typically Computer Emergency Response Team for India, that's called CERT-IN, right? So they have quite a good number of regulations, right? So one such reports from the team says, you see what all the data breach happened in India. Fine, we'll see some statistics. The top 5 states, Telangana, followed by Surat, are the locations, hotspots. There comes Tamil Nadu and Bangalore and Jaipur. Fine. You see here, over 369 million detection across 8.4 million endpoints. These many devices were scanned and these many attacks has been detected. You see here, you remember I discussed about this ransomware. Ransomware is a virus. There are some 1000 attack detected or 500 attack detected. There is one ransomware. If 1000 attack detected, there are 2 ransomwares. Just a minute. Okay. Fine. So a data breach, you see something like sensitive, a username or password or something is leaked. Fine. So when we talk about data breach, if you are going to give it as a 4 mark or 8 mark, the expectation will be define data breach, then attack vectors, how the attack happened, what is the virus, who's the hacker, phishing is an attack, malware is a virus, ransomware is a type of malware, credential theft, stealing username and password, impact, what does it mean, after attack, what happened, financial loss, someone lost money, reputation damage, the company is closed, regulatory penalties, government comes to you and say, hey, your website is hacked and some data is leaked. I remember, again, without revealing the name, I can say here, right? So the government agency have reported to a university, fine, last week saying that, hey, your university is having a website, you have a distance education website, fine, and you have a normal operations website, fine. So your university website, you are uploading question papers, you are conducting exams, you are giving login. There is an attack possible, right? So I can just a minute. I can name the attack. That should not be a problem. XSS attack. That's called cross-site scripting attack. Fine. So you have a website, university website. In that, this cyber attack, you see what comes in. This cross-site scripting attack is possible. So the government, maybe the team like CERTIN, right? They might have got some input. They might have verified that. And they are sending a notice to the college or university saying that, hey, your website is vulnerable. Just find it, patch it, give me the report within 48 hours or 92, 72 hours. Not like 1 month or 2 months. I want the report within 2 to 4 days, right? So that is on this impact, financial loss, reputation damage, regulatory penalties. It may be Indian government suing you, it may be UGC or NAC or whatever regulatory body, state or central or global, right? You are not keeping your website secure. The regulatory body might find your website vulnerabilities. They will report to you, or else they will put some penalties, fines, or legal complications for you. Fine. Responses of this is typically What we need to do typically when a cyber attack happens, detecting the attack, containing, if the virus is spreading, you don't want to spread it further. You contain it within that system. Notify, you need to notify to the college, notify to the students, notify to the parents, or whomever are stakeholders. You cannot keep it closed. You need to notify to who are the stakeholders, saying that the attack happened, be safe. Final is remediation. The attack has happened, everything is done. You are going to go back and find what is the attack, how it happened, how to prevent in future also. See, in our company also we do something called DFIR, Digital Forensic and Incident Response. We do this in action. When a client comes to us and asks, hey, some attack happened, we go, we find the attack, we detect, we contain, we give a notification, we remediate, we patch it and give them the report within 42 hours or 74 hours. Fine. So that is on something called as data breach. Fine. Data breaches. There are quite a good number of case studies available, right? If you want to, we'll discuss one or two. Fine. The target networks. You see here. November 30, someone will see this, right? First one, third-party vendor. That's a service coming onto your system, September 2013. The attacker is sending something to you. After November, it is going onto the server. It is reflected on your server, step number 3 and 4. It is forwarded to your POS machines. You see here, POS terminal. Then you have a firewall. See, that is going through the firewall or bypassing, and it goes to the attacker's website. See, starting from September till December, the attacker has sent a virus to your system. Someone is clicking, something is opening, something is sitting inside your server, something is bypassing the firewall, something goes back to the attacker. What goes back to the attacker will be your username, password, or your sensitive information. Fine. Okay. We have seen this. Have I been pawned, password manager, DNS checker, and on. Okay, we'll come back to this concept called ports and protocols. We discussed this lately yesterday. MAC address, IP address. Let me check. It's not there. Yeah, this is ports, right? We discussed port are like Windows. Just for your understanding, I'm saying they are virtual entries to your computer or system. Fine. Virtual entries are doors and windows for your computers to do something. So there are, as per the protocol, 65,536 ports are common ports. We know FTP, it should be 2021. HTTP 80, HTTPS 443, DNS 53, SMTP 25, POP 110, common ports, random ports, right? Port is the entry point, right? So let's check. Well-known ports, you see here, common ports. Yeah. I hope this is a GIF image. It's not floating in PDF. Fine, no problem. See, let's see one by one. Open ports, protocols. You know, protocol is a standard. HTTP is a normal standard. You type www.google.com, goes via HTTP. You type https://www.google.com, the secure version of that. When you request and reply, normal web traffic. When you request and reply with the SSL, TLS SSL, you see here, transport layer security, secure socket layer, fine, TLS and SSL. That is called as 443. FTP, you see, this is most common. You sit in the ground first floor faculty room and you upload the question paper to the exam office. You do it with the FTP. It's a traditional method of file transfer, but that's not secure. TCP, you know, you remember yesterday we discussed about TCP, connection oriented protocol, reliable protocol, three-way handshake. IP, you know, IP between sender and the receiver. UDP, you see TCP how it is going, ordered, packet 1 of 4, 2 of 4, 3 of 4, 4 of 4. But UDP, you see, it's like spreading. Whatever I'm speaking now, it's like UDP. I'm not sure how many are able to understand, how many got it, how many have a doubt. It's everything blank. I'm just broadcasting, right? If it is TCP, we do, right? Sometimes students used to say, hey, this faculty is strict. What does that mean? We'll teach something. After 5 minutes, we'll call everyone and ask a question whether they have understood. We want to verify whether the communication is successfully done, right? So TCP is reliable, UDP is unreliable, SMTP, simple mail transfer protocol. So you see FTP, I said file transfer protocol, not a secure channel. The replacement or the current day alternative for FTP is SSH, secure shell. From the sender, between the sender and the receiver, the communication is secure. Secure means it will have an authentication, it will have a lock, let's say a crypto. Fine. So we'll go back here. FTP is 2021, SSH is 22 port number. Instead of FTP, you need to use SSH. Instead of HTTP, you need to use HTTPS. Fine. So that is about ports. Whenever we talk about network security, we need to know about IP, MAC, port, protocol. All cyber attack will talk only about this. Which IP was compromised, which MAC address was involved, what was the port number the virus came into your system, what was the application that was compromised. We'll talk in terms of this only. So this foundation has to be clear. Okay. You see an extended version of port numbers, the listing available here. I've given you some common ports: FTP 2021, 22 SSH, 23 Telnet, and there will be some fancy numbers. I hope it's not listed here. 123 is for network time protocol. Let's say all your college computers have the common time. You're going to conduct an exam, right? So they will be synchronized with the NTP, network time protocol. Port number 123. Then you have different port numbers. You see, till 1024, it's common. But you see, above 1000, they are random ports. Viruses might come in some different ports. Let me show you an example. Sub7 malware, 777 port. Fine. I'm showing an example. It's an older traditional Gandhi time malware. Fine. So let me check this. Sub7 malware. Just a minute. I'm randomly opening. Okay, see, historical use. Nowadays it's not module, as I said. Older days when there was a Sub7 malware, it used to run via the port number 777. Right? How to check? Like your firewall will say which port is open, which port is closed, right? We have seen that, right? Let me open command prompt. Yesterday we have seen a command. You remember we typed something called net stat-ano. Ports and protocols open. Let's see the port numbers here. Port number 6746, 7193, 356, 106, different port numbers. So if this port is open, the majority, you see 90% of the client, there's a Sub7 malware, older days. Nowadays, Sub7 malware comes in a notorious port, 27374. Fine, let us check. Images. So you have a company, you have a computer, you are running 80/443 HTTPS, fine. But in your network, in one computer or multiple computers or in whole of your network, port number 27374 is open. The conclusion is your system or network might be infected by a Sub7 malware. Because how I am just able to say it here is like we regularly work with companies, right? The most common malwares, most common infections, some things we have it in mind, right? Running all together. Fine. So these are the ports and protocols. Again, in interview, our expectation for a candidate or a student, a fresher, at least they need to say the top 5 ports or top 10 ports. If I ask them what is a port, if they say, sir, I don't know what is a port, we can't give them a job in cybersecurity. So at least they need to know the top 10 ports. I remember when I asked an interview for students, I'll be so happy if they're able to show this different at least. A computer science student saying HTTP 80, HTTPS 443. If it's a cybersecurity student, I'll be happy if they're able to say at least these port numbers. FTP, SSH, DNS, SMTP, POP, common numbers. Okay, there was a raising hand, Professor Payal. Yeah, ma'am. May you have any questions, queries? Let me check onto the chat box. No, not any questions. Okay, if you accidentally raise your hand, you can lower it. Or else if you have any questions, you can unmute and speak or put in the chat box. I'm not able to find anything in the chat box. The chat box is empty. So I believe, yeah, Dr. Mohammed, yes. I'm able to see multiple people raising their hand. Yes. Any questions, queries from the participants side? Those who are raising hand, Dr. Mohammed Shahid. Yes, sir. You have any questions? Do you want me to unmute? I hope the organizers have to do that. You can also have put a question in the chat box.
Hello.
Yes.
Hello.
Yes, sir. I was able to hear your voice.
Okay. You're getting my voice, sir?
Yeah, now it's clear.
Okay. So I would like to know one thing. Actually, the port number which you have mentioned here, like SSS and HTTP and HTTPS and DNS and all, right? While can we change these ports, or this port has been already fixed? It's
Yes, sir.
possible.
As per the, it's a good question. Like as per the protocol, you see, SMTP is for email. SMTP has the port number 25. As per the protocol, if you want to send a mail, you will be using SMTP protocol port number 25. See, let me go on the internet. Let me check. SMTP port number for Gmail, Outlook, Hotmail. Like I'm just searching this on the internet. Fine. Let's check onto the images. Just a minute. So this is standard set. Again, this is not hard-coded value, right? As you asked, as you rightly asked, right? This is not hard-coded. Fine. Let me open that in a new tab. Yeah. See this, it's not clear, but fine. Port number 25 is used for SMTP here. You are using a security, some XYZ protocols you use for security. You have set the port number to 587, right? So I remember like when you use a Gmail or a Hotmail or something, SMTP might operate in port number 999. It might operate in port number 998. It might operate in port number 890, anything. It won't take the common ports, it will take some random ports. As per the protocol, SMTP is bound to be used on port number 25. Gmail might use different, Outlook might use different, Azure or any other cloud or any other vendor might use different. Protocol says SMTP is default protocol. But you have a flexibility, you are a system admin, you are a network admin, you have a flexibility to change the protocol port, but you need to configure it in the right way.
Right. Because while installing the MySQL server and all, sometimes we need to use to change the ports as well, because they have already engaged by some any other softwares and all.
Got it. So that's what. Right. If you are a part of the university, there will be a de facto protocol for MySQL, right? For example, let's say MySQL port. There will be a de facto protocol.
8080. They usually 3306. Yeah, correct.
Yeah. But you see, like sometimes.
But if you want to change, you can change it. Yeah, sure.
Sometimes the college might have a firewall. Firewall will have a common rule saying that the attacker, whenever they come from outside, they are only targeting 3306. So the college might host the same MySQL server, the DB server, in a random port. Let's say they use the port number 7742, something different. They'll ask you to configure that port number, right? So that's a part of security. We call it as hardening. We don't want the attacker to see everything. We can harden it, right? But whatever you see here on the screen, these port numbers are the de facto ports, the common ports which can be used, which is used, right? And it can be, as he was asking, like it can be changed or tweaked based upon the purpose. It cannot be randomly changed. You cannot go at all times and change HTTP from 80 to 88 or 8080. You cannot go and change HTTPS from 443 to some random numbers, right? So if there is a need, you're open to change. Your network admin or system admin can change that. Fine. So we'll get back to the. Okay, we'll quickly walk through the topics. Packet analysis, you see, yesterday we discussed about this, right? So whenever a TCP three-way handshake happens, right, it is SYN-ACK act. Fine. So let me show you in a pictorial representation. So everyone says TCP is a reliable connection. The two mark which we say TCP is connection oriented, reliable. I am a client or else I am the sender. I say hello. Fine. You are the receiver. You say hello. Then after that, we start speaking, right? Just like we both make a call. I say hello. I say my name. You say your name. We both acknowledge. We start speaking. The same thing happened in a TCP handshake, right? It will be SYN plus ACK and ACK. That is called SYN plus acknowledgement. So for easy understanding, I am the, let's give some names, right? I am Ashok. I am initiating a connection synchronize. And for your understanding, I am giving some small numbers, 100. But in real world, this sequence numbers will be something like this. You might have seen that in Wireshark yesterday. For your understanding, I am giving a small number. Synchronize. Hey, I want to speak to you. Fine. Ashok want to speak to Lakshmi. Fine. Lakshmi will say, hey, yeah, I am also interested in speaking to you. She might send a different sync sequence. Fine. And she might acknowledge for my message. Minus 100. She might acknowledge with 101. 100 plus 1. 101. Then again, it comes to Ashok. Hey, yeah, Lakshmi is interested in speaking to me. She is acknowledged. I am going to acknowledge for her message. I will give her 201. Yeah. In layman terms, this is a three-way handshake. A sender's request, receiver's request, receiver's acknowledgement for sender, sender's acknowledgement for receiver. Right? This is called as a typical three-way handshake. Right? That's what the basic principle of TCP protocol, how it works. Fine. Okay. DNS checker. Who is, what is. Okay, I'll show you one website for the matter of fact of time. I'll show you a simple website. DNS info. Yeah, view DNS. There's a website available, which will let us know what are the things. If you want to find, we can find IP reverse lookup. Find enter a domain. I'm giving a common domain. I remember www.annauniv.edu, a common university in Tamil Nadu, right? It will go and say, hey, welcome. This website or the university is hosted their website on a public IP 14.139.161.7. This might not be the actual IP of the server, sorry, the website. It may be hosted on the hosting provider. Just like in the parking, you have 50 cars parked. Same way, that's a hosting provider. Let's say GoDaddy, it's a hosting provider. Hostinger, it's a hosting provider. NIC in hosting, Indian government has a hosting for universities, colleges, national cloud for NIC, right? So GoDaddy is a hosting provider where you can go and host your website there. Yet another hosting provider, Hostinger. I remember I have some of my websites here hosted. Fine. If you're a part of the college or university in India under UGC or NAC, right? Your college websites are bound to be hosted here in Indian government's server. NIC, NICS, National Informatics Center Services, right? So there you will be able to host your server, web server, application server, all the details. See, they have somewhere around, they have a database of 2000 customers, 4 national data centers, 24 mini data centers across the country. It's maintained by Indian government. Yeah. Okay, now we'll come on to the last part. Maybe we are on the last half an hour, right? So we're going to talk about firewall, IDS, IPS, security devices. Before giving you the definition of a firewall, I'll show you Fortinet. Fortinet is a firewall company. They have a demo online. I regularly show this. FortiGate is their firewall. Again, firewall can be a hardware, a device. It can be a software. You pay and get the license for 1,000 users, 10,000 users. Fine. Fortinet firewall. I'm not promoting any vendors, right? You have many different firewalls, right? They have a free login, so I'm showing this. You have a Fortinet firewall, you have a Sophos firewall, you have a Sonic wall, different firewalls, different make manufacturer for a purpose, right? Sophos is yet another firewall. Then Sonic wall is there. I remember my previous institution was using this firewall. Again said, it can be a hardware that is put on the network level in your college level, like you have a security gate. This firewall will be the security gate for all your incoming and outgoing data traffic. Fine. If I'm not wrong, it should be demo. Is it so? Let me check. Just a minute. No. FortiGate demo. It will be there in their website. I forgot it. I entered it long ago. Well, it takes back just a minute. Demo, yeah, the same thing I'm trying. Maybe a different URL. Just a minute. Yeah, this is another one. Okay. It was a different version I'm checking. Username is demo, password is demo, login. It'll hey, welcome. You can log into this firewall. It's a firewall available online, a free demo. Fine. I'm not sure why it's not allowing me to log in with that demo username and password. I've disabled the cookies. Let me enable it. Just a minute. I thought of showing you a live. We check. They have it open in their website. That should be available, publicly available. Admin. I'm trying to brute force. Just try not all the common username and passwords I know, but it will be logged in that server. Okay, enough of brute forcing. Close this. I have a password manager, so it's trying to open using password manager. No. See, the firewall have locked me, allowing me not to log it. NGFW. Credentials. Credentials means username and password. Let me check. I hope these things will be answered by any GPT platforms. You put it in a GPT platform, they'll say the default username. Okay, I missed this. Default username and passwords. You have to ask for it. That's a demo site. Let me check one final try. Checking to the demo site, but fine. Okay, let's leave this. I thought of showing you that website in the demo. Anyway, we'll check it. We'll complete the theory part and check that. See, firewall, IDS, IPS, all are different security devices. Small, medium, large, right? Like you see, just like you see different versions of crackers, right? Meant for a purpose. These are all security devices. Firewall will allow and deny based upon some filters. Allow rule, deny rule. The next thing is called IDS, intrusion detection system. It will detect an attack, but the attack might happen. The next thing is called intrusion prevention system. It will detect the attack and block it. It won't allow it to happen. It won't allow you to get into the network, right? So that's what is given here. You see, firewall is typically allow deny rule, right? IPS, you see the difference between IDS and IPS. IPS is placed on the flow. If IPS is not allowing, the data cannot go here. But you see here, IDS, The data will flow. IDS is only a tab for monitoring it. Fine. So after firewall, there was something called IDS, intrusion detection system. The attack might happen. Yesterday, the attack might have happened. Before 2 hours, the attack might have happened. This IDS, it can be a hardware or a software. It will find it and it will report to the system admin or your reporting people. IPS will detect the attack. It will stop at that place. Like security stopping you at the gate. It will stop. Hey, wait, you are not allowed to go in. It will stop it and alert to the admin, right? So firewall is the primitive device. IDS is the next level. The extended version is called IPS. Fine. And okay, the login should look like this, right? The Sophos login. Sophos is another firewall that's available, right? So their login will have a dashboard. Hey, in your college, you have 6,000 computers. Now, currently, there are 2,000 mobiles are connected. Each and every device, when they connected, how they connected, this will answer all your CIA, AAA, defense in depth principles, right? So the pictorial representation, the dashboard here shows all the principles, how they work and how they are measured here. It will say, hey, today, let's say take example today in your college or university, 6,000 login was there in the university domain. Out of 6,000 login, there were some 200 failed login. From the same system, the user have tried 20 times different password. You remember just now I tried on the website, right? So I don't know the username and password, trying some random known things, right? So everything will be detected and reported in this security devices. So firewall, IDS, IPS. Nowadays we have NGFW. That's what is given here. You remember the previous screen, we might have seen that. Sorry. In the previous screen, we might have seen that NGFW, next generation firewall. You see here, yeah, next generation firewall. That is called as 4840 demo. Stop. Let me check. I hope they have it in their website. That's common. Demo for username and password. Admin for the name and instance ID for password. Let me check. Just a minute. I remember trying this maybe last month or so. I'm not sure whether they have changed it now or updated it. Anyway, I'll get it. Maybe I'll get you the actual thing from their official website. Let's go back. Okay. Sorry. Okay. Let's continue here. Okay, there are some firewall tests online. Let me check. There's a slight delay. Just a minute. Let me. Let me open that in a tab. I'll close the other windows to save some memory. Word is not responding. Let me close that. Okay, it's showing the example of the. Close this. I'm ending the. Okay. Fine, let's get back to this. Okay. So we have seen IDS, IPS, firewall. IDS was there, IPS was there, previously firewall was there. The extended version of them are called SIM, XDR, SOAR, SIEM, security, information, and event management. Let's say you have a college, 2000 computers are there. In the college, there's a SIM solution available, the security device is available, hardware or software. What will be there in the SIM? SIM will collect all the logs from your system. You remember I showed you the event viewer log, right? Same way, SIM will collect the event viewer log from all the 2000 system. If I'm regularly using a SIM, I can say last 6 months in the college, how many times a faculty or a student have given the password wrongly, and how many systems they have given the password. The same user sitting in different systems, trying some different combinations of password, that can be found using this extended version of security device called SIM, SIEM. SIM is nothing but the log correlation. It will collect the log and it will analyze and give you in the dashboard. Fine. The extended version of that is called XDR, extended detection and response, right? You see here, log, events, incident, it will collect the logs, it will put an alert. Fine. And when you talk about SIM, see, again, we used to train some students, candidates for placement training. Maybe in the last year of the graduation, a cybersecurity student wants the cybersecurity placement, right? So when we talk about SIM, there is something called Splunk. There's a tool called Splunk. Most common tool on this industry, right? Let me open this. Open image in new tab. And there's yet another open source version called Wazoo. Wazoo tool. Yeah, open source SIM. Because in academics, we prefer much of open source versions, right? New tab, open video and new tab. You see here the screen of Wazoo, how it looks like. This is a SIM tool. If you are running this live in your system, total, these many systems are there. Count, Mac OS, Windows OS, Linux OS, how many attacks have happened, right? You see Mitre attack framework, it says how many password attack, how many SSH attack, how many brute force attack have happened, right? This is a dashboard. This is between January, February 2024, right? It's a threat hunting platform. So this is called as SIM or extended version of your firewall, IDS, IPS, right? So it's a log collection system. It collects log from all your system across different branches of your college or your company, and put it in a common dashboard and give it to you for the management or for the owner to check what is the current security status of the company. Fine. Just a minute. Yeah. Wazoo. And this is a Splunk dashboard. And many other things. There is something called IBM QRadar. Another tool. Fine. There's a tool called IBM QRadar. At another monitoring. Then there's a tool called Logarithm. It's yet another SIM tool. Fine. And the most common leaders in the market are Splunk, maybe the most commonly used. Splunk is used and Wazoo is used. You see here, IBM QRadar, Splunk, Logarithm, Azure Sentinel. All these things are SIM solution. Different SIEM applications or softwares, right? So what does that SIM means? Security, information, and event management. It will collect log, collecting the log, correlating what happened yesterday at 12 o'clock. What was the wrong password given? Alert. It can do it for older data also. It can give it in real time also. Now, this is running in your college. You're trying to give the password 3 times, 4 times, 5 times wrongly. It will alert to your SIM solution. Your system admin will call, hey, why are you using your faculty ID and giving the password multiple times wrongly? Whether you are using or someone is trying to use your ID. So that is the purpose of SIM. Real-time log collection, log correlation, and alerting mechanism. The output will be in a good-looking dashboard like this. You see here, it will show you a dashboard like this. What are the devices? What are the attacks in a statistics format? Okay. Fine. What is the need, importance? I leave it up to you to read. I hope I've just covered the stuff. Okay, just a minute. demo. Kaspersky cyber threat map, digital attack map. This is an interesting map. I'll show you. Digital attack map. We might see this older days. We might see this only during Diwali. There will be a photo showing that, hey, how many crackers have been bursted in India? It might show you some photo with some lighting in India, world map in India, right? But you see these maps, we call as threat intel maps or threat landscape maps. Mostly these maps are released by security companies or antivirus companies, right? So what will be there in the map? Let's check what this map is going to show us. Digital attack map. You see at the top, DDoS, distributed denial of service. If I don't want your website to run, I do a DOS attack. Multiple packets at the same time. Fine. So that is called as denial of service attack. In terms of principles, CIA, confidentiality, integrity, availability. DDoS affects maximum the availability. You see here the play button at the bottom. When I play, you see here the attack is going from one country to other country. These are all not like gaming stuff, right? This was the real attack that have been captured and it have been put it like a map. See January 23, 2015, what is happening? If you want to forward, I can check what is happening on May, June, September, maybe real time, what is happening, older one, current one, fine. This is one map, digital attack map, fine. So what is it? Let's check how it works. The attack is shown in map, fine, well and good. You see attack going from one country to other country like a game, interesting. What are the type of attack? TCP, volumetric, fragment. What are the source port? You see here, DNS 53. What are the destination port? 80, 443, DNS. Duration, the time of the attack. It's happening for 1 day, 2 days. Some attack might happen weeks, months, and years together, right? So when you scroll down, you will find something interesting. Most active countries. You might find India, yes. Active countries means attack might coming in and going out. It's not like only doing the attack, fine. You see here the map for India. It clearly shows the timeline, right? See the orange color, what all the attacks going in and out. We can explore this. Fine. It may be a bit delayed, the live map from my browser to your Zoom thing. Okay, I'll show you another map. Checkpoint is a security company. They have their live attack map, threat map. We call it a threat intel map or threat map. An attack is going from Singapore to Canada, then within Netherlands to Netherlands, fine. So you might find the statistics at the bottom. What was the attack? From where it is going? What is the attack? Fine. Okay. Yeah. Something popped out. Okay, see here. An attack happened from one country to other country. What is the type? It's a malware. What is the type of the virus? It's a botnet is one malware. Info stealer, it steals your username and password. It is also categorizing and showing what have happened here. Top targeted industries. You see here, they are showing which industry is targeted at top. Top targeted countries. Top targeted industry. You see education comes on the top. Top malware types, mobile. Now I have disabled the cookies here, so it's not listing completely. I normally disable unwanted cookies in my browser. I've enabled the cookies. I hope now you might see the just a minute. Okay. Recent attack, daily attack, day wise, fine. Then it's a 3D map, like obviously I need to allow the cookies for you to display. See, interesting 3D view map. Let me zoom into India. Yeah, it's here. Let's zoom and check. See, they are picturized and given. Like, we'll check the border. We may be interested in this place. See what all the data that is going in and out. Different types you see here. What is the results from intrusion detection system? What all the vulnerabilities? Whatever comes in pink color are IDS results. Whatever comes in yellow color are vulnerabilities. whatever comes in cases by the Kaspersky, they have detected and found. Fine. So this map looks something like this. Global attack map, detections per second, everyday, live, active. Fine. Yeah. I'll close this. It will take some memory in my browser. Okay. So again, one take home for today, like for this part, second part at least, right? See, if you want someone, a student, a computer science student or cybersecurity student who wants to get placed, industry or recruiters might be interested in a specific domain. We don't want them to master everything, right? See, when I was in academics, I was in industry, I just got to know all these concepts because I was bound to teach different category of cyber students over 10 years. So I've explored all these things. But for a student or even being a faculty, right? So you can take a specific domain. Sir, I am going to take a SOC domain, Security Operations Center. Whatever you're discussing now, Splunk, other things, is all about SOC domain. SOC cyber. You'll find a interesting image you see in movies. You see here a big screen, people sitting and monitoring it, right? Not CCTV screens. These are all screens of your company or organizations. How many computers are connected, where they are connected, what attack is going on. Looks like a TV station or a CCTV monitoring room. This is called SOC. In a nutshell, this is called Security Operations Center. Let me turn on the AI mode for you to say what is SOC and cyber. Just a definition. A centralized team of cyber professionals responsible for protecting the organization data. How they will protect? They will protect with the use of the security mechanism which we have seen, right? They will collect the log from firewall. They will use an IDS. They will use an IPS. They will use a SIM tool. They will use a SOR tool, extended version of SIM. They will use a UTM. All these things are different security tools, right? So SIM is typically extended to SOC. Security Operations Center is supported by these security devices. So students want to know what is SOC with all the basics which we had on yesterday and today, network foundation. They need to know what is a Security Operations Center. They need to know what is SIM. SIM is all about log. They need to know how to read a log. You remember we were reading a log from Event Viewer, right? Obviously, they need to read a log. Then they need to analyze the log and report it. Fine. Maybe tools and techniques, as I said, it's not at all times just teach the tools. The concept has to be explained to the students, right? Then we can say the tools. You need to explain SOC concept. For supportive, you see, you can explain SOC tools, right? When I put SOC tools, there will be some different SOC in the market. So you can put a SOC cyber so that you'll get an exclusive cyber tools. Yeah. Yeah, you see here, it shows the best SOC tools. And these are all reviews from different companies. It depends. But you see, I mentioned about Splunk, Logarithm, IBM QRadar, Elastic. There is something called ELK. It's an open source version. Elastic, Logstash, and Kibana. We use it in the research community, but it's not used in the industry because it's open source, have lots of vulnerability. Fine. So ELK also have something like a dashboard looking like this. Fine. What attack, how it is happening, and on. Fine. Yeah. Okay. So to revise, we'll go back. Fine. So today we have just gone through the previous thing, what was missed yesterday, the Linux commands. Fine. And we have seen system internals, a couple of things. And we have also seen something on files and permissions. So today we have covered these 8 topics: CAA, confidentiality, integrity, availability, AAA principles, other security principles, defense in depth, security layers, data breach. What is the difference between a hack and a breach? We have seen some examples of data breach. See again, there is a website for data breach. I will show you. Don't get panicked when something is listed here. Maybe you put your college name, your company name, it is listed here. There are many websites for notifying breach. Fine. You go there and give a company name. I'm doing www. I'm not going to put any live company. I'll put example.com. Example.com. Fine. When you put see my exposures, it will run for a while. This is many websites are available. This is one common website. This company, let's say BreachSense, right? What they do, like they collect the username password leaked online and they create a database. So you have a free user or paid user of them. They will check the list in your check your username or password, whatever you give, or your company name. You give your college name, it will show all the domains in your college. Admin at college.com, principal at college.com, right? CEO at company.com, whatever it may be. It will come up with the result. What all the data breach detected? How many user information is leaked? How many customer information is leaked? Leak is, you saw, like most of you are teaching computer science. You have a server, you have a database server. Database will be by default most commonly MySQL, right? So you see here on the right side an image. The data lakes will be something like this. That's a username, password, sign up column. The username and password are visible. The attacker is able to sniff and capture it, right? It will take some time. Let me close this. See, recent breaches. For your information, the recent breaches in 2025, you see here, data breaches of different companies or different make and model or by different hackers group. Fine. You see here, let us check what was our most recent breach on 2025 October. We are on this month, October, right? Let us check the top breach across the globe for this October month. It will list you, hey, a breach was there available in. Yeah, see this BQT lock brass. Data breach victim of this threat vector shows this many users and passwords leaked online. When I don't want to click it and expose something, right? It will be showing you what are the data breaches by different hackers group or attackers group. Fine. Okay, just a minute. We are maybe the last 5 to 8 minutes. Quickly revamping both these things. Yesterday we started with keyloggers, different types of viruses, hardware, software, starttypedoom.com, how a keylogger works, IP address, public, private, there is one categorization, IPv4, IPv6, another categorization, MAC address, it's a physical address, 8 into 6, 48-bit MAC address, how to find MAC address, we have seen. Then we have seen protocols, ping, ICMP, DNS, HTTP, HTTPS, MIME protocols, ISO, SLAS, total number of ports, firewall, how it works, NAT, virtual LAN. Then we try to do some subnetting, right, using online subnet calculators. We have seen Linux permissions, how Linux permission works, how to set a permission. For setting up this permission, I hope in that course, just a minute. In this course, right, in this free course where you go and take, right, you will be able to find this. We can change the permission using chmod, and there will be something called chown, changing the permission and changing the ownership. I'm not going to type it completely, it will be available here. Chmod, and you need to give the permission. Hyphen, what is the permission, right? You need to give chmod, what permission you need to change, for what file? /etc/ashok.txt, something like that. If you give, it will just change the mode. If you give change the ownership from one user to it will chon. Instead of 664, I can give 000. I can give 777. I can give 741. Whatever permissions. You remember we discussed on this, how this permission works. Read, write, and execute. 4 plus 2 plus 1. Okay. Yeah. So we discussed on ports and protocols, packets, security devices in the order: firewall, IDS, IPS, SIM, XDR, UTM. I've not discussed about SOR, XDR, UTM boxes, right? That may be confusing to you. So you can keep it in mind. Firewall, IDS, IPS, SIM. These four. Basic firewall. The next thing is intrusion detection. The next thing is intrusion prevention. SIEM is the log collection, correlation, and dashboarding system. Fine. The next 8 parts, cyber threat landscape. Cybersecurity, you see, like when we teach at the college or university, students they go for a hardcore cybersecurity job. What they will do day in and day out, it's going to be like two sides of a coin. Either they are going to do something offensive or defensive. Offensive in the sense, so-called hackers, they want to hack into the system and report to someone, right? Again, in college or university, even I don't do, like I don't recommend faculties to motivate or do something related to hacking, right? We need to just motivate them and do something related to information security. Like say like 10-15 years before, there were huge demand for the XYZ hackers. But nowadays, there's a huge demand for security professionals. Anyone can use a tool and do a so-called XYZ hack, but there is a hard-coded effort that are put. There should be a knowledge, there should be some experience to defend the network, right? So we need to train students specifically for the defensive part of cybersecurity. Obviously, we'll teach them how to do an attack so that they can safeguard. That's different. But the agenda should be something training them on the defensive part. Then we'll just walk through to the threat map, right? The global cyber threat map. Yeah. Countermeasures and hygiene. Okay, we'll see what is an attack, how attack happens, then how to prevent the attack, right? So you cannot put a single tool so that, you remember, like way back 20 years before, we have an antivirus. We put an antivirus, the computer is secure. That's not the scenario nowadays. We need to put different security mechanism for different attacks. So only we learn or know about what is an attack, how are the different types of attacks, how they are happening. Then we'll come back to countermeasures. In a single word, if you want me to say how to prevent attack, again, layman terms, we say we need to enhance security or put security. Technically speaking, or in cyber terminologies, security means it's all about locking and unlocking. Even more technical, it's all about cryptography and steganography. We don't use steganography more these days, right? We'll see that what this technique is. But cryptography, you keep this in mind. Cryptography is the art of locking, unlocking. Steganography is the art of hiding and unhiding, right? So the whole of the security relies on an algorithm. You lock in one side, you unlock in other side, right? So that is on cryptography. So today's topic will be from cyber threat landscape till cryptography and steganography. We'll walk through that. Before getting on to that, something was pending yesterday. Yeah, I remember we discussed on this, right? I was not able to log in into this website. FortiGate demo login, right? Let me copy this and put it in the chat box, maybe for your understanding. Can also try that. We put it for everyone. Yeah. The username password is demo. Fine. Yeah. So I'm logging in again. This is an example or a demo. Okay, when I'm logging in, they hosted it online, cloud, just for us to understand, have a look and feel, right? So we know, right? Whenever we want to see something, we want to feel something, we need to touch and feel. We need to see and feel. Same way, just to give us a look and feel, this company, they have their one of their demo firewalls posted online. So we are logging into it. So obviously they will allow us only to log as read only. They don't want us to edit or change anything. Just like an exhibition, you can go see and come. Fine. Okay. So let me make it full screen. Okay. So this is a dashboard, login screen or dashboard or thing of a FortiGate. Fortinet is the company. FortiGate is the model of the firewall, right? FortiGate virtual machine firewall. Again, nowadays we have a hardware-based firewall, like a device. We put it on the server room, right? Then you install a software. You can install it in your Windows server or Linux server or something. Nowadays, this software-hardware combination have migrated to a cloud. So the hardware or software might not be available in your premises. You pay for license. You are paying for a firewall for 6,000 users. You'll get a license. You only have a login and dashboard like this. Everything will be managed, maintained somewhere remotely on the cloud. Fine. Let me zoom in. Yeah, okay. So interface, as we have seen yesterday, interface is the different types of connectivity. Fine. So you see 1, 3, 5. If we can remember this port numbers, port number 1, port number 3, just like yet another switch or router. This firewalls also will have a port. Firewall, you imagine like a wall that is built between the external world and the internal network. Internal network is your college network. External world is the World Wide Web. And an attacker wants to come from external network to your internal network, they need to cross the firewall. Imagine firewall like your traditional security people. Firewall will verify, allow something, deny something, block something. Everything will happen in the firewall level. Fine. So interfaces, you can see here interface 1, 3. Yeah, interface number just a minute. The interface 1, 3, 5, 7, 9, 2, 4, 6, 8. So totally 9 interfaces are on. Maybe 9 different devices may be connected. Typically in firewall, right? For example, you have a firewall for your college. Your college has 4 buildings. Each building, there are 3 departments, 12 departments. By default, the firewall will be connected to the main switch or the main device of the each and every department or each and every network, so that the firewall can monitor what is going in, what is coming out within the internal network. Then the firewall will decide what to send outside the network, what to allow inside the network from the internet. So firewall acts something as a middleman between the internet, the World Wide Web, and the intranet. That is the network within our organization. Fine. So firewall policies, you remember yesterday we discussed firewall is all about policies. You want to allow or deny based upon some rule. Fine. So this firewall you see here, it's loading. Fortinet v7.6.3. There is a software version built 3510. See, there can be n number of policies, right? So it's loading. Yeah. You see, they have put a policy from port number 3 to 1. What is the policy? You see, when you just click, it will say what is the policy. Say internet 2 in the firewall number 2. The firewall policy is all, right? Disabled, all, disabled, always, all the days, all the months, it is disabled. What is the service? General, they don't want to allow anything into that. The firewall is accepted. It is allowed. It is a NAT. NAT is typically network address translation, converting from one external network to one internal network. There is another rule from port number 5 to 1. See, they have an intrusion prevention system. They have an antivirus solution that is mapped here. So this is on the top level. You write up a rule on from device to device. Rule can be written device to device, network to network. Rule can be written based upon ports, protocols, IP address. Even you can put a keyword. We don't allow any network data or packet with a keyword called hacker. It will work. Fine. Security ratings. We'll see what is there in the security ratings. You see here currently 18 results have been there, right? Uncategorized, audited log, data protection. You see what all the system uptime, unsecure protocol identified in one system. Two-factor authentication is not done in one system. There's an SNMP pooling that is passed. NTP, you remember yesterday we discussed the fancy number, port number 123. Fine. So this is how the firewall dashboard will look like. So there will be something called dashboard at the end. When you click onto the dashboard, it will show you the whole thing. How many users are connected to my college Wi-Fi now? Fine, it will give you a statistics. Currently, you see only 2 devices are connected. They are offline. Fine. Users, the total number of users. This firewall is yet another software or application. There will be an admin user for this. There will be a manager user for this. There will be an end user or client user for this. Router monitoring, network. You see here what all the networks available. If it is having hundreds and thousands of devices, all beautiful graphs will be loaded here. How much data rate, what it went and on. Fine. Let's check what all the live sessions available. Which device? If there are 100 devices connected, we'll say, hey, in computer lab 1, there are 30 devices. Currently, 18 devices are on and connected on the network. There's an accounts department. There are 5 devices. Now, currently, all the 5 devices are connected. That will be displayed here. As this is the demo one, they have not populated any devices here. Fine. You see here the data which is going from source. IP number 101 from 10. The MAC address is there. What was the data that went? How many bytes of data? What is the session ID? Right? Fine. See, that's the IP 172.30.72.100. They have some malicious traffic. You see the red color, session blocked. 43,000 requests from that website to the network has been blocked by the firewall. That's what it's listing in the red color, right? So this is how the logs, live logs will look like. Then inventory monitor. Hey, your college has 1,000 systems. How many Windows? How many Linux? How many embedded devices? How many printers? How many CCTV cameras? Each one device we call as an end device, right? See, it's listing. There's a Windows computer available. Fine. If you want to see more details about that, you can check onto the interface and check. There's another device. The MAC address is listed. There's a couple of other devices connected. Totally 5 devices are connected in this demo system. Fine. Let's check on to destination threats, right? Threat means you call a hacker as a threat. Someone from external is doing an attack, or someone sitting inside your company also may do an attack. Anyone who want to attack your data or infrastructure will be called as threat, right? You see the threats, they have categorized one threat. There's a failed connection because of this. They'll have a threat score. They'll just say why the threat came in, all details. Top system events. It will show what all the events. Yesterday we remember we discussed about how many people logged, how many people logged out, how many times they gave the password wrongly, how much is the session duration. Everything should be available here. And you see many numbers. You see here routing monitor, IPsec monitor, firewall user monitor, client monitor, APs monitor, access point. If you have a Wi-Fi configured, how many of them have connected to your college Wi-Fi, whether they are allowed or not. You see, like in college, I remember we used to set something like a username and password for faculty, a username and password for students. Faculty will have more privilege, student will have less privilege when they connect to Wi-Fi, right? So that can be monitored here. You see, failed authentication, as I said, from this IP for this protocol, maybe HTTPS connection, there was 26 failed attempts. When you check view session, it will clearly say how many times the user have given the passwords wrongly. When you scroll down, the complete data will be there. It's a demo, so they have not populated connected the DB for this. Let's see. So the network, the whole of the network will show only one device is connected now, demo device. So if it is a big network, you'll see a beautiful network diagram. And the network protocols, OSPF, BGP, routing protocols used for route the data from the sender to receiver. You can see what are the policies: denial of service policy, proxy policy, authentication policies. You can write a policy. You can add or remove a policy. Fine. Then traffic shaping, virtual servers, health check, generally checking the health of all devices connected here. Then VPN, virtual private network. You remember day one we discussed something about VPN. Or else we might have seen somewhere in bits and pieces about VPN, virtual private network. Between the sender and the receiver, that's a private network. It's virtual. Obviously, it will be enabled with XYZ crypto algorithms, right? The data is secure between the sender and the receiver. And many more. Fine, Wi-Fi controller, complete about things. So this is a complete dashboard about how a firewall looks like. Fine. You see here the policy, IP lookup, packet capture, monitoring what you want to monitor. So that's what when you hire someone, for example, when a company wants to hire your student for some cybersecurity positions, they will hire not only for cybersecurity, they will hire for network security, firewall admin, SOC admin, right? So your student should know what is this FortiGate firewall. They should be able to configure the firewall. They should be able to connect all devices. They should be able to regularly monitor this in the dashboard. Simple. Fine. Okay. So let me come out of this. We'll go back to the actual part for today. Okay. So cyber threat landscape. What is the landscape? Like we call it as an environment, right? We live in a forest ecosystem. The upward is ecosystem. We live in a forest ecosystem. We live in a desert ecosystem. We live in a sea ecosystem, right? Threat landscape is, again, obviously the whole of the world comes under the World Wide Web, right? Cyber threat landscape, there is every device is connected on the internet, everything is available on the internet. What is a threat? Threat, you remember we discussed, threat is typically an attacker or a hacker or a virus, right? So threat landscape will clearly give you a bird's eye view, right? A eagle flies, it will have the bird's eye view. This threat landscape you use as a tool or a technique or an application. It will give you a bird's eye view. That's what the firewall is giving. It is showing you what all the device connected, what attacks happening, right? And what all the remedies taken, fine? So to get on to this, we need to get to know these two keywords, the important keywords. Vulnerability and exploit, fine? So whenever, again, the most common interview question is, what is a vulnerability? In any cyber system, what is a vulnerability? I'll just start with the dictionary definition. Vulnerability is the weakness in any system. Weakness in a system is called vulnerability. Simple. So then what is a cyber vulnerability or vulnerability in computers? The vulnerability can be a weakness in your hardware, chip, board, CCTVs, printers. The vulnerabilities can be in your software, MS Office, MATLAB, any other applications. The vulnerability can be in your firmware. You see some devices have a middleman firmware. Again, vulnerabilities can be in your operating system. Operating system is yet another software, extended version, right? So vulnerabilities can be in hardware, software, application, or anything, right? So that is vulnerability, weakness, right? Then we'll go for exploit. Exploit means attacker finds a vulnerability, they exploit something. Someone finds a wall in your college somewhere weak, they come, they break it, and they enter into that. That is an exploit. Exploit, you can imagine a bomb. Someone finds a vulnerability, they put a bomb, they break it, and they go inside. So that is called vulnerability, exploit, and threat, right? See, there will be definitions available. Vulnerability is a weakness in a system. Exploit is a attacker, typically a threat that can attack your vulnerability. We'll have some detailed things. Yeah. So this should do good. Fine. Let's check. Yeah. So let's take a couple of use cases. Vulnerability, threat, risk. What is the risk? Right? Riding a bike without a helmet is a risk. Fine. There will be consequences of risk, right? Same way here, risk is an attack. You imagine a cyber attack. Your password is leaked, there is a risk. Your question paper is leaked, there is a risk, right? So for a risk to happen, you see the formula. For a risk to happen, what all the ingredients? There should be a vulnerability, and there should be a threat acting over there. So vulnerability plus threat results in a risk. Fine. So you see the definition, weakness in the system is vulnerability. A cyber incident. Incident, here we call it as a attack or compromise or fancy words, hack, right? A cyber attack or cyber hack is called because of a threat, right? And the chain, when you talk about a chain, there is a vulnerability, that's a threat attacker. When vulnerability and threat is combined, the attack happens. That's a risk, you lose something, fine? You see the example, company has no ransomware protection for Google Workspace. We have seen this in many colleges recently, fine? So a college working, they have just hosted their mail server in Google or Amazon, or they have their own hosting space. So one of the faculty or employee clicks onto the link. The link is the fancy virus called ransomware, right? The ransomware is a virus. When you click, it will just come into your system. It will know how many documents, how many audio, how many video you have. It will lock all the files. It is going to lock all the files, put a single lock, and ask for money. Right? Flight hijacking. Someone hijacked the flight and they ask for money, right? Kid hijacking. Older days, thieves used to hijack kids from house and then they ask for money. Ransomware is typically a digital hijacking in which the attacker will get your data. They are not going to take your data and put it in a remote server. In your laptop, data will be locked, but the lock will have only one key. The lock will have only one key. The key will be with the attacker. Let's imagine your kid is in your house. They are safe, but they are locked inside the room. You are not able to get them out. You can hear their sound, you can see them, but you are not able to take them out. You need to pay to them, get the key, unlock, and bring the kid outside. Instead of kid, here is your data. When the ransomware infects your system, it comes to your system. It will scan all your useful files audio, video, documents, everything, and lock all the files with a single algorithm. Fine. Who sends? A cyber criminal sends an email to the company. The employee clicks without knowing that. Once when it is clicked, within 5 or 10 minutes, the attack is done. Right? All data on the company workspace are encrypted and locked. There is a single key that can unlock. Only you need to go pay to the attacker and get back that. So when we are discussing on this, I'll give you an example of low-key ransomware. The most common ransomware, maybe the superstars of ransomware that's available. Low-key, BitLocker. I'll type BitLocker, the traditional ransomware. Yeah, you see here, a note will be here like this. Let me open that. Cool, that's not clear. Okay, this note will be something like this. Once when your system is locked, you will see a note like this. Hey, welcome. I am the virus. I've locked your computer files. You need to go online, pay to my master, and get the single key to unlock. They won't ask you to pay in UPI or GPay. Right? They are doing some offense, right? They ask you to pay in something called Bitcoins, right? Virtual currency, cryptocurrency. You see, recently we heard in India, Bitcoin price is somewhere around 1 crore or something, right? 99 lakhs, 21,000, right? So they'll ask you to pay in Bitcoins. They'll give a Bitcoin wallet. You need to pay in Bitcoin, right? So how they are locking? See, they will be locking this using, let's check this BitLocker ransomware uses which encryption, right? These ransomwares are way to do. They are available over a decade, right? They'll be using new upgraded versions of encryption algorithm. They are using AES. Let us assume we'll see the crypto algorithm shortly today itself. But you keep in mind AES is a crypto algorithm used by BitLocker ransomware to do an attack. Let me open AES. I'll put up in how or else time taken to break this AES. I'll give some numbers also. AES will have 128 bit, the least bit I'm giving. Fine. You'll see some fancy years, fancy results in the number of years. You see how many years it will take. If you are running a server to break the password, for example, ATM will have a password from 0000 to 9999. It will have the whole password, right? If you want to try all passwords and break the algorithm, fine, or break the law, how much time it will take? Trillions of years, right? Let us see what is a trillion year. Trillion year in number. What does trillion means? Trillion is, you see here, 10 to the power 12. These many years. You know, 1 year is 365 days. Fine. So if someone wants to crack the algorithm that was set by this ransomware, right? They need to use a password cracking tool or server or thing. These many years continuously to break the algorithm. Practically speaking, that is not possible. And I throw you a disclaimer. Current day we are discussing about quantum cryptography, right? Quantum crypto includes this quantum attack and other things. This is the current research topics. Using quantum, the trillion years can be reduced to very less numbers, right? So if we don't use a quantum crypto stuff, right? Use a traditional server to crack the algorithm. For you to crack a AES, it will take how many? 1 trillion, some trillions of years. So at the end of the day, what you need to do? You need to go pay to the ransomware unit and get the key back so that you can unlock your data. I remember maybe 5-7 years ago, there was a faculty who had her PhD thesis defense. The day before her thesis defense, her system was locked. She clicked onto that link, somewhere came on the mail. Morning when she wants to present, all her PPTs in the desktop was locked. There's a file name called ppt dot some rename is there. She was not able to open the file. I remember she paid somewhere around $200 and unlocked and got the ransomware key and unlocked all of the data. Right? So that we are talking about vulnerability, weakness in a system, threat is an external actor. The result is a risk. Some attack might happen. Fine. All these things, when we talk about risk, you see, we'll see some advanced topics in risk, maybe the last day, right? So what exactly is a risk? You have a risk, you accept the risk, right? For someone says, hey, you are driving without a helmet, you say, hey, I know the risk, I accept the risk. You avoid the risk. How to avoid? You use a helmet so that you avoid the risk. You transfer the risk. Without you driving, you ask someone to drive, or you put the helmet and you ask them to do. You mitigate the risk. Both of them driving will use the helmet so that they are not affected, right? So a risk can be a cyber attack. It's a combination of a threat and a vulnerability. Either you need to accept the risk, you need to avoid the risk, you need to transfer the risk, or you need to mitigate the risk, right? So these are the all possible combinations of dealing a risk, right? So companies might hire maybe cybersecurity students or computer science students a specific rule called risk management in cybersecurity, where they need to know network security, they need to know threat, they need to know vulnerability, they need to know risk. There are some formulas for this. They need to know how to calculate the risk. They're not going to do this one time. Day in and day out, they're going to do the same thing, right? Okay. So when we talk about threat actor, the attacker, it can be a virus that can do an attack. It can also be a individual, so-called hacker, right? You see here malware, ransomware. We discussed about ransomware now. And I'll show you some real cases of ransomware, right? I'm randomly typing off some news. I heard it. You see, this was the 10 years old news. Fine. 2015. Those days hackers news page. Okay, you see here, 10 years ago, there was a ransomware group attacked some country's police department, right? Chicago Police Department. Illinois is a city, right? And they have paid a ransom of 600 bitcoins, right? 600 bitcoins to unlock the data. What is the data? It's the data of the police department in one US state, right? You see, they know how this crypto algorithms are used. You see, just a minute. Let's check. They have paid $600 in Bitcoin, right? $600 in Bitcoin. Nowadays, the rate may be something different. $0.000, right? Bitcoin in 2015. Let us check. Bitcoin rate in 2015. Just here. See the Bitcoin rates, it will show the different rates. In 2050, what was the rate? $1 will be some rate of Bitcoins, right? So they might have paid $600. Roughly in Indian money, they might have paid like 1 lakh, 2 lakh, or even greater to get their data back. You see why I am showing this news? A police department is attacked by ransomware. Even they are not able to do something and get the data back. They are paying and getting the ransom back. Fine. So that's the severity of this type of virus called ransomware. Malware, again, anyone teaching a cyber course, right? We might have teaching something about virus and a worm. Different 2 mark, maybe differentiate between virus and a worm. A virus is a application. Malware is a malicious program that need a host. You know, coronavirus, it comes into someone, right? What is a worm? Worm is self-replicating, right? So in 2000, there are 2 categories of bad programs. One is virus and another one is a worm. But in 2025, we have malware. You go to supermarket, you get everything. Same way, malware is a family of bad programs. Malicious software, that is called malware. Virus, worm, Trojan, ransomware, rootkits, 0 days, exploits, everything comes into place, right? So we'll see, you know, virus, right? Virus is an application infected. When you click, it will get infected, right? We have seen what is a ransomware. I'll give you one example of this virus category. Trojan horse virus, right? Trojan horse virus. It's a virus. The name has a meaning because you see a horse, wooden horse. In older days, Greek and Latin, one country, a king of one country presented this horse to another country king. Fine. That's what is called Trojan horse. Not a small horse. It is 10 feet, 20 feet. Their building height horse. The other country king got it. They kept it in the fancy, like you see, keep it in showcase. They kept it in center of the city. But inside that horse, the opponent country soldiers are hiding. They found the right time. They come out of the horse. They invaded the country and they won. So Trojan horse can be anything. You download a calculator. You download a cracker software. You download movies online, right? Pirated stuff. Everything can come with the Trojan horse. The outside application might look legitimate. Inside that, another virus should be there. Trojan horse is as such not a virus. It's a carrier, carries any other virus, right? So that's Trojan horse. And you see here SQL injection, DDoS, social engineering. This is interesting. Social engineering, you see at the bottom, fine. You see, no network is 100% secure. Why? Because humans are the weakest link in the any network, fine. So if the attacker is not able to find a vulnerability in hardware, software, application, the attacker will find the vulnerability in humans. That technique is called social engineering. I hope someone have raised your hand. You have any questions, query, chat box? Let me check. Someone is asking to unmute. I hope the team can check. Dr. Mohammed Shahid is asking for an unmute. If there's a permission, you can unmute. Or else he can type the question in the chat box. Fine. Let me continue. Yeah. Social engineering is an attack in which the attackers exploit the weakness in an individual. For example, someone calls to you, say that nowadays cyber attacks are happening like that. Someone will send a message from your principal photo saying that, hey, your principal might be actually on a vacation. He might have gone to Singapore. They'll send a message saying that, hey, I'm in Singapore, I got struck, my purse is lost, something happened to me. I want you to send me money to this account. Send me 1,000 rupees, 2,000 rupees. Why your principal is going to ask money to you? But the mail will be sent or message will be sent to 100 faculties in your college. Without knowing that if you send money, you are being a victimized of phishing attack. Extended version is called social engineering. Fine. And there is another category called zero-day attack. You have an antivirus, you have a firewall, you have an IDS, any security solution. This is the advanced version of virus that can bypass everything. And that's what is called zero-day. Today, we are finding a virus. Indian government is finding a virus sent by, let's say, Pakistan hackers. They will name it as a zero-day. Fine. I'll give you an example of a zero-day. Zero-day is tied up with something called APT. Let me type APT 36, Pakistan, India, postal. This is one of the virus. Let me check on to AA mode. What it is saying all about APT postal virus. Yeah, you see, 3-4 months before we were working on this, our team was working on this attack, how it happened and other things. In March 2025, a Pakistani linked hackers group, APT 36, they don't know the virus, right? The name is Advanced Persistent Threat, APT 36, right? That started mimicking Indian postal website and sending message to all people having account in post office saying that, hey, welcome to Indian government new post office application. Welcome to Indian government post office website. Someone clicked and they gave the money because they might have a computer with antivirus, mobile with security, but this is an advanced form of virus, right? It's called APT, Advanced Persistent Threat. They come in the similar category of zero-day. Fine. Let us check on to the images. What happened with this APT? That was set by a group called Transparent Tribe, hackers group. It was claimed that the hackers group belonged to Pakistan. Fine, let me open this. Yeah, they have just some security team have done some research and they have applied. See the left side, the original postal website is hosted on this website. Right side, the fake postal website is posted on this website that was registered in the other country. Fine. So that is zero-day. So attack, why we came into this topic, we are discussing about threat and vulnerability. Vulnerability is a weakness, threat is an attack, risk happens. So threat, different types of malwares and virus. That's how we jumped on to this malwares and virus, right? So types of cyber attack, different types of malwares and virus. Have I been found? URL void, have I been found? Yesterday, you remember we discussed website where you can check whether your mail ID is there in the compromised list, right? That's a website called URL void. URL checker. For example, you are getting a URL today. Hey, that's a price available, or so there's an offer available for crackers online. You just pay 2,000 rupees and get crackers for 20,000 rupees. They might send you a fancy website. You can check that URL. For example, I'll type www.example.com and check it. I'm just taking a random website, right? So it says 0 out of 41. Detection count 0 out of 41 security devices are found. This is a genuine website. If you have got a link, right, you can clearly put it here. It will say whether the link is a virus or not, right? Or the link is genuine or a malicious one. Fine. So today we have seen from the starting, we have discussed about vulnerability, threats, risks, right? We'll see attack vectors. You know vector? If anyone is good at math here, right? Vector, right, magnitude and vector. Vector will have a direction, right? So from which direction something is happening, or else from where the attack is happening, right? That is called attack vectors. Let us see the attack vector here. You see here? You have a computer, you have a server. There are weaknesses in your computer. I'll give you a real world example, typically for colleges and universities, right? So you might be having a network. You have a software which you got licensed 10 years ago. That software will work only in Windows 7 or Windows XP, older Windows computer. Your IT team will ask you to update the OS. You will say, hey, the licensed software is there. If you don't want to update the OS. Because like every OS, every software, every hardware will have a vulnerability. When you pay and get it, the owner of the OS, Microsoft or Apple or whomever is giving, they will regularly release the update. Update will have only patches. What was the weakness? What was the vulnerability? What was the patch, right? You see here, you remember the news, Microsoft support for Windows 10. I hope most of the colleges might be using Windows 10, right? Yesterday was the date. If I'm not wrong, let's check. Yeah, this is the date. You check it, check this page. Maybe, yeah, 14th October 2025. That was yesterday. Till yesterday, Microsoft was giving support to all Windows 10 devices. Every week they'll give new updates. Because they released this in 2015, most successful Windows version after Windows XP. It's used for more than 10 years. Now Microsoft have stopped the support from yesterday. From today, there won't be any support. Even a big problem is there, they'll give the patch or something, but they won't give a regular support. Microsoft wants you to go to Windows 11. If your college is regularly following a security audit or something, your IT team will clearly say, hey, we need to remove all the Windows 10 computers and put Windows 11. If you've already paid for Windows 10 license with some extended versions, you can upgrade your OS from Windows 10 to Windows 11, right? That should happen. So a weakness in a system, what are the attack vectors? Social engineering, someone calling to your office and say, hey, I'm the PA for your principal, give me this username or password. Malware, website-based, network-based, physical attack, password-based attack. The attacker will know a weakness in your system and do attack. You know, right? You have your friends, you have your family members. You know how to befriend your friend. Or else you know how to say something to your kid. You give a chocolate to them, they behave something different. You know their weakness. Same way, the attacker wants to like do an attack on your college. They'll find what is your college public IP. They will scan your outside systems. If they were able to get into your network, they will scan what all the systems inside. They will scan what is your IP, what all the MAC address available, what all the ports and protocols available, what all the operating system which you are using, which version of software you are using, everything they'll do. Then they will put an attack, right? When you, again, even when I teach some courses on hacking or ethical hacking, some courses available in the market comes in this name, right? So they will teach something called, before doing the attack, you want to do a footprinting. We call it as a reconnaissance, gathering basic details about the victim, fine? Then do an attack. Use case fish tank, right? That's a website called fish tank, not FISH. This is PHISH. You are able to find a malicious website URL. You are getting a link saying that, hey, I am your principal, do something. You can copy that URL and put it here. For example, I'm copying a URL from here and putting it here. Is it a fish? When I ask, it will verify. Again, it's checking whether I'm a human. I need to put a tick mark for the CAPTCHA. Yeah, I'm a human, verified. No screenshots it. Visit the frame. See, it's saying that this website is vulnerable. You see, the first link is available. When you click onto the details, ID number, this number, someone have reported the website is vulnerable. If you want to get more details, obviously you create an account in this website and log in. Fine. So this is fish tank where you can go and check whether the link you are getting, your got, is a genuine or not. After clicking the link, if you are trying this, no use. Already you are infected, right? So before something happened, you can check it on websites like this. Phishing quiz Google. This is an interesting quiz. Phishing quiz by Google. Can participate it. They'll ask you some 10 questions, right? We're not going to try it now. It'll, if you are doing it step by step, it'll eat up maybe like 20-30 minutes of that. But I'll share you the document. You'll get it in the document. So you can just go. You need to log in, take a quiz. It will just ask for a username and password. You give it and start it. It will give you 6 phishing pages, right? For example, Google phishing quiz. I'm not going to log in now. I'll show you how it looks like. Google phishing quiz. Yeah. Yeah. So they'll give you some 10 mails or 10 websites link. How it looks like. I want to save this. Sorry. See here on the website, fax message received from admin. Click on that link. You need to read that and say whether it's a good link or bad link. They'll give you a test of 10 out of 10, right? So based upon your results, you can conclude what is your ranking, what is your security portion, right? You get 7, 8, 9 out of 10, well and good. You get 2 out of 10, 3 out of 10, you need to repeat it, right? That is on this. Scam advisor, you can check it. So before I go on to the next topic, I want to summarize the whole thing which we have seen. We have seen a vulnerability, weakness in a computer, hardware, software, or network. We have seen a threat, hackers, malwares, virus. We have seen the risk. The other thing important here is asset. ASSET. We have not discussed on this. Asset is your property. Your computer is your property. Your data is your property. Your laptop printer is your property. The attacker wants to do an attack, right? They need to do attack on something. So your asset, you have an asset. The asset has a vulnerability. The vulnerability is exploited by the threat actor. The merge of all these things, the intersection of all these things is the risk, right? So again, when we go for interview, right, we want a candidate who's applying for cybersecurity has to have a clear-cut idea about this. Define each and every term with an example and differentiate between threat and vulnerability, risk and threat. They should be crystal clear on this, right? Because the whole of the day in and day out cyber job is going to be revolving in and around vulnerability, threats, risk, and on. Fine. Global threat map. I hope yesterday we have seen the same threat maps, 2 or 3 cyber threat maps, right? Global threat maps on Kaspersky digital attack map. Fine. Let me open again. Kaspersky global threat map. Live map. Okay, let's check. Okay, map is getting populated. Fine. Let us check on to data source. See from what all the sources they are collecting the data. Let's check on to the statistics. Detection per second. How many attacks are happening per second? That will be listed here. Fine. I have disabled the cookies, so it might not display here. We'll see onto the map. Yeah, the same thing which you have seen yesterday. See. So this might be a live map. You see from India, what all the different types of attacks, how it is identified, right? From which source, which destinations, what attack are happening. The map might look fancy, exaggerated, right? But actually that is from the statistics. It is not a demo map or dummy map, right? So this is extracted, the map is put, the statistics are created based upon the current attacks happening in real world. Fine. Okay, we have seen a cyber attack, threat, vulnerabilities, attacks, everything is clear, right? Again, so before getting on to the countermeasures of cyber attacks, let me show you some. Again, when we teach at the university, we teach students clearly about define a virus 2 mark, define a worm 2 mark, differentiate between virus and a worm, define a ransomware. Everything is good, right? In real world, the interviewer's questions will be, hey, let me know what's a ransomware. So ransomware is a program uses cryptography to lock your data and ask for a ransom money. You need to pay them in bitcoins. Definition is okay. Give me an example of ransomware. The student is not able to say an example of the ransomware. We believe the whole of the definition which you have said is only a book bag. You have just written it for clearing 2 marks, 4 marks in exam, right? So you talk about any virus, malware, ransomware, you need to have at least one example each, right? For example, example of a virus, right? I have something in mind, right? For your understanding, I'm searching it, right? Example of a virus. Let's talk about a computer virus, not a biovirus. Okay. Viruses are having different categories, right? Let's say example of I'll type this way. Superstar will be the most. Again, that's a game. It's going to the game, right? You see this? Just to check the famous viruses, right? On a new tab. At least this. I hope we'll have this in our what to say book examples. 2000 there was a virus called iloveyou.txt. What is the virus name? Let me type it in the notepad. In 2000 there was a traditional virus called as iloveyou.txt is the actual file name, but the virus will have an extension called .vbs. iloveyou.txt.vbs. So that it typically looks like a text file, but actually it's a VB script. Those who maybe the faculty those who are teaching for over a decade, you know. Now we teach Python, Perl, something. Previously we had C, Java. Previously we had Microsoft .NET and on, right? VB script is one technique, right? Visual basics, right? So iloveyou.txt.vbs is a virus. It's not going to do anything harm. It's going to circulate. For example, it will have a mail. Hey, welcome with virus. Something will be there. The same mail, if you click, the mail will be forwarded to you. You belong to college. It will be forwarded to all the 200 mail IDs of your contacts, right? Contacts in email. Fine. Yeah. So when someone says a virus, at least you should be able to say, hey, this iloveyou.vbs. is a virus. Code Red, SQL Slammer, Stuxnet. Stuxnet is the extended version of the virus, right? Again, Stuxnet is the one virus, right? Comes in the category of virus, Stuxnet, but it was a mixed hybrid. It was a Trojan, it was a dropper. You see, like, what is Stuxnet? Stuxnet is the first proof of concept malware, which is sent from one country over another country. One country want to do an attack on another country, so they created a specific virus malware in this name. They sent it to the other country. They didn't send it to their postal system or they didn't send it to the transport system. They sent that virus to the nuclear power plant of the other country. You see here, Stuxnet, sender, receiver, and there are some claims which country sent, which country does not send. We don't want to get into the politics, right? So Stuxnet is a malware, fine. You see here, it was created by, officially it was believed to be created by US and it was sent to Israel nuclear power plant. Sorry. Let me zoom in. Okay. So it was believed to be created, a combination created by US and Israel, front nations. It was sent, the victim was nuclear power plant of Iran, right? You know, Iran and Israel opponents, right? So it was sent to the Iran's nuclear power plant, right? So let's check like result of Stuxnet. What happened after this Stuxnet virus was infected? I'm using the AI mode of the Gemini that's available here. Fine. It delayed the enrichment. The nuclear power plant was running. It just reduced the speed or increased the speed of centrifuges of the nuclear power plant, right? And typically it just caused the damage to the nuclear power plant, right? So that is called Stuxnet. That was one of the first malware came into that. Viruses can be put on hardware also, right? Because Stuxnet was infecting the uranium nuclear power plant. You call it as IoT nowadays. The extended versions are SCADA or ICS, right? So that was on this Stuxnet. Then Trojan rootkit generic. So when someone says ransomware, at least they need to know. I'll give you a version. Karma ransomware. It was believed to be Indian version of ransomware. Karma is a ransomware. I just asked a question in in an interview to a student. Hey, what does karma means? If he may give a traditional authentic definition of karma with respect to his religious beliefs, right? Can you let me know what is karma ransomware? Student should initially know what is a ransomware. Then he need to know karma is a type of ransomware or the name of a ransomware. Then he should answer. If he's able to do this, the interviewer will be convinced. Hey, okay, I believe that the student knows about virus and ransomware. Fine. So now let's jump on to the countermeasures, right? We have seen attack, right? How to prevent the attack? We are training students to, as I said, not completely on the offensive stuff, attacker stuff. We are training them on the defensive side. We need to train them to defend the network. How to secure? Strong authentication, a strong password, regular software update. I said, right, Windows 10 stopped their support, right? So then you need to go to the next version, or else you need to have support for the older version, right? Phishing awareness, instead of sbi.com, someone may send you a link called sbl.com, right? Regular data backup. The ransomware attack, you already have a data backup. What you can do, you format the system and put the data back, right? There is no data backup. Only the system is having one data. No use. You need to pay them and get the money back, the data back. Fine. Reputable software, security softwares, having an antivirus, IDS, IPS, firewall. Secure browsers, using a browser with some security, privacy enabled. Device security, physical security on things, devices. Identity monitoring. You remember this identity monitoring clubs with AAA principles. What is AAA? We can remember yesterday's session. Authentication, authorization, accounting, right? We remember we have seen the password generator and other things. Okay, security means password. Any layman term will say, what is security? Putting a password, right? So then we'll see how to keep a strong password, right? Okay, fine. So again, password is one form of authentication, right? You see when we type here, authentication, who, what, why. When you click it, check onto images. Fine. I want to see this image. Just a minute. Yeah. So I want you to explain with this image. Fine. You see here, knowledge factor, and you have something called as possession factor and inerted factor, right? Knowledge factor, these are all different types of authentication. If you want to verify, if you want to keep your data secure, when we go back, you want to ensure confidentiality, integrity, availability, you need to lock the data. You need to put some security. For putting some security, you need to enable authentication. Authentication is putting a lock. One of the most common lock we put is a password, right? So the knowledge factor is something you know. You know your password, right? You know your security question. You forget the email, you give a security question. You know the pin for your phone, 1, 2, 3, 4, other things, right? That is knowledge, what you know in terms of authentication. The second thing is possession, what you have in hand. I have my smartphone. You know, right, nowadays when you log into Gmail will ask, you log in from a new device. Hey, I have sent a code to your mobile, click on number 17. What it is doing, you have given the right password. It is enabling, it is asking you to verify whether you are the owner. It is using another factor. If you are using more than one factor of this, that is called as two-factor authentication, or else multi-factor authentication. You use the password and smartphone. You use the PIN and the biometric, right? So third one is inerted factors. I know something, I have something here, but something is within me. That is called inertance factor, right? My fingerprint, my retina scans, my voice, everything comes as inverted factor. So broadly, authentication can be done using any of these three family. One is what you know, second is what you have in hand, third is whom you are, what is inside your body or something, right? Password, security question, PIN, smartphone, smart cards, and hardware token-based authentication. Fingerprint, retina, facial, voice recognition comes under the third factor, right? So these are all the factors of authentication. Password is one most common authentication mechanism, right? So then how to keep a strong password? When we talk about a strong password, I remember many places where we go for security audit, especially in colleges, right? So they might have written a password and saved it in their email draft. They might have written the password and put it in sticky notes, paper sticky notes, or else computer sticky notes, right? In the desktop, right? No use in having a password, right? Passwords are something you need to remember, fine? For example, when we went to an audit for a college, right? The government have sent a notice to the college. We were called in to do an audit so that the college has to say to the government saying that, hey, my college is secure, or else the government would put some fine, right? The college had some many departments. The password set by the admin we did the audit in 2022, right? The system admin gave the password to HOD, you know, right? How top level management will have the password to HOD in 2019, right? 3 years ago. What was the password? CSC at 123. ECE at 123. Fine. Something like that. So the actual password was, I don't know how to mention the college name, right? I will mention the college name as XYZ. XYZ CSC at, they have given it as, I exactly say, they have given it as 2019. Then what might be the ECE password? XYZ ECE at 2019. You see, just by knowing one or two passwords, if I'm an attacker, I'll be able to guess, right? XYZ MEC at 2019. If not, XYZ MECH at 2019. You see here? EC guessable passwords, right? Password should not be something like this. And when you teach students how to set a password, so-called strong password should have 8 character. That is in 2020. Now in 2025, you need to have a minimum of 12 character. Fine. It should have a caps. It should have a small. It should have a number. It should have a special character. And having all these things, you should not write it and keep it in a notepad or a sticky notes. Let me say I am Ashok Kumar Mohan. I am setting this as my password. Fine. It have passed the first criteria, minimum 12 character. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm secure. Fine. But you need to have a caps. Let's say, let me put Ashok as caps. Bit secure. Kumar Mohan is small. Okay. I want to put a number. Let me say I see a 0 here. I replace this 0 with O. Sorry, I replace this O with 0. Fine. Fine. So I have an A here. Replace it with at. For additional security, I put a $, and I say my year of birth. Fine. I should not put this year of birth. Someone can guess it. I'll put my fancy number. I like this number. Fine. This is a strong password. You know, right? First name is capital. All other things are small. In that small, I've replaced O with 0, and I have put at the replace A with that. Even if you don't want this, right? You don't want to make it more complex. Let this be the password. Fine. Something like that should be set, right? And I should not reuse this password. Fine. Yeah, this is passwords. Fine. Okay, let's come back. Authentication, you see, we have discussed authentication is verifying mechanism. You want to get in, you need to give a key. You need to put a biometric. You need to type something, right? Password, OTP, multi-factor, token-based, biometric, different types of authentication. Password-based, biometric-based, single sign-on, one-time password, OTP. You know, right? That is called OTP. Every day for your messages, you're getting an OTP, right? You want to send 1,000 rupees to so and so. Your Canara Bank OTP is 12345 6, right? OTP is yet another authentication mechanism, right? Multi-factor token-based authentication. You see Google Authenticator. How many of us are using Google Authenticator? I use it, right? Google Authenticator is a Play Store app that's available from Google, which is free of cost. I use it for all my mail IDs, irrespective it's my personal mail ID or company mail ID. If this is enabled, any person from a new location is logging in, it'll ask the authenticator from my mobile app. The token will be randomly generated. It's a time-based OTP. The token will be generated every 10 seconds or 20 seconds. You see a timer will be running. So I recommend everyone for normal account, sensitive account, just use an authenticator. Google Authenticator is there, Microsoft Authenticator is there, some third-party authenticator is there. Zogo has their authenticators, right? Each and everyone has their authenticator app completely free of cost. You don't want to pay for any of the authenticators, right? It's available in the Play Store. You can take it and use it. All these things, when we teach at the college or university, we teach students this authentication is backend by an algorithm called OAuth, Open Authentication Algorithm. Again, when someone goes for an interview, we'll ask what is open authentication. If you teach it in a course on cryptography or something, that should be made clear how OAuth works and how it. Okay, now let's come to cryptographic basics, right? Symmetric, asymmetric. Those who are brand new to cryptography, I'll say cryptography is a mechanism of securing data, right? Cryptography means encryption, decryption, locking at one end, unlocking at the other end. Obviously, locking and unlocking needs a key. You have a key, fine. And cryptography is of two types: symmetric, asymmetric. Symmetric means I lock the data with key number 7. I'll send you the same key number 7. Both the sender and the receiver will use the same key, right? For your understanding, I'm saying the key number, right? Key value is 007. Let me give a fancy number. But in real world, the key values, just like we saw the sequence number in the Wireshark acknowledgement number, the key values will be pretty lengthy like this, fine? And again, those who are from a mathematical background, math is the foundation for whole of the crypto. It uses prime numbers, fine? You know, like 7 into 3. Sorry, I'm not good at math. I take small numbers. 7 into 3 equal to 21. I believe they are prime numbers. Only 21 can be equally split by 7 and 3. There may be 0 to 21 combinations, right? Same way, instead of taking this small number, if we take a big number, this big number can be split only using two small numbers, right? Number 1 and number 2. Finding this number 1, number 2 is a real challenge, right? So that's what is used in cryptography, most of the crypto algorithms, right? Symmetric, sender and the receiver will use the same key. Asymmetric, again, there will be a confusion when you study between symmetric and asymmetric. Asymmetric means sender and the receiver will use a different key. That is fine. But why really is it asymmetric? For example, 100 people are here sitting in this class. I am going to keep an exam for you. I want you to write the answers and lock it and send it to me. I will unlock and see. So I'll say like everyone will generate a key. All 100 people or 200 people available here, we will generate a key for ourselves. Each and every one of you have to generate 2 keys. One public key, one private key. Let us say all of us are going to generate that. Let's say Ashok is going to generate a public key and a private key. As the name goes, public means I keep it open. I gave a public key as 1000. Some numbers I'm giving for understanding. Private key as, okay. So everyone will generate public and private key. All of you will have. You will put the public key in a common place. Let's say public key of Ashok is 1000. Public key of Lakshmi is 2, 3, 4, 5. Fine. Again, 1000, 2000. Same way the public key of everyone is available. Fine. So in a box, there are 100 public keys available, right? And I have my own public key. She will have her own public key. Sorry, she will have her own private key. This is the thing. So asymmetric means there will be each person or each individual will have a public key and private key. As the name goes, private key they won't give outside. The public key, they give it outside, right? Say they just send the key to outside, fine. So public key will be available in a common place. For example, I want to send a message to Lakshmi. I will take the public key of Lakshmi, fine. That is 2, 3, 4, 5, and send the message. What will be the message? Plus, hey, meet me at 6. Fine. It will goes on the internet to the receiver, right? The receiver is receiving the message. There will be a private key of Lakshmi. Lakshmi only knows it. Again, I'm using this name regularly. It's my wife's name. So I believe that I can use it, right? I'm not targeting any other names. So she have the same combination. Let us type it here. Fine. She has her public key as 2, 3, 4, 5. She has her private key as 0987. So I'm locking with her public key. Fine. Okay. I'm locking with her public key. I know that that's available. I put a message. She has her only private key 0987. With that, she'll be able to unlock the message. But on the internet, when this meet me at 6 message goes, it's an encrypted channel. So how the data will be there in the internet? It will be Greek and Latin, something like this. The same message is locked, converted into another format. Receiver have the corresponding public or private key, can unlock and get the same message. If they are able to give the correct key, they'll be able to get the same message. This is the mechanism, map or logic behind public and private keys, right? So I'll do one thing. Just a minute. Let me open. There is something called Ringedale algorithm. Those who are new to cryptography, I'll just Ringedale algorithm animation. That's an age old, maybe years, 10, 15 years ago. But this animation will just clearly explain how this lock and unlock happens. This level of whatever I'm going to explain now, this level of basic understanding is more than enough for a student who's attending an interview for anything related to cryptography, right? Let me start this. Let me play this. Meanwhile, it's playing. I'll explain. Play. 15 steps. AES Advanced Encryption Standard 128-bit algorithm. Let us see how the algorithm works. There's a cipher key. There's a cipher text. The above is the plain text. Meet me at 6 is the actual message coming from above. Let us see what is AES. It will have a state and a cipher. Fine. At this stage, state and a cipher. State is your message. MEET, right? The message will be converted as state. Cipher key is the key, right? For something to work, you have an input, you have a key plus algorithm, and output will be there. Input is the plain text, output is the encrypted text, right? So there are two types of process, encryption process and key generation process. We'll see the encryption process, right? It's typically like permutations and combination, changing the order, changing the sequence. That's how it works. But it's going to be complex. How many rounds? 10 rounds. Each round will have 4 types. Substitution bytes, shift row, mixed column, add round. See, round number 3, 4, 5. But the 10th round will be unique. It won't have a mixed column to add some randomness. 10th round will have 3 shifts. So this is happening in each and every round. After this happens in each and every round for your input, the output will come, right? Just like chewing it in one level and putting on to the next level. And okay, you see here, this one, right side, a small table like a chessboard, interesting, 0 to F, hexadecimal. This is something called as an S box. You remember like when the intro was given, they said like I was working for some research for some defense agencies and all. Defense agencies, government agencies used to develop their own crypto algorithms. For that, where I was there at the university, we used to develop something like this. This is called S box, right? So creating a box, something like this, a random numbers, testing it completely random. You can sell it for 10 lakhs, 20 lakhs, 60 lakhs, or given greater. Fine. See, the first value is 6 and 7. 6 is corresponding to some value. Next is 4 and 5. 4 is corresponding, 5 is corresponding to 60. 4, 5 is replaced with 60. Same way you see here, everything is replaced. First level of substitution is done, right? So this is the seed. We call it as a seed value. This key has to be kept secure. This S box has to be kept secure. And the background behind this will be the random numbers and the prime number sequence, how it works. Okay, the first state we have got. Second level, what is the name of the level? Shift row, we are rotating it by 1 byte. First is rotated once, second is rotated twice, third will be rotated thrice. 1, 2, and 3. The previous input, it was random. We even randomize this. The third row is mixed column. You have the previous input, you take something from the state, you do a matrix multiplication. You get the output. Do it for every row and column. Fine. This is done only for the rows. Do it for the all 4 rows. You go on to the next level. Finally, the key we generated, right? The first key, the key will be added on to this. This is the output of 1 round. For the first bit of data, WE or meet, MEET, that is done on this round. Round 1, round 2, round 3, it goes to the 10 rounds. AES uses, this bit uses 10 rounds, right? You remember 10th round won't have the mixed column. The output is there, right? This is the process of AES encryption, right? How AES works, 10 rounds of AES. For each and every round, you need to give a key. So what I do, I have a single key, fine, I'm having a single key. You can see here. You remember I took my key as 007. I have my single key. From that key, I'm going to generate 10 round of keys. We call it as a parent key and children key, right? From a single parent key, which I have in my hand, you see, take it, rot word, there's a orcon, there's a table to be multiplied. When that is done, the first two child keys, first row will be calculated. You got it? Then the first row will be multiplied with the second row of the previous. The second row will be multiplied with the third row of the previous. The third new row will be multiplied with the fourth row of the previous. So from the first key, we have derived a second key. From the second key, you derive third key, fourth key, but first key will be the master key, right? So from this, we want 10 keys, you can derive 10 keys. If you want 64 keys, you can derive 64 keys, no problem. But the first key will be the same thing. So the X box and the first key are to be kept secure, right? And you see here, the key is derived for the third, for the fourth, and it goes on consecutively, fine? Okay, this is how it works. Round 1, round 2, round 3, I hope we had 10 rounds. So 10 round of keys will be generated. Each round, that round key will be taken from the key scheduling algorithm and it will be given on to the key, fine? So this is an interesting website, crypto tools, right? If you want, I can, but this is not available in the class notes. I'll put it in the chat box, fine? I'm putting in the chat box for everyone so that you will come to know. Can you use it? Okay. Let's get back to the slides. So we are seeing about security means locking. Locking means authentication. Authentication means password. Password means any type of factors which we use. So the common authentication passwords, we have seen Google Authenticator, open authentication algorithms. And cryptography is the art of hiding data, art of locking and unlocking data. Steganography is hiding and unhiding. You hide and unhide. Cryptography is lock and unlock. Fine. So symmetric algorithm, AES, DES, asymmetric algorithm, RSA, reverse Shamir Adelman, 3 professors, right? Their results. ECC, elliptic curve cryptography. Fine. So this is one type of crypto to lock and unlock, right? There is another crypto here. I'll just quickly walk you through. We're not going to go in depth. There is something called hashing. I said we are doing cybercrime investigation, right? If I'm going to the court and saying that, hey, this is the photo that was in the pen drive, the judge will ask me, hey, the photo name is girl.jpg, right? Girl.jpg. This photo was available in Oppo Reno 7 mobile, right? Okay, fine, well and good. The judge will ask me for a hash value. Hey, give me the hash of the photo. Hash is yet another cryptography algorithm. hash MD5 is one hash algorithm. SHA is one hash algorithm. SHA-1, 2, right? There are many other hash algorithms available. SHA-1, sorry. SHA-1, SHA-2, SHA-2. What this algorithm does, we'll see a real world example here. MD5 online. It will just take your data, digest and give the output. But the data is going to be this. Okay, you see, I'm generating the hash of the keyword, ignoring the adds apart. Fine. I'm generating the hash for Ashok, ASHOK. Generate MD5. See, this MD5 is unique for the keyword Ashok. Fine. For example, ASHOK, the MD5 hash equal to this. Wherever on the globe anyone is generating ASHOK small will have the same MD5 algorithm hash, right? You want to see this? Let us decode this. 1, 2, 3, 4, 8. In math, in computers, everything is 2 power 0. 8, 16, 24, 32. It's a 32-bit algorithm, right? If you what do you mean as 32-bit? 32 into some value, some x value, you get 128. Sorry, it's a 128-bit algorithm, right? 32 characters, right? 32 characters multiplied to something, you will get a 128-bit, right? So there are 32 characters. For example, the first bit B will be belong to 001, 00010. For identification, I'm saying 8-bit is equal to 1 byte. We remember we discussed on that. Fine. So 128-bit is called MD5 hash algorithm. Fine. Because yeah. So instead of small a, I give capital A. I generate the hash. Fine. I generate the hash. Let me copy the hash and we'll check out on the notepad. Fine. Fine. I hope this was the hash, right? Yeah. So if I'm checking the hash of this capital A, small shok, you see completely changed. This is the hash of the first word. Same, I change one bit, completely changed. What is the conclusion? Hash or hashing is a crypto algorithm used to verify, if you talk it in terms of principle CIA, confidentiality, integrity, availability, it is for integrity. It is going to say whether the message is same or not. I'm sending meet me at 6. You are receiving meet me at 9. So 6 is changed to 9 by the attacker in between. So if you take the hash of this, it won't match. So obviously you can verify not only for a text file, you can change the hash of CYS DFIR 1201 question paper dot document. You are sending a question paper to your exam office. You can take a hash of this and send it to them. But provided the hash, you send it to the team in a different routine. A clever attacker will modify the bail and modify the hash also, or put the new hash also. Fine. I remember colleges, many colleges where we audit, we recommend them to send the question paper to the exam office. They need to take the hash and send it to the exam office in some other routine, not an email, WhatsApp or something. Before printing the question paper, the exam office will verify the hash of the question paper. It can be a document, it can be a PDF, anything. If the hash is not matching, obviously they believe something is changed, added and modified, or something has been done. Right? So that is on this hash algorithms, one type of crypto algorithm. When you talk about cryptography, symmetric algorithms, asymmetric algorithms, hash algorithms, broad categories of cryptographic algorithms. Remember, we saw that in crypto tools, sender receiver will have the same key, that is called symmetric. Receiver sender will have a different key, public and private key, that is called asymmetric algorithm. Fine. Okay. So we'll come on to the last topic, steganography. Fine. Okay. Steganography is the art of, let me open it. Crypto is the heart of lock and unlock. You play with numbers for locking and unlocking. Fine. Stego, or else we call it as stegano. Fine. This is the art of hiding and unhiding, right? Simple. You see, like older days, you remember you can hide something inside a photo and send it, right? For example, I'll show you some demo. Live Stego demo online. Stego online. Decode image. Crypto Stego demo. Open Stego. Open Stego is most commonly used. Okay, I'll take an example. I'm uploading an image. Fine. So let me say I'm uploading a pictures. Let me go to the picture. Let me upload a photo. I am with you. Open. I'm uploading this photo. Fine. I'm going to do some stego with this, right? So browse bit planes, you know, right? Those who do cryptography, or steganography or image processing. A bit will be split into bits plane, 8 planes, 0 to 7, right? So this is the actual image. Fine. Reset. You can select the bit planes. Full red, full green, LSB half. You can select which algorithm you want to use. Let me upload it again. Embed file or data. So I uploaded an image. I'm going to embed a data. It's asking which bit I want to embed. See, now you can embed it with secret or without secrets. Let's say I want to embed it on RGB plane, R7, B4, R7, G4, B1. Fine. 741. Fine. So I'm going to hide it. What is the type I want to send? My ATM pin is 7854. I'm giving a random number. That's not my actual pin. Go. Loading 100%. It's going to do a steganography. It's going to hide something inside the photo which I was given. The output is ready. You see, visually you don't see any difference, right? I can download the device. You see here the same photo. I'm downloading it in the download photo, downloads folder, save. Fine. This stego image, right? Right click. Fine. So this is, I've just got an image. I've selected which bit, or else you can select the algorithm, LSB algorithm. You put a secret message. Let me copy the secret message. We'll verify it. Fine. I have a secret message and I've got it. Now I go back to the upload image. I am the sender. Now you are the receiver. Assume you are the receiver. You are uploading the image. Not on the pictures folder. Now I'm going to go to the downloads folder where I downloaded that image now. Fine. The same image. I'm opening it. The image is uploaded. I want to extract the data. You remember I have clearly given which bit I embedded. R7, G4, B1. Fine. Go. If this is the actual stego image with the secret. If you know the bits, instead of bits, you can also have a secret key. If you know the bits are keys, you go. If the sender and the receiver side, the stego normal image works correctly. The header of the photo image, you see here, are you able to find? I'm copying the bit. Fine. My ATM pin is 7854. You're able to see this? Fine. So this is typically an art in security called as steganography. You're going, I have hidden a text, a secret message inside a photo. Traditional time, you go 10-15 years ago, steganography means you take a photo, inside the photo you hide a text. On the receiver side, you unhide the text from the same photo, typically the stego photo. But nowadays, steganography is you can hide anything inside anything. You can hide a photo inside audio, you can hide audio inside video, you can hide a text inside photo, you can hide a video inside text, anything can be done. the advancement of stego algorithms. I know many of the college faculties do PhD research on this steganography, right? So that is on steganography, yet another security technique, right? Where you are hiding and unhiding. Mostly it will use LSB, least significant bit. LSB is the most common stego algorithm. Fine. Okay. Or we have seen about this authenticator, right? I'll explain you about this. We missed on to that. Google Authenticator working. Yes. Geauth. There is another app called Geauth. So we'll open Google Auth. You see, this is what really happens when you request via a Google Authenticator token. Fine. Just that's a web application. You request a token via Authenticator app. It displays the access. The user logs in, permissions, redirects to the website. Website will verify. It will give the access. It's yet another authentication. Instead of giving only password, when you type log into your Gmail from a different device, as I said, it will ask for, hey, go to your mobile and click on this number. Or else go, if you have installed an authenticator app, it will ask, hey, give me the number from that or pin OTP from that authenticator app. Fine. And different other types of authentications. We discussed about hardware token based authentication. You see here, it's like a small device, like pen drive like device, right? The device is a hardware which can generate random numbers. Instead of your mobile generating, the device will generate secret codes or one-time codes, right? Yeah. That's on this. I remember this authentication, fine. When I was doing my bachelor's degree, we used a chip board way back in 2009. With that chip, with a SIM, we generated a random OTP. That was my BTech project in 2009. I remember in MTech, we created a time-based OTP, extended version of that, time-based and device-based. A OTP will be generated. First part of the OTP will come to your email. Second part of the OTP will come to your mobile. If I'm not wrong, nowadays many banks are using this, right? The first part will come to your mobile. Second part will come to your email. You need to get both and combine and enter it here, right? So once when you enter that, then only it will just allow you to log in. Nowadays, banks, secure mechanisms, they are using this as the authentication mechanism, right? Not only this hardware tokens, we can have a smart card. You know, right, nowadays, all the ATM cards which we have will have a small chip, right? Then you can have using your mobile or any third-party hardware tokens. Right? So this is one form of authentication. You see, I remember some banks give OTP generators like this. Small remote-like device. Or small pen drive-like device. Fine. These are all different types of authentication mechanisms. So to summarize what you have seen in the whole of the concepts, let me go back. I'll once again let you know the definitions, what we have seen. Definition by definition. Fine. Vulnerability is the weakness in the system. The weakness can be on a hardware, software, or an application. Exploit is a malware or a virus, a piece of code, right, that is used to attack the vulnerability. Right? Then we saw something on vulnerability is a weakness, threat agent is the attacker, they use the exploit. Because of this, the risk is there, right? Risk is the attack. The attack happens, you might lose something. Company has to either accept the risk, avoid the risk, transfer the risk, or mitigate the risk. Different types of malware, malicious software, virus, worms, ransomware, 0-day, we saw APT, we saw Pakistani APT 36, We saw what is social engineering, right? We saw Trojan horse. We saw an example of a ransomware. Ransomware uses encryption. Using encryption, it locks. You need to pay and get the single key. That is called ransom. Ransom money, you need to pay and get it back. Attack vector. Vector is something have a magnitude, direction. How the attack is happening. Social engineering, malware, network-based, physical, password-based, different types of attacks. The attacker will not do a random attack. That's a vector, right? So the attacker will find what is the weakness, vulnerability in your system. The attacker will get the actual exploit, and then they will do an attack. You might have seen in movies, right? To blast this building, you need this much kg of bomb. What they are doing, they have an attack vector. They are deciding the circumference, strength, and everything. They are deciding how many kg bombs they need, and then they do an attack, right? So same way, we are talking about exploits, right? Sir, where to get an exploit? I want to do a demo on exploit, right? But don't do it on any live websites or live institutions. They might be having a firewall to monitor. Exploit DB. We'll be seeing this in upcoming classes, but for matter of interest, I'm showing this now. Exploit DB. I'm going and type Windows 10. Windows 10. You see, yesterday they stopped the support. So Windows 10. You see how many exploits are available. Different exploits. When I check one exploit, remote code execution, this website will give me a virus. We click on to download. It will download some code. It can be a Perl or Python.NA file. When I download this file, this is an exploit available in Windows 10 computer on this web dev interface or application or protocol. And the attack name is remote code execution. You get it, send it to the victim. This is a piece of code, right? If it works, you'll be able to do an attack, right? The attacker is getting basic details about the victim, finding the vulnerabilities, finding correct exploit for the vulnerabilities, have a vector for that, then send an attack. When they send the virus, they send it over email, WhatsApp, SMS, pen drives, anything, right? Different mechanisms to send, but actually this is how it works. Fine, attack vectors, phishing, fish tank. So you have an asset, your company, college has 1,000 computer, you have a vulnerability, you are using older Windows XP, you have a threat. Your student will find a remote code and they get log into your faculty system. A hacker outside will log into your college system and steal the question paper and go. That's a risk, right? Then we have seen the global threat map. Different types of maps. Yesterday we saw the same we saw today. Cyber hygiene, how to prevent that? The first part we see what is attack. How to prevent attack is put a lock. Lock means security. Security means password. Password means cryptography, right? Most common. So we have seen password, how to set a password, different types of authentication, different types of passwords. Then Google Authenticator, OpenAuth. I have not discussed on OAuth. It will take more time. But OAuth is an algorithm that is the most common algorithm behind. You know, right? A plus B whole square formula. Same way, OAuth is the open authentication algorithm behind most of the authentications. Cryptography, the art of locking and unlocking. Symmetric, sender and receiver will use the same key. Asymmetric, sender and the receiver will use a different key. Hashing, typically for checking integrity. Hashes are used to verify whether the message is modified or not. And keep in mind, even when I learned for the first time, I got confused, right? Hashes won't get me this Ashok and this Ashok. Hash will only give this, whether the message is modified or not. Hash will say whether the question paper is modified or not. From the hash, you cannot extract the question paper. It is not a RAR or a compression algorithm. I had a misconception when I was learning, right? Don't believe hashes won't get you the data back. Hashes is only a signature, just to verify whether it is modified or not. Fine. We have seen some hashing algorithms. We have seen the website for AES Ridgedale algorithm. 10 rounds for each key generation. S-box. We have seen how it is generated. Steganography is the art of hiding and unhiding. Hiding a text inside photo, traditional steganography. Hiding anything inside anything is current day steganography. You can use this Git code, most common stego code, if you want to do for some research. Source code should be available. You can download and try it. Fine. So the concepts which you are going to see, we have already got introduced to this WAF top 10. We will see some bits and pieces of WAF top 10. And important among this is cross-site scripting, SQL injection or SQL injection, cross-site request forgery, broken authentication. We'll see some common attacks, right? Digital signatures, digital certificates, DNS, VPN, proxy, cyber kill chain. We call it as an attack. Let's give some steps, 7-step attack. Step 1 to step 7. The attack is going to happen in 7 steps. The attacker has to successfully complete all the 7 steps. If you are a security professional, successfully you need to defend in any one of the steps or all the steps, right? So then when you just make a report, in industry we call it as a pen testing report or a security audit report or a VAPT report. The report will say, hey, welcome, see, we give audit reports for colleges and university. Sir, your college has this many number of computers, this many IPs, this many systems, this many email IDs, everything. There are like 1,000 vulnerabilities available. Out of that, maybe like 20-25 vulnerabilities are critical. Today you need to patch that or else someone might steal the data. Then there are some high vulnerabilities, maybe like 100 high vulnerabilities, some 500 medium vulnerabilities, 200 low vulnerabilities, another 100 information level vulnerabilities. Likewise, we'll categorize. We need to give a score, right? So maybe like technical people, your IT support team might understand what the vulnerability we are talking about. But the management people, you talk about a principal or a chairman, they want to know what is the problem, how to fix it. So we need to give them the number. Sir, this is like the vulnerability, the weakness is 99 out of 100. Or else this is only 10 out of 100, right? Something like that we need to give. So we have something called as CVE, CVSS. It's a scoring system. We'll see what is CVE and CVSS. This is a scoring system between 0.0 to 10.0. The score is not 0 to 100 scale. It's between 0 to 10. The 0 to 100% is split between 0 to 10. And at the end of the day today, we'll see some top cybersecurity tools or information security tools. Anyone who comes out and claims that, hey, give me a job in cybersecurity, the industry will expect these things, at least knowing what is the tool, how it works, right? So that is going to be the agenda for today. We'll quickly walk on through the topics. Okay. OWASP, OWASP, as we have already seen, OWASP top 10. OWASP is a security group, organization who is listing the vulnerabilities. You can contribute, I can contribute, anyone can contribute for that, right? So they will regularly find the vulnerabilities, the attacks happening globally, the vulnerabilities that are available, day in and day out, the new vulnerability release, they'll rank it. They have a formula for that, they have a ranking mechanism, they have an experts team who's auditing that. So they will rank and say, hey, what is the vulnerability? Vulnerability out of 0 to 10, fine. Just a minute, let me open. For your understanding, I open a website called application.security. This was free earlier. Now they have made it as a paid version, right? But this is a good website, right? If at all you get a chance, like from your college or university to teach cybersecurity, and you want to students maybe in the 7th semester or 8th semester or final semester, just by knowing this paper, they want to get a job or they want to clear the interview. This website might be a good one. You see here, clickjacking, command injection, different vulnerabilities are listed here. For example, let me take one. It might not allow more than 2 to 3 steps, but even though we'll just open that. Directory traversal attack. See, looks like a website, Deal Hub. There's a website available. It's an online marketing place. Fine. Go next. Fine. So someone have just gone. They are just going to add something to the cart and they are going to purchase something, right? Fine. So someone wants to going to buy, is clicking. Fine. Okay. So it will ask for the paid version. So this website, right? If you get the paid version of this, right? So it will clearly walk you through this. I'm going to explain the top 10, right? Top 10 vulnerabilities. I may take you through 4 or 5 vulnerabilities, right? The most common, right? So this will take a step by step. Step by step, left side, it will say what it is. Right side, you can just see the demo. Previously, as I said, it was free. Now they have made it as a paid version. You see here, OWASP top 10 web vulnerabilities, OWASP top 10 vulnerabilities for API, fine. So different types, but you see whatever you see here on this screen are different vulnerabilities. Clickjacking, command injection, cross-site request forgery, directory traversal. I clicked and opened this directory traversal, right? Directory traversal is nothing but, see, you have access to your folder in the exam office drive, right? So you can copy your question papers. You can view your other department people question paper. You go out of your folder. You go out of your department folder. You go to the other department. You go to their folder and you open or copy or edit their file. That is called directory traversal. Imagine from your room you come out of your building. You go to the other building or you go to the other college. You go to their building and see what is there in their system or their room, right? Same way, directory traversal, you move out of your directory and you go to the others directory which you don't have a permission. AAA principle comes in, authorization, authentication, accounting comes in. You are not allowed to do so if you are an abusive or offensive user, the so-called hacker. If you find something that is open, you go and check. See, most of the times when we audit colleges, right? So their website will have this vulnerability in common, directory traversal. There will be a common directory put for parents to download some circulars, right? They can open and see the circulars, right? But there may be an option for them to go back and check or view or copy or paste anything from the faculty folder that is available in the same cloud. Maybe the website might be hosted on a cloud. They might have a file server there, FTP server there. So they will be able to visit that. So 2021, the top 10 categories, vulnerabilities are these 10. And as we have already seen in the earlier classes, this is the comparison 2017 and 2021. These are the top 10 vulnerabilities, right? For example, you'll say like maybe the day before the exam, we'll say, hey, study these 10 questions. For sure, majority of that thing will come. You'll be able to crack or clear the exam, right? Same way, if someone wants to do a security audit, without these vulnerabilities, they cannot make a security report because majority, 99.99% of the devices, it can be a hardware, it can be a software, it can be a network, it can be an application, right? They might have these vulnerabilities. That's how the vulnerabilities are ranked. Fine. Okay. So security team uses SWAP's top 10 base checklist. Fine. Okay. We'll check on to the top 2 or the common 2. Cross-site scripting, right? Cross-site scripting, that is called XSS, right? It's an attack where the attacker injects a malicious script into a legitimate website. Let's take an example of your college website. In your college website, you're having an option. Let's assume this is an admission time. You're having an option for a parent or a student to give an inquiry. They can give their name, they can give their mobile number, they can give what department they want, they can give a comment at the bottom and submit it, right? There's a column, an input column where someone can input, right? So you see that we will just revise the line again, right? An attacker injects a malicious script, a code, it can be a malware, a piece of code, into a legitimate website. Your college website is a legitimate website run by your college, authorized, right? But attacker visiting your website finds your college website, what is the application it's developed, what is the backend it's using, what's the DB it's using, and they have found that in the top 10, this website is vulnerable to something called an attack called cross-site scripting. Fine. So if let's say the website is vulnerable, the attacker is putting the virus, what will happen after that? The user's browser executes the script because it believes it came from the trusted source. So the user will go, the attacker will go. Next time another user is coming, they are going to give an input in the website, their name, mobile number, comments, which department they want and submit. But the person, whomever they are going to coming after that attack happen, the website will give them some script, a malicious script that may do something. For example, you are visiting from your laptop. It may steal your browser passwords. You might have stored some passwords in your browser, right? Or else it might inject something into your local system. From local system, it will take something about some malicious purpose. Some attack might happen, right? So that is the purpose of XSS, right? Cross-site scripting. Okay. Yeah. You see this diagram for cross-site scripting. Fine. So there is a client 1 and client 2. Fine. 2 clients are there, right? They are going to send a request. That's a server. Server, you assume that your college website is hosted on the server, and the server is having a backend. Like most common, a SQL database or MongoDB or any traditional or DB-less databases, right? So that may be in the backend, right? So what I'm going to do, I'm just want to insert a name under comment, right? So for example, let me open a demo website. Fine. Let's check this. Now there are some websites that are hosted online that are vulnerable. Intentionally, the websites have been kept vulnerable just to check whether they are vulnerable. They can just check whether this cross-site scripting works or not. Okay, let's check. Advanced proceeding security. Okay. Okay, let me open it in the command prompt. OWASP has a application online called OWASP Juice Jack, right? With which you can just try this online. You see here the website looks like this. We need to download this and keep it fine. Just a minute. For your understanding, I'm taking a college website. I'm randomly typing. And again, you're not allowed to do any of these attacks or something in any of the external websites without their permission, right? So that's really an offense, right? So for your understanding, I'm not going to open any website, live websites. Let's assume like, okay, this, you are going to search something, fine. We're going to search something, see something has been searched earlier, right? So instead of searching or instead of typing something, if I give script, right? I'm opening a script, fine. And having a command saying that we have been hacked. And the script is closed, slash script. A traditional syntax for cross-site scripting, right? Just a minute. Because in Google page itself, they have just marked this as malicious. So it might not open. Yeah, it's here. This should do good. Fine. Fine. So there is a website you see here, insecurewebsite.com, right? In the comment column, what you can comment, you say like, someone have raised their hand. If you have any questions, queries, you can put in the chat box. Let me check. Not any questions in the chat box. Okay. Fine. So you see here. So that's a website. Let's assume it's insecurewebsite.com or your collegewebsite.com. In that, you need to give a comment. After giving your name, mobile number, you say, hey, I want this department, something like that, right? So if it's a real one, it will just go to the website team or the college team. They'll call back to you for some comments. The attacker's intention is not getting a college seat or something. He wants to find some vulnerability in this website and inject something, inject a code into that. See what the attacker is doing. You see here, http insecurewebsite.com comment. In the comment message, what he's doing, a similar one, whichever I've just shown. image message is equal to OpenScript source HTML eviluser.net / badscript.js JavaScript and script is closed. Assume that that's a college website. It have to just give saying that, hey, welcome, your comments are taken, our team will call you. That is a normal. The attacker will inject a script saying that it will redirect you to another page. Maybe they might have created a fake page, phishing page, right? Good, looking like exactly like the college page. That page will say, hey, welcome, the basic details which you have given. Welcome, Mr. So-and-so, right? We are happy to just give you a seat for this. Just pay this 10,000 advance so that your seat is booked, right? So if something like that is given, yeah. So it will be redirected to the evil user page. For example, instead of your actual page saying that your college.com, it will show you some XYZ. For example, let me open. So instead of taking you to a college page, right? Madurai college.edu.in. I'm giving some example, right? So let's assume this is your college, right? So the attacker might have a website, right? org.in. Fine. Looks like the same thing. Maybe O is replaced by a 0. It may redirect to the same page because you and me, those who learning this, might know like, hey, the URL is something different, right? But for a layman parent who wants to get a seat in the college, it is their intention to just get the seat confirmed, right? So this URL, it will be redirected to the URL. URL will just give some account details. It will just start getting the money. Let's assume this is happening. Your college website is vulnerable. Now it is a peak admission days. Maybe in another 1 week, the admission is going to get closed. It's vulnerable. No one is looking at. After a week, some parents might come saying that, hey, I have given you the token advance of 10,000 rupees. I'm waiting for the seat confirmation. Maybe not one, maybe 100 and thousands of people might have given it online, right? So that is the thing. So this thing is one of the most common attack called as XSS, cross-site scripting. It's a web security vulnerability in the code, right? That will allow an attacker, so-called hacker, to compromise the interaction between the user, the end user who's visiting the website, right? And the website which is vulnerable, fine? Then the attacker will circumvent the same origin policy, right? Which is designed to segregate different websites for each others, right? So this allows an attacker to masquerade a victim user, fine? So whatever actions he wants, he can do. He can copy something from the victim system. He can redirect the victim to some other website. At the end of the day, intention of attacker will be to do some attack. You see here, it can be a password, it can be a sensitive information, it can be getting your secret info, or else it can be a wire transfer, asking or making you to pay some money. See, there is, again, cross-site scripting are of multiple types. Stored cross-site scripting, reflector cross-site scripting. Fine. When you check it, I hope this is logged in. I have my company account on this SportsWigger website. Let's check on to the lab. I'm opening that lab. I hope some labs in this website, SportsWigger, are free. I've already logged into my account, right? Cool. Yeah, it's asking for the subscription. Yes. Yeah. Fine, leave that. See, if we have the access to the lab, what we will do, you'll just log in. There will be a column for entering the command. In that, you will give script. The message is alert1 and the script is closed. If this is fine, right? What will happen? When you visit, you inject the command, you come out, you are the attacker. Fine. When someone else visits, the next legitimate user, they try to type something and submit. The script which is the previous attacker have just put on the website will be reflected to the next legitimate user or a victim user, right? The most common XSS is you have been hacked. So most of the people, those who learn XSS, right, they keep something like this. You see here, when you visit a website, you will get some pop-up like this. Visit a website, submit something, When you put the submit button, you need to get the content or you need to get the output. Fine. Yeah, you see here, a pop-up will come, a website pop-up will come saying that you have been hacked. This is an XSS attack. That's a proof of concept. Instead of that, the attacker will say, hey, welcome, your seat is confirmed. Click on OK to pay the money, right? Something like that, it will work, right? But in layman terms, keep in mind, this is one of the most common attack, right? Cross-site scripting, fine. Attacker is injecting a malicious code. The attacker is injecting a malicious script into the legitimate website. The website is a vulnerable website. If the website is sanitized, when the attacker injects a script, it might not work. It will say page not found, or it will just refresh the page, right? And the second common attack, the most common attack, SQL injection or SQL injection, right? In which, see, whenever we talk about a network, there's a client and the server. Client are your 1,000 students. Server is your college website. Server will have a backend, maybe a backend database. If it is a SQL or SQL based database, what the user can do? See, I am a guest user. I am getting admission in the college. You have given me a sample username and password. From my guest user, I am trying to check what are all the other guest users who are available in that website. Whereas from my guest user, I am able to find what are the details of the principal, what are the details of the HOD, what are the details of the admission team. Let us assume you have a registry, big registry, where whomever is coming, they signs and puts and goes off. Anyone comes, they open the previous pages and check something. If they're not allowed to do so, right? If they check something like that, imagine you have your whole college database. I don't know where exactly is your exam office, where exam server, and where exactly is the details, or I don't know where exactly is the accounts department, where exactly is the salary. But I want to know what is the salary that is put for your principal. What is the salary that is put for the HOD, right? Something like that. If that website is vulnerable to SQL injection, attacker, he can be a guest user, he can be an insider. Insider means one faculty might try to know the other faculty's thing, right? Or else it can be a vulnerability. The attacker have really hacked onto the website and they have got control over that, right? So you're going to give an enter. There's an input column. Same way, hey, welcome, give your username and password. There's an input column, right? The attacker here, the attacker executes some malicious script on the comment column, right? Just to reflect it for the next user, fine. In SQL injection, the attacker is not attacking another user. The attacker is attacking the company's or college website database, backend database, right? So attacker will give an input, another mode of injection, SQL injection code. If the application does not properly validate or sanitize, for example, there's an input column called name. What you can give in the name, A to Z, sometimes a space, capital, small, fine. Why I am allowed to give open braces in the name column? Why I am allowed to give a slash in the name column, right? If something like that is there, right? So that website may be vulnerable to SQL injection attack. Let's check. Okay. See, this is an example of this, right? An attacker, you know, right? Those who have taught or teaching databases, right? Any different types of databases. For sure, you'll teach SQL, right? So SQL is all about rows and columns. Imagine like a bigger Excel sheet, right? So there are rows, there are columns. In the rows, we call it as a field value pair. There's a field called student. The name is the value. There's a field called subject. There will be a mark, right? Field value pairs will be there. The attacker is sending some command. You see here. If you want, I'll type it in the notepad. The same one. Okay, let's take it like this. Yeah. Let me. So it's not starting with union. There is something like an apostrophe union select username. The attacker might have already known there's a tuple. Tuple means the field called username, password from. In DB, in the database, there is a table called users and hyphen. Thereafter, comment it everything. So I am a user. Let's say like Ashok at 123 is my Ashok at 2015. User number 1234 is my temporary ID, right? So with this ID, I give my password and I need to check what is my status in the college admission. Right? So, but instead of giving username this one, if I'm able to type this, it's a valid, it's again yet another legitimate statement, right? To the computer language, it's a legitimate SQL statement. The input column username is not sanitized, it's not verified. This will go to the server, it will go to the database and it will execute. When it executes, what it's going to display? You see here, another syntax, select name description from the product where category gifts union select usernames passwords from users. Simple. Let's say go to a website called xyz.com. The website is vulnerable. Let's say it's like online Amazon or Flipkart or something. Fine. So you have a username and password. You're logged in. In an input column, you are giving this. So it will list all the users. What all the username? What all the passwords? Whom are having under the category called gift. Right? It's a union select. You know, right? Those who work on to this databases, you come to know about this, right? Select star dot star hyphen, right? And there is something called as a common SQL injection syntax. Even if we don't teach students advanced SQL injection or advanced stuff, right? At least we need to teach them this something called as I'm typing 1 is equal to 1. Let's check on to the AA mode, what output it gives to us. Syntax SQL injection. Okay, I'm copying this R1 is equal to 1. Let me paste it here. Okay. So if I'm an interviewer, I'll just give it to the student. Hey, just let me know what is this. It's an attack. It's a cyber attack, right? Just let me know what is this. The student should be able to say, sir, it's something like an SQL injection attack. Fine. Well and good. What is SQL injection attack? The definition which we have seen till now. Fine. So explain me. This is typically a syntax. It's a syntax of an attack, right? Syntax of a traditional SQL injection attack, right? So just explain me. Fine. So there will be username password column, right? So let us check on to this. That's the first column. You see this apostrophe. So that is going to end the first one, right? Whatever you are giving at the first, end that. Fine. You know the difference between R. R means either it should be left-hand side or right-hand side. If it is and, left-hand side also should be true, right-hand side also should be true. So I'm least bothered about the left-hand side. I'm closing the syntax of the previous command and giving a R statement. Hey, ignore the left-hand side. Whatever username is given, leave that. I want you to execute this statement, R. And you see this Boolean, 1 is equal to 1. It's always true. Instead of 1 is equal to 1, I can give 7 is equal to 7. Instead of that, I can give Ashok is equal to Ashok. Anything, right? So the traditional thing we give it as, for example, we give it as 1 is equal to 1. Fine. It's at all times it's a true statement. Then after leave a space, hyphen. You know, in DBs, hyphen is like whatever comes after hyphen, right? You need to comment it. You put it as a hash, or you need to, you know, right? We comment it on the databases, right? So if this application or server is vulnerable to SQL injection attack, someone is trying this in their column. If this is run, right, it will pop up, right? Let me check like output of this. Yeah. Let us check on to some images. SQL injection attacks. Yeah, in the you just Portspeaker account, which I have opened it, right? They have quite a good number of demos. You can check. There is another application called DVWA, Damn Vulnerable Web Application, right? So there also you'll be able to find this. Yeah, it's here in the Portspeaker's website itself. They have given it here. Okay. They have the demo video. You see here, if anyone teaching database, update, insert, order by, where, the syntaxes which we give in a traditional SQL statement, right? This is a website. The website shows, hey, you logged into the website, your product in which you have a gift, right? Fine. In that, if you are able to inject this, select start from product where category is equal to gift and list is equal to 1. If that website is vulnerable, this will run in the background and it will just give you the output of all the users. The website might have 1,000 users. It's going to list the username, password, whatever you list, right? Whatever tuples, whatever rows and columns you list it, that will be listed there. You see here this syntax, the similar syntax which we have given, fine. The SQL injection syntax. Select start from products where category is equal to gifts. You see this statement, you notice this alone, fine. So this was the thing which you executed. By default, this will be there. By default, this will be there. The attacker is clearly crafting and injecting this statement, the same thing which we have tried here, right? This is a simple example for a cyber attack, database attack, SQL injection. If someone is not able to say what is SQL injection, on seeing this, if someone is not able to explain what is this, right? A company might not be interested in giving them a cyber job. It can be a fresher job or an intermediate or anything, right? Okay, so they're given on the Portswigger examples. Fine. So we have seen something called cross-site scripting, XSS. There is another attack called cross-site request forgery. You see here, the attacker crafts a malicious request. Request means attacker is sending a request, right? To transfer fund or change the email and tricks the logged in user into unknowingly submit it, right? Often via link or image. Let us say you're getting an email from your college. It's not your college IT team, a fake email saying that, hey, I am from your IT team. Something is going wrong. We want everyone to reset the password. The attacker is crafting a malicious request. The request is asking you to transfer money in some case. Now I'm saying that the request is asking to change the email or change the password. If it looks like a legitimate, right, you click on to that, it will take a good looking college website with all the username and password looking like the same. And then you give the username and old password, new password, everything will be stored and sent to the attacker. Fine, you see here, a vulnerable website.com, email, change it to email pond@eviluser.net. You are a faculty, let's say you are the HOD of the department, you have your login to change the password, or this is the admission, maybe the appraisal time, you are going to write an appraisal for a faculty to the principal. Someone have just sent you a link, you clicked on to that link, thereafter your HOD login access have been transferred to someone else. Maybe it may be a student or a faculty or a hacker who knows your website is vulnerable. They may just know your username. You know, right? You remember we discussed yesterday, right? Control F HOD. Remember we discussed yesterday HOD CSE 2019 at abccollege.edu.in, something like that, right? So you know, right nowadays, now I remember even I was there at the university, right? So most of the colleges, university website, they'll have a faculty profile. In that, their usernames and passwords will be publicly there. Sorry, usernames will be publicly there, the mail IDs, right? So some college I remember where they strictly follow cyber rules, what they will do, right? So the same mail ID, they won't type it as such. They don't want any attacker to just copy like a bot. Instead of this @ symbol, they will put something like this. @ fine. ABC College, here they will put dot. Fine. Yeah. So it's one form of sanitizing, just not allowing an attacker to copy. Let's say you go to a website, there are 1,100 faculties. An attacker with a small script can copy all the 100 faculties mail IDs from the website. And this is one example, but nowadays there are some advanced attacks. But for simple caution, @ can be replaced with this, dot can be replaced with this, so that some basic level security you have. Fine. So that is called as CSRF, cross-site request forgery. And there is another attack called broken authentication, right? I'll just show you an example. Admin images. Let me check. Yeah, this image, the first image. I just want to show you the same image. It's a meme, right? Meme For some cars, it's a meme. Just a minute, let me close other pages. Okay, you see here, a door is having a lock. How the lock is put, easy to break, right? So that's how username with admin and password with admin will look like. But nowadays we claim that we have a strong password, admin at 123, even weakest password than admin. Fine. Again, you say like college HOD at date of birth, something like that. Just not by adding an at or a dollar symbol, we become secure. This was the scenario. Adding an at, adding a dollar, you became secure in 2010. Fine. So adding multiple special characters, you become secure in 2020. Now we are somewhere in 2025. We are marching towards 2030, right? So no more adding an at or dollar is going to keep you. It's secure, right? Instead of having your name or your 10-digit mobile number, adding an at and dollar is secure, right? But keep in mind, we won't be able to create normal passwords like this, right? So we need to migrate something from a mechanism called password to passphrase, right? Okay, fine. Let me close this. So we have seen CSRF, cross-site request forgery. Then broken authentication, that's what you're talking on this concept. Weak logging sessions, handler allows attackers to hijack account. You know, right? Someone can hijack a flight, right? Flight hijacking, right? They have done some thing to hijack the flight. So how to hijack an account? I remember way back 15 years ago, right? So we had something called a platform called Arkut. I hope most of you, those who are elderly teachers, you might have had an account in this, the predecessor of Facebook, right? So the early days of this, right? There will be a website in this, right? And there will be a username called something like a ID, something like a random number or ID. This will be the unique ID for your user. For me, something else will be there, right? For example, this is, let me copy. This is your ID, fine, your URL, fine. Let me remove this, it is www, fine. So let us say like, this is my ID. Instead of yours, let me type another random ID. This is my ID, fine. So what the attacker will do, attacker will know the user's ID. They will copy that, the hash or a key or a, we call it as a cookie, cache or cookie. Copy that, come to you attacker system, paste the victim's thing, just put an enter. So they will get the login of the other user, right? Nowadays, none of the websites are vulnerable to these attacks. These are all traditional attacks, right? But still, some websites will have something called this weak login session handling, right? Session, right? You remember in ISO SLIS, we were talking about session. I gave an example of a movie ticket. Movie ticket will have which theater, which movie, which session, how many are allowed, right? The ticket is not valid thereafter, right? I remember I have seen like even see Diwali is fast approaching. Anyone have got a movie ticket for the brand new movie, a celebrity movie coming? What they will do? They will take the movie ticket and keep it in their status. If you have really noticed, right, when they are keeping in the status, there will be some unique ID. A QR code will be there, a unique ID will be there. They will put a smiley over there. Because anyone taking a screenshot of that status can go to the movie and just use the ticket, right? Because nowadays we are using all the e-ticket based things, right? So that is on this broken authentication. We'll see an example of that. You see here, the attacker is just sending a request to a vulnerable website for a username to reset the password, right? So it goes to the server, right? Hello, Carlos, to reset your password, click on the following link. It need to reset to, so this is Carlos, the guy who's at the bottom, legitimate user. He believes that he's resetting the password of his in original his website, but it is redirected to a evil website. Password reset token is here. The attacker just copies the token of the user. So with the token, like a movie ticket, he can do anything. He can reset the password, he can delete the account, he can change the account, anything they can do. Just like stealing a movie ticket, that's called a broken authentication, is called hijacking, right? Session hijacking, fine. And they come in conjugation, right? So session hijacking is a unique attack. Broken authentication is unique attack, right? Oh, fine. Again, it's showed on the port speaker website. Okay, now we'll get on to a concept called. I've explained to you 4 common vulnerabilities: cross-site scripting, SQL injection, cross-site request forgery, broken authentication. Out of the 10, if you are seeing all the 10, it will eat up the whole of the 2 hours. We have some other topics to see. And as I said, you can find them in the worst top 10 website. Fine. So we'll see digital signatures and digital certificates, right? And keep in mind when we teach, right, there's a main difference between these two. Digital signature, okay, digital certificate. Fine. So let's take an example of our college itself, right? In the college, you issue a certificate, right? So let us take an example of a BTech Anna Univ degree certificate. Fine. Okay. I'm randomly, something is available on the internet. Okay, there's a certificate available given by this university to whom what it was given. This is a certificate. Everyone knows certificate will have what is the certificate, to whom it was issued, and some credibility from to validity, who issued it and everything. So on seeing this, certificate issued by Anna University, certificate is issued to the candidate, degree of Bachelor's of Engineering, Civil Engineering, first class, April 2018. At the bottom, we find who issued the certificate. So this is a traditional certificate, college certificate. Same way, when we talk about a digital certificate will have what is a digital certificate, who issued the certificate, to whom the certificate was issued, how it was issued, how in the sense some credibility. You know, right? We saw yesterday some cryptographic algorithms will be there, some hashes will be there for the verification purpose, right? So that is called as a digital certificate. Just like you normally see a degree certificate, right? We'll see how a digital certificate works, right? Same way, there is something called signature, digital signature. We don't confuse this digital signature with scanned copy signed, right? This is what we do every day, right? When some college or someone asks you when you are not available, you sign it and send it to them. Take a photo and send it to them. They will remove the background and put the signature in the document, right? This is called as a normal signature, right? For example, inked sign, right? For your identification, it's an inked signature. What will be there in the digital signature? Digital signature will be saying that who is the signing authority, who signed it, and also will have some hashes, right? So for example, a degree certificate will have a inked signature of a, let's say, inked signature of the registrar or VC or someone, fine. Okay, same way, a digital certificate obviously will have digital signatures in it, but these two are different concepts. When we talk about cryptography, asymmetric cryptography, you remember public key, private key, fine. Same way, a digital signature concept, the key possession will be of one order. In digital certificate concept, the key possession will be of exactly the reverse order. I don't want you to say that in depth. If you're hearing this for the first time, you'll get confused on that. But we'll see what exactly is the digital certificate at first. So let us visit some website. I'm visiting a common website, the university website. Let's check on to. I'm randomly opening a website somewhere on the internet. Maybe. See, this is a website. So that is having connection is secure. It is saying that the connection between that website and I am the client connecting using my Chrome browser is secure. Why it is secure? The website has a certificate. The certificate is valid. Let us check what is there in the certificate, right? And this is typically showing the difference between HTTP and HTTPS. By this time, everyone should know the difference between HTTP, port number 80, running traditionally. HTTPS, by default, it will run on port number 443. HTTPS is so-called secure because between the sender and the receiver, the data is encrypted, right? Encrypted means, you know, right? The data is locked. Obviously, it will have a cryptographic algorithm. It works on the basis of TLS, transport layer security, right? And the actual protocol is SSL, secure socket layer, fine. So when you say a website HTTP, normal data, when you say it HTTPS, the data is encrypted. The algorithm behind that is TLS SSL, right? So let us see this website. In this website, let me open the magnifier so that we can see it in the zoomed one. Zoom. Okay. You see this? Issued to aniv.edu, right? Some additional details. Valid period from October 5, 2024 to November 6, 2025. The signature, the certificate is having a SHA. You remember yesterday we discussed SHA is the integrity checking algorithm, crypto algorithm. Certificate ID is there. The certificate's public key. You remember we discussed about asymmetric cryptography. The public key of the certificate is there. So anyone can online go and verify whether this website is having a valid certificate or not. Fine. The details of the certificate. See, certificate, for example, a certificate has to be issued by someone, right? I have a certificate issued by my university. Same way, this university is having a digital certificate that is issued by a third party, right? In India, many companies, they have authority to issue the digital certificates, right? See, they have, okay. They have the version 3, serial number of the certificate, unique ID, certificate algorithm, they keep PKCS, SHA 384 variant with RSA. Issuer, it is issued by the User Trust Network, a company who have issued from New Jersey, right? Validity, the end validity is this date, this time, this year, right? And other than that, the public key info, the public key algorithm, the actual public key, it's using, if I'm not wrong, RSA 4096, fine. Then certificate, subject key, certificate basis, signature, SHA, that's public key and everything. So that's that. So when you see a website, right? When you see a website will have something like HTTPS. It says connection is secure. The connection is secure because the website has a valid certificate, right? Valid HTTPS secure certificate issued by a certifying body, right? Let me check, like companies that can issue digital certificate in India. Let us check. Let's check onto the images. It will list a list of companies, right? Even Indian government has something called, you know, right? DigiSign. E-Mudra, Indian government's thing. DigiSign, PDF signer, Signex, Express, SIFI, vSign, different vendors for issuing a. Yeah, just a minute. Yeah. So again, we will see this with a even simpler example, right? I am typing Aadhaar red, green, and orange signs. Cool. Just a minute. Orange tick marks. Fine. Yeah. You see here, this one. Yeah. Most of you, when you submit Aadhaar somewhere outside, right, you might have noticed this. Right, you might have noticed this. You are submitting the Aadhaar PDF, directly downloading from the Aadhaar website, or else you might have downloaded and you might have printed in a PDF and you might have submitted it. You might have noticed this. What is this? This is typically a digital signature. You see, Aadhaar's digital signature. The digital signature of the Aadhaar card might be issued by the Aadhaar signing authority. They have issued it to Ashok Kumar. I am sharing my Aadhaar PDF copy to someone. The signature is valid. It will show, hey, the signature is valid. the signature is not known, maybe net might not be connected, it is not verified, it will show this exclamation mark, right? Sometimes it might show you something called as Aadhaar red X mark, right? Fine. Invalid PDF signatures. It says, hey, this website claims to have a signature. Sorry, this certificate claims to have a signature, but there is not valid one. Fine. So let's assume like your university is getting, your college is getting a certificate. A student have passed out in 2014. Name, department, marks, everything. But you check your database, nothing like that is there. What you will reply? Hey, this student didn't study in my college. Same way, a document with a digital signature, right? If it is valid, it will have a green tick. If it is not verifiable, signature is there, but it's not verifiable at the moment. It will have an yellow color exclamation mark. If there is not a valid signature, it will have an into mark. Fine. So example, correlating that with your Aadhaar. Okay, that is about digital certificate, right? For a website, digital signatures individually. In India, there's a website called eMudra, government one, right? So where you can go and get your own digital signature, not a digital certificate, right? Digital signature. Fine. If you want to get a digital signature, say I own my company, I am the director of my company. I have a digital signature for my company in my director ID. Right? Again, you remember, this is one of the form of authentication. How I can authenticate? I am the director of my company, signing a contract document, right? eMudra dongle. When you pay them 3,000 rupees, 5,000 rupees based upon the plan, they'll give you a pen drive like thing. Just it will look like this, pen drive like thing. If you are a part of the college admissions team, accounts team, or finance team, management team, when you submit to university website, when you submit for a contract or a tender, you might have signed this using your college eMudra or your principal's eMudra, registrar's eMudra, right? This is how it will look like. Inside this, nothing much. Whatever we have seen here in this certificate, connection is secure, certificate is valid. Only this certificate information will be there in a dongle version. So that this is a signature. This signature, you can put it over a PDF document, right? You are certifying that I am the owner of the college or I am the owner of the company, right? So eMudra is a common website in India where you can go and buy a digital signature for you. Sir, I want to get a digital certificate for my college website, right? We see SSL free. There are many websites, SSL for free, where you can go get. You remember this SSL? I mentioned HTTPS. This means encryption. Encryption is backended by transport layer security. TLS is actually working on the foundation of SSL. So if your website has SSL TLS, it's HTTPS, right? So you can see here, you can go and get a free certificate for this, right? Create a free certificate for your site. For example, I'm typing www.akmohan.in, my personal website. I believe I already have a certificate, but let me check. Okay, it will ask me to log in, right? Once when I log in and get this a free certificate, it will give me a SSL certificate. I can go add it in my website, right? Previously, when you type akmohan.in, right? You see at the top right corner, certificate connection is secure, certificate is valid. You saw the Anna University certificate, right? You see this certificate, a different certificate. Certificate is issued to akmohan.in, my website. I have a certificate got from Let's Encrypt Webs company, right? So that is valid from September 5, 2025 to December 4, 2025. Certificate, the public key. Then you go to the details of the certificate, version, serial number, certificate signature, who issued it, root certificate. And when you talk about digital signature, digital certificates, we have something called as PKI. Anyone teaching cryptography, you may teach something like that. PKI, digital sign steps. Let's check onto this. Yeah, this one. Let me open this. Yeah. See, there will be a CA, certifying authority, receiver, right? And there will be a sender. So sender, right, public private key works here. I want to send something to you. I'll take your public thing, sign it and send it to you. If you want to verify me, you can verify me in the certifying authority. Just like someone coming to your college, giving a degree certificate and verifying whether the student had clearly actually completed the degree. So there will be a certification authority. There will be a receiver and sender. There will be something like a revocation authority. Someone can revoke your certificate, just like you cancel a degree. Someone can revoke your certificate, right? So it works on this PKI principle, right? Public key infrastructure, right? I don't want to take any complex diagrams. It might confuse, right? But actually, the whole of the PKI works like this. You see, worldwide, you go to the website, registering authority. Step 1, you register the certificate. Fine. Step 2, your registration is confirmed. Step 3, it is you when the registered, it goes to the certifying authority, a new entry. Just like you join a college and get your ID card, a new entry is put. Step 4, a copy of that, the ID and the password is given to the user. Step 5, the user goes to the website, gives their identity. The website want to verify. The CA will give a copy to VA. The VA will have a database of all the registered users. Anyone can go to the VA and verify, right? Verification or validation authority. So there will be RA, CA, VA, the end users, right? But the common is certifying authority and the end user. So this is all about digital signatures. You see here, and again a 2-mark definition is there. Digital signature is created by taking the hash of the message and encrypting it with the sender's private key. The recipient then uses the sender's public key to decrypt the signature. I sign it with my private key and send it to you. You can verify my signature with my public key. Yesterday we discussed public private key pair. Fine, that's how it works. So HTTPS works based upon SSL TLS or TLS SSL. Fine. So SSL is issuing certificate to the website. Same diagram is given here. How to digitally sign. Private key on one side, public key on the other side. SSL Labs, DigiSecure. We have seen a couple of websites here. Okay. So now we'll see. I hope it's clear. Signature and certificate. A certificate will have a signature in it. Just like your degree certificate. Same way, a digital certificate might have a digital signature in it. But digital certificate is a unique identity. Digital signature is a unique identity. Don't confuse them. And again, don't confuse this signature, right? Scanned copy of sign. We face this issue in many educational institutions. Someone asks you, sir, sign the document, digitally sign, put a digital signature on the document and send it to me. Even I did the same thing before 10-15 years, right? I'll sign it, scan it, put the sign in the Word document or PDF document. That is not a digital signature. That is a scanned copy of your signature. Digital signature is actually your electronic signature. It's not only a sign, it should have a actual fine. You see here, for example, I've opened this document, your class notes using this Foxit. Let me open it. Foxit PDF reader, I use it regularly. Fine. So Foxit PDF reader, when we go home, comment, view, form, protect, you see here, file and sign, right? I can put a signature, manage signature. See, I can put a digital scanned copy of the signature, convert it into a digital signature, verify it and use it. But scanned copy of the signature, what we sign, is not a digital signature. It's a scanned copy of the signature only. Fine. So you see here, e-sign. You remember you're able to see my signature. I have a password for that. Let me check whether I read. Okay, see, I'm dragging my signature. I'm pasting in this document. Fine. This is not a scanned copy of the signature. When I give you this PDF, right, you can clearly verify the signature. Not only the signature, when you check onto the info of this PDF, it will clearly say Ashok Kumar signed this signature using Foxit, the signature ID, everything will be here. Fine. So this is a digital signature. Fine. Just like you see in your Aadhaar, a tick mark, into mark. Same way you receive this, you will be able to see the tick mark, into mark, depending upon the validity of verifiability of the signature. Sign and certify. For example, place a signature. That's what we did. e-signature is processed. Already I've submitted it, so it's not allowing me to put another. Fine. Digital IDs. You see here I have a couple of certificates which I have. I can put any one of them. I can export this certificate. Save it to a data file. You see, I can export a cert file name.fdf, so that this certificate I can use it in some other system also. Certificate details, valid from and to, who issued, to whom is what issued. Fine. So this is really a digital signature. Fine. You see here, you won't be able to see the signature here unless and unless I save that, it won't be visible here. Yeah, it's here. Fine. So DNS, VPN, proxy. Fine. So next concept which you are going to see is something called as a DNS, domain name system. If I'm not wrong, fine. DNS. The first day you remember we saw DNS. DNS is like your telephone directory, converting between the www.website.com to 170.168.1.1 IP. So conversion between the lookup table between domain and the IP, just like your name and phone number, that is called DNS. Fine. We already have seen the DNS. Fine. Some websites to check this. Fine. VPN and proxy. Let's check what is the concept of VPN and proxy. Let me say Frigate VPN. I'll give an example. When I was doing masters at the university, fine, the university had a firewall. Fine. The firewall says, hey, you are a student, you are not allowed to open facebook.com. You are not allowed to open WhatsApp. Fine. But for the faculties, the access was there. So what we did, we searched for a VPN, a virtual private network, an application, right? Frigate is one application. To download that application, install it in your system. Thereafter, traffic going from Frigate, from my laptop to the college server to outside world will allow me to open facebook.com. Fine. It's typically a proxy. You see here, that's what is given here. Proxy is something between the sender and the receiver. VPN is a traditional type of a proxy in which between the sender and the receiver, there will be something intermediate. Fine. For example, I leave it Frigate VPN. VPN working. Yeah. Let us see this. I'm opening the image in another tab. Yeah. See, without a VPN, from your device, an IP address to the internet, Airtel, BSNL, Jio, it goes to the website. So with the VPN, from your device, your college or company might have a VPN. Again, it can be a hardware or a software, right? Insert. So it will go via the VPN client and the VPN server, then to the internet. This VPN acts as a tunnel. Obviously, VPN is holding all your encryption stuff. It encrypts the whole of the data. Fine. So, for example, let me type Sonic Wall VPN. At the university, this was used, right? Sonic Wall VPN. The time was harder when all of us was forced to work from home for taking classes during Corona lockdown. The university gave us a VPN. So from house, you log into the VPN, go to the college server, take the PPT, you take the class via MS Teams. Fine. Let me close this. So DNS is domain name system, mapping between domain to IP. Reverse DNS is IP to domain. VPN is an application between the sender and the receiver. When the data goes on the internet, VPN acts like a tunnel or a pipe with which your data will be secure inside the VPN. Proxy, between the sender and the receiver, there will be a proxy. You connect to the college, you type your gmail.com, your college has a proxy. They can monitor what you are typing, right? So typically I see whenever I go for a visiting lecture in some colleges, when I ask them to connect the internet, they will put an IP in my network settings and they will connect. When I start capturing the packets, it will say go via the proxy. Again, you go, you be a part of the college, you accept to their terms and use the proxy, right? Proxy is typically a man in the middle between the sender and the receiver. Proxy can be for any purpose. Colleges use proxies, government do proxy, companies do proxy, attackers do proxy between the sender and the receiver. Whatever attack we have done, right? Cross-site scripting, cross-site request forgery, any of the injection attacks, the attacker acts as a proxy between the website and the legitimate end user. Fine. Man in the middle, right? Is set on the things. So this is done. Cyber kill chain, interesting topic. Fine. Cyber kill chain. Let's see how many are here. Just like ISO SLAS, 1, 2, 3, 4, 5, 6, 7. 7 steps are there, right? Let me close all the other old stuff. 7 steps. Cyber kill chain. Let's take a diagram. Maybe any public diagram for a cyber kill chain. Lockheed Martin, he's the founder of this principle called cyber kill chain. So it's called Lockheed Martin's cyber kill chain. Like just like we call Pythagoras theorem, right? Let me open this image. Okay, now it is clear. See, there are 7 steps. This is called as a cyber kill chain. Let us say like weak chain. Let's see an example of a weak chain. You see, this is really a big chain. As you see here on the screen, the chain is there, interlocked. One point there is a weakness. You pull it on any of the side, the weakest chain breaks first, right? So that's what an correlation given here for this cyber kill chain. Fine. So cyber kill chain, the attacker wants to do 1, 2, 3, 4, 5, 6, 7. 7 steps to complete the attack or to complete the so-called hacking. If you are a security professionals, you need to stop the attacker in any one of these steps or any 2 steps. You cannot block them in all the 7 steps. In current day scenario, attack are complex. Attacker have to completely successfully complete the 7 steps. The defender security person has to break the chain in some places, right? So it's a cat and mouse race, fine. So let us say when you go out again, when you teach or when you study or when you do a certificate on ethical hacking or hacking, right? They say 5 steps in hacking, 7 steps in hacking, steps in VAPT. They run parallel with these steps, right? The cyber kill chain. So someone wants to do an attack. Your competitive college wants to do an attack on your college. They will do something called reconnaissance, right? If you are hearing this for the first time, reconnaissance is a dictionary word, yet a military keyword, gathering details about your target or enemy, right? So someone wants to gather details about your college website. What they will do? Harvesting email, conference information, everything. So someone visits your website, as I said, they can come to your website. There are applications called crawler. They can crawl your website with a simple Python script or Perl script, and they can collect all the mail IDs available in your website. So what the attacker is doing? They have done a reconnaissance. They have found what is your website, what is the server your website is hosted, the server version of your website, what all the email IDs available. Fine. With the basic details collected, the attacker will go to step number 2. Fine. What is step number 2? Weaponization. You remember, right? If you want to blast a building, you need to select the appropriate bomb. So they will select based upon the basic details collected. They will select what weapon to select. In yesterday's terminologies, you have found the asset. In reconnaissance, you will get the vulnerabilities. From the vulnerabilities, you will select an exploit. Fine. Let us check exploit DB. You remember this website I have opened maybe yesterday or day before, exploit DB, where I go and find there's a vulnerability in the website. Let's say your website, most of the website use a server called Nginx, right? You see here, Ingress Nginx remote code execution vulnerability, right? So the exploit DB is giving this is a vulnerability released in 2025, vulnerability number 1974, right? We'll see what exactly CV is, right? So when you click on to download, it will download and give the vulnerability. It may be a Perl or a Python or a text file. where the code you see here, the same code will be there. Those who teach C, Java, Python, you know, it's a code, exploit.py, a Python code. When you run this code against your target is running on Nginx server version 4.1.11, lesser than version 4.1.11. You will be able to do a remote code execution. Let us see what is this remote code execution. Let me check. A mode. A vulnerability is identified in your website. A payload is created. Virus is created. Exploit and delivery is done. The code is executed in your system. The attacker gets the control. Right? RCE, remote code execution, is an attack, a cyber attack that allows a malicious actor to execute an arbitrary code on a remote machine. I am an attacker. I am not allowed to get into your college server, but I am coming in. I am executing a code. By executing the code, I am able to get the Excel sheet, which is having the salary statement for the last month for whole of your college. Fine. Something like that. You can execute a remote code and get control over the system. Either you can see, either you can edit, you can steal something from that and come out of the system or the network. Okay. Let us go back to that. Okay. Weaponization. After reconnaissance, in weaponization, you will find the exploit. Then delivery. You need to send that to the attacker, right? Sorry, victim, right? So you send it over an email. You give it in a pen drive, you send it over an attachment, right? Delivery, just like you're delivering a letter, you can deliver via email, web, USB, or anything. Step 3 is done. Step 4 is exploitation. The exploit is delivered there. The user have clicked onto that email. They have downloaded that part, exploiting a vulnerability to execute the code. The user is opening the, for example, let us assume I am opening the attachment to the attacker you have sent using this Foxit reader. I go to my help. I go to my about Foxit reader. See, version is 1.0.27. When I check for update, the current version might be 1.1 or 1.2. Fine. So if the victim is using older versions of software, hardware, or any application, the exploit will be created for that. After that, installing the malware. Exploit is active. It works. The virus is installed on your system or server. Step number 5. Step number 6, command and control. This step number 6, CNC, we can correlate this to something, a real world example. When you see this image, zombie, humans, some image may be sensitive, so it is closed. So you know this zombie concept, right? Zombie or zombie concept, right? Someone bites someone else, they become zombies, right? This is a zombie concept, right? So whenever all these steps happens, till installation is done, your system becomes a zombie. It is going to send some data to the attacker. So that is called command and control. Attacker sitting in Russia, China, some other countries might control your system, right? So the command and control server, let's say every night at 2 o'clock, your system will send a request to the zombie. The zombie will say, hey, this command and control. The command and control will say, I am having 10,000 systems compromised in India or inside your college. From that, they are going to attack your college server, college exam server. When you investigate, you find only your computer attacking your server. Because your computer is become a zombie. It have become infected and it have doing an attack. What is the purpose of doing all these things? The last step, action of objective. The purpose of an attacker to do one recon, to create a weapon, to deliver it, to exploit a vulnerability, make it install, get a command and control. The ultimate reaping is at the end. He wants to put a virus. He wants to steal your data. He wants to format your website. He wants to delete your data, anything. That is called action of objective. The objective of the XYZ hacker, right? So this, in a combination of all the 7 steps, is called cyber kill chain. Lockheed Martin's principle on cyber kill chain. So the attacker wants to successfully complete this attack. You are a security professional. What you want to do? You want to break. For example, attacker have done a reconnaissance on your college website. Okay. They have created a weapon. Fine. They have delivered it to your email. Okay. They have exploited your PDF reader. Okay. But before installation, your computer antivirus stops. Hey, stop. This PDF file you are trying to open has a virus. At step number 5, the chain is broken. But let's assume that is done. Step number 6, the virus is installed in your system. You go connect to your college server. The college is having a SOC, Security Operations Center. You remember yesterday we discussed Splunk, Wazoo, QRadar tool. The tool will monitor, hey, your college system morning at 10 o'clock is sending a request to a IP in China. Your security device might monitor. You can break it at step number 7. Not only 5, 6. Even you can break it number 2 or 3. 1 is most common, right? Anyone can do a reconnaissance, fine. But you can break it starting from step number 3, 4, 5, 6. Fine. So that is on this concept, cyber kill chain. All these 7 steps. I'm not going to read the 2 marks, fine. So whatever I explained is just given here on these 7 steps. A diagram, websites to check. CVE, CVSS. The important part, see nowadays companies, cybersecurity companies, recruiting candidates saying that they will give a website, ask you to make a security report. You need to submit the report. Based upon your report, the company will give you a job. So I'm calling students from your college. I'm giving a subdomain website in my company website, the dummy website hosted. I keep it vulnerable for purpose and ask your students to give me a security report or a pen testing report, right? So what will be there in the report? Hey, your website is completely secure. Currently, no website claims to be 100% secure. They will say, sir, your website is vulnerable. I've got some 10 vulnerabilities, 1 critical, 2 high, 3 medium, 5 information level vulnerabilities, right? So how to rank the vulnerabilities? When we started the session, we discussed about CVE, right? CVSS. Let's check what are these. CVE and CVSS. You see the score between 0 to 10, right? 0.0 to 10.0. But keep in mind, you cannot randomly give the score. Everyone knows the formula for A plus B whole square, right? Same way, there's a formula for calculating this. And there are 2 entities involved, CVE and CVSS, right? So let us check. CVE, that's a website called CVE, mitre.org. They run this website. Just like OAS, it's yet another organization. CVE. What I want to do, let me allow the cookies for time being. I'm searching, see. Enter the keyword SQL injection. See, let's search for SQL injection. See how many CVEs are released. Let us open one CVE. Fine, I'm opening a CVE, a vulnerability. Vulnerability number is, again, how to decode a CVE. Decode a CVE, images. Yeah, this one. CVE is common vulnerabilities listing. It was released in the year 2019. CVE number is 1214, 1215, 22,200, something like that. It will be there. So now let us check. This is a CVE released on year 2025. The CVE number is 9,932. It is published, verified and published. Fine. Let us check. The CVE is the vulnerability on PHP, the website running on PHP, SQL vulnerability, PHP, this Gurukul Beauty Parlor Management System. Let us check what is this. Images. See, there's a website which is giving you a free website for beauty parlor management, a PHP code, a free PHP code. That code has this vulnerability that is identified by some security professional and they have reported it. Fine. The flaw has been found in this PHP code 1.1 version, affected by the vulnerability in this page, admin update image.php. If your website is running on this code, your college.com/admin/update image.php might be vulnerable to this SQL injection attack. What is the score? 6.9 out of 10. Have you got the score? This is the formula for the score. CVE is the vulnerability. CVSS is the formula system, typically a common vulnerability scoring system. CVE.org, where you can go and search for vulnerability. Let's say you want to find a vulnerability. Everyone uses MATLAB, common softwares used in colleges. See, MATLAB is having a, Jenkins is the company, MATLAB plugin. MATLAB is having a vulnerability, you see, a cross-site request forgery vulnerability. You remember, we discussed about CSRF. 2023, it was released. 49,656 was the vulnerability ID. Cross-site scripting, cross-site request forgery vulnerability. In this Jenkins MATLAB plugin 2.11.0. So when you see this, right, when you see this Jenkins MATLAB plugin or this CVE, I copy this CVE, I go to ExploitDB website where the exploits viruses might be available. You can go and search for this. Fine, you need to give the CVE or MATLAB. Search filters might differ. Jenkins. Yeah, see Jenkins, Control F, SRF. Okay, see it's showing a cross-site scripting vulnerability available in Jenkins. Stored cross-site scripting available. Jenkins 2.235.5. This Jenkins 2.1.0. That's what it's recommended. You have an application, hardware, software application. You need to update it. 2.11, 2.12, 2.13, update to the latest version. Update, the company, the owner of the software or hardware gives the update because of that's a vulnerability identified. That's a threat actor is there. There might be a CVE released online. They are giving a patch for the vulnerability, right? You and me cannot go and patch all the softwares. When you get a paid software or even free software, they give the update for the purpose of patching the software, right? So don't never ever stop any update on your Windows, on your Android. There's an update, let the update run. That will make your system or mobile secure. Fine. Okay. So CVE, we have seen CVE. We'll see what is CVSS, Common Vulnerability Scoring System. CVE is run by Mitre.org. CVSS is the scoring system run by First.org. Fine. It's another security group. Fine. So you check the calculator at the left. CVSS calculator. You see this? The calculator is having something. Attack vector adjacent. Attack complexity high. Attack requirement present. Privilege required low. User interaction active. Confidentiality high. Integrity high. Availability low. When I complete this base matrix, you'll see the formula. Confidentiality high. Integrity low. None. Fine. So when you just select specific options from here, you see at the top, the score is getting calculated 6.7. Right? When I change something here, the score changes 8.5. Fine. When I change something, the score changes. So this score, just like A plus B whole square, CV score is calculated based upon 3 group of matrices. Base matrix, supplementary matrix, and base matrix is main, environmental matrix is second, and the third matrix. So these 3 matrix. Now I hope we are coming on to scoring system 4, right? Let me go to CVSS scoring 3 version, right? 3 will have, see, base matrix, temporal matrix, environmental matrix. Now they are updated to the latest version of scoring, so the matrices have increased. Fine. By default, attack happened over network. Attack complexity is high. Privilege, it doesn't need any privilege to do an attack. User interaction, it is required. When you want to click that to run. Scope is changed. Confidentiality is affected, high. Integrity not affecting, none. Availability low. When I complete this, the first part, when I complete all the options in the base metric, the formula will start calculated. Till then it will become 0. This temporal and environmental are optional, but it also has to be given. You see the change in the formula, but you cannot randomly click on here. Based upon the attack, someone has to sit and calculate this formula. Nowadays, we have XYZ tools to calculate this, but even there's a human intervention required to verify the match, right? So that is called as CVSS. CVE is the vulnerability ID, like your name and roll number. CVSS is the formula, like marks 10, 20, 30, 40, 50. It is a score between 0 to 10. CVE, common vulnerabilities and exposures. CVSS, common vulnerability scoring system. Fine, okay. CVSS scores. NVD, National Vulnerability Database, they run this CVE, CVSS on the top of the hierarchy. Top security tools for this, fine. Okay. So CVE, CVSS. Before getting onto the tools part, right, we'll try to calculate a score for something, or else we'll see. I hope everyone uses GPT, Perplexity, right? Let me log into my Perplexity login. I hope I have one. Okay, I'm asking this Perplexity to do something. So you remember APT 36, Indian Post Office attack. Fine. Yesterday we discussed, right? APT 36, Indian Post Office attack. For the same example, we'll try to do something. Let me open this. Let me go to the research mode. Fine. Hey, assume you are a 20 years experience cybersecurity expert India. That may be a typo error. It will automatically create. Calculate the CVSS score for 3.0 and CVE associated with so and so. Also show me the Mitre attack. I'm showing it here. Mitre, ATT and CK is the framework. Mitre attack life cycle for cyber chain with real statistics. Fine. I'm running this. It will run for 2 or 3 minutes. Let it run. In the meanwhile, it is running. Let us go back to the thing. Okay. So whatever we have seen from the first on day 4 today, it's all about the real world implementation. A guy who goes as a security engineer, fresher, after studying from your college, maybe a computer science student, a cybersecurity student, an AA student, who gets into a company for a security engineer. They want to know all these things. Company wants them to know at least these basics. Whatever we have discussed today, they need to know these basics. Fine. So top security tools, fine. So I've listed the top 10 tools that is available. WASP ZAP, Nmap, let us check. WASP ZAP, ZAP proxy, right? ZAP is a proxy between the sender and the receiver. So WASP ZAP, if you download and install, you can try all the WASP top 10 attacks. Z attack proxy, that is called ZAP, fine. That is one tool, fine. It's a scanner. It is scanned. For example, you log into your college. Go to your college.com, give your faculty username and password and submit. This can scan how you are going to your college. What is the GET request you are sending? What is the post? What is the reply it is coming from the website? It can scan. If someone is able to scan in this level only, they can try all the 10 attacks. They can do an injection. They can do a cross-site scripting. They can do a cross-site request forgery. They can do a directory traversal. They can do a password brute force, right? So WASP ZAP is one of the most common application from WASP itself for freely available for checking the top 10 cyber vulnerabilities or infosec vulnerabilities. Nmap, network mapping tool, online. See, Nmap is a tool, interesting tool, common tool used in this step. Let us go up. Nmap is an actual tool that is used. Let me come down to this place. Okay, this one, yeah. Reconnaissance, recon your network, right? The first step in the chain, gathering details about your enemy or target. So Nmap is a tool is used to gather details about your target. You see here, Nmap scan started. You are scanning a website or IP address. The website result says, hey, welcome. This IP is available. This website is open. Port number 21, TCP open. Port number 22, SSH open. Port number 110, POP3 open. Port number 53, DNS open. Right? It's typically showing all the ports open. Fine. So there are some online websites available to show this. Let me show you those. Let me close this, close this, close this. Let this run. It will run for some time because I've given a detailed prompt for it to get us a result. Okay. So there's a website called shodan.io. It's an online website like Google to find or search internet connected devices. Fine. Let me search Shodan query for finding EDU websites, education websites, EDU websites, India. Let us put a mode. Let it go. Search me the syntax. Host name EDU, country India. I'm searching for the websites in India. Sometimes Shodan will ask me to log in, right? I'm searching it here. Let's check whether it's asking for a login. Yeah. It wants me to log in. Okay, leave this. I leave the host name, country India. I'm not sure which account I have logged in with my things. Fine, leave it. Let me check Shodan results. Images. Let's search for some images online. So that a Shodan result will look something like this. Thanks. This one. Yeah, see the Shodan result says, hey, welcome. You are searching for some search query. The website is available in 74, 131, 151 IP. The server is running on this THTTPD, this version. Last modified doc type. This in US child, right? They are searching for a query called WVC80N. Let's check. WVC80N. What is this? See, they are typically searching for a camera. You see here, if I'm not wrong, they are searching for a Cisco wireless camera connected on the internet from US. So that is listing a website, a company or a college who's having a public IP. In this IP, there's a website, so there's a web camera connected on the internet hosted here. So not only camera, they can see the website, they can see your printers that is connected on the internet, right? So everything. Shodan is a website for finding internet connected device. Any device like your mobile or your laptop or your college CCTV camera or your college printer, college server, anything has a public IP that is connected on the internet can be seen using Shodan. Fine, just like viewing it. Let me close this, close this, close this. Okay. I hope we have got the detailed summary report. Copy this. Let me open a Word document and let me paste this for you. Let's see what happened in the. See how many references, like a 63 references research paper, like this it looks like. But you see here, we have asked them about that APT. Fine. I want to completely copy this. Control V paste. Page with these 3 pages. Okay. Let me select this, the whole of the result. Copy this and paste it here. See, it have clearly given me. Let me paste and keep the original text. Sorry. Paste. And keep source formatting so that the images and other things will be visible. Okay, let us check on to them. So I have created a APT Indian Post Office attack CVSS scoring mid-range score. So APT 36 is the transparent type. APT, a virus that infected post office domains. It was infected using a malicious PDF, clickfix, PowerShell command, Windows. It have two types of infection. Infecting Windows users, post office users who used malicious PDF via clickfix vulnerability, PowerShell command. You remember first day we saw the blue color screen, PowerShell command on Windows computer. Or else any Android user also can be infected. See, the CVSS scoring 3 base score is 7.3 high. Why? Because the CVSS score is for AV, it is this N network. For AC, it is L. For PR, it is N. You remember I selected the formulas, right? So that's how it's calculated. So it's not like randomly you can select the formula, right? You need to only those who have a domain expert in that will be able to select these vectors, right? So that is done, right? APT, right? CVE. So any of your Windows computer having these older versions of Windows can be infected. CVE 2010, 2019, 2024, fine. Attack framework, reconnaissance. I have not discussed about attack framework here. APT and CK. Mitre has something called attack framework. It will have all possible combinations. You go to a shop and nowadays you go to a cracker shop and find different types of crackers from the first till last. Same way, see from reconnaissance till the final phase, we can find, see reconnaissance, active scanning, 3 different types of active scanning. Gathering victim T1592, gathering using information 1589. So let's say the attacker have gathered information via organization information, your website. Fine. So that is the start of the attack. Let's go back. Just a minute. Yeah. See, in the reconnaissance, someone have just found vulnerability in your organization website 1591. Then they might have acquired from your compromised accounts. Then they might have got control over an email. Then they might have sent you an email. They might have just asked you to click onto a link, right? So reconnaissance, initial access, execution, privilege escalation, credential access, lateral movement collection, detailed step-by-step process of this. Any of these permutations combination attack can happen. So we have calculated in the reconnaissance space, the attacker have used for this attack APT 39, sorry, APT 36, this post office attack that happened this year early, right? So they have used 31592 T1598. Then resource development T1583 subdivision 001. Initial access, execution. See, a rat called Crimson Rat, Eliza rat, oblink rat. This rat is not a normal household rat. This is RAT, remote access Trojan. It's a computer virus. Just like a home rat, it can infect your computer or network and hide inside the system, right? Defense evasion credentials is bypassing the security. See, even in government website, they might have basic security. They have found how to bypass that security also. So that is called defensive techniques. Collection exfiltration, what details is collected? 70% of breaches with 100 GB of data stolen from the customer, end users. Command and control server, you see, the command and control server was active somewhere for 200 days. Telegram bot that was running in Telegram using Eliza rat. Fine. So government have found they have hosted a website in this modgovindia.space, semisitelive.store, fake websites hosted. So that's what is given. You see here, reconnaissance, weaponization, delivery, exploitation, installation, command and control, action of objectives. It's done. See, what is the result of this APT? It is over 12 years. The APT36 is not only affecting India. It is proclaimed to be from Pakistani hackers group. 12 years of attack. It have attacked 27 countries, right? It have 1,000 victims, active victims from India, Afghanistan, Iraq, Germany, right? Target distributed government organizations, education institutions, technical infrastructures. It has a CNC server. You remember? Command and control server hosted on the internet. ElisaRat, NetRat, CapraRat. For Android, they have AndroRat, Pepi, all the viruses. You can find the bunch of these viruses in the exploit DB. Fine. They have used a spear phishing, one type of phishing, targeted links sent for specific customers, those who are using postal website or postal application. How many devices attacked, how it happened. Find the whole step with some results. So if you see on the website, there should be some statistics also shown here. You see here. Let us check. They are showing how the attack happened, impact, exfiltration, how the attack happened. Then they are showing reconnaissance, APT kill chain detection rate. Reconnaissance 15%, weaponization 36%. The detection rate, how the attack might have been detected. Fine. A comprehensive result from this. So maybe like, so when I say like, I take a student from a college for interview, give him 20 minutes, ask him to make a report like this. Any XYZ GPT platform, you name GPT, Perplexity, Grok, or anything, Gemini can create a document like this. But we'll ask the candidate to explain. Hey, let me know what is an APT. Let me know what is an AndroRat. Let me know what is a cyber kill chain, right? They cannot see everything and answer it. It's good to use LLM platforms to generate reports because it's publicly accessible, open to everyone. But after getting the report, at least you need to understand and read it. At least for the interview purpose, student should be able to explain what they have done, fine, or what they have gathered on the internet. Let us down. Okay, we are discussing about Nmap, right? Second tool, Nmap. Third tool is Wireshark. We have already seen this Wireshark tool on day one itself. Burp Suite, an interesting tool. Burp Suite. ForceMaker is a company. The tool which they have is called Burp Suite. Community edition, it's free, right? They have the professional edition, it's a paid version, right? See what will be there, what can be done using this tool. It's a real world example of the man in the middle tool, proxy tool, right? See, request and response, it's not clear, leave it. The left side is the request, right side is the response. You are going to your college, giving the username, giving the password, entering. Anyone who is sitting in the network, acting as a man in the middle, can clearly identify which website you are going, what password, username giving, what password you are giving. The difference between HTTP, HTTPS, FTP, and SSL. Sometimes they may get the actual plain text username and password. Sometimes they may get the session ID. Sometimes they may get the cookie of the system, so cookie of your session or something, right? It depends, right? So that is the name of the tool, Burp Suite. Fine. Then Nessus, it's a commercial tool. Nessus, Tenable Nessus. Tenable is the company. It's a vulnerability scanner. It will scan and give you the comprehensive report. It can do an automated scan. Every day it can scan whole of your college, 7 branches, 20,000 computers, and give you a report like this. What is the vulnerability? 147 high, 278 medium, 59 low, 189 information, right? And each and every vulnerability you see here, right side, CVSS scoring, which date, vulnerability. It will give you CVE, CVSS, mintrade.org, attack map, how to mitigate. The important part, it will give a remediation saying that how to overcome the attack, how to prevent the attack. Fine. Then SS. Snot, I hope those who teach firewall security, we teach something called a snot. Snot has an image like a pig, traditional pig with a nose, right? Just like a pig sniffs, right? The snot is a tool which is going to sniff or monitor the network traffic. It's an IDS, if I'm not wrong, intrusion detection system. Snot is a publicly available open source free version of the IDS, right? They have the most common free version of the IDS, Snot. We can install that and check. you have a college, you have the permission, you can run snot in your college and check whether what data is going out. Then Sarikata, yet another IDS tool. It's named behind this animal, right? Peeping, right? You would have seen in Discovery Channel. It will peep and go run behind and sit, right? Depending upon this nature, Sarikata, this tool is for monitoring your network, free and open source. It's an IDS IPS combination. Then there's a tool called volatility. A tool, sorry, if you put volatility, different results will come. You put it as volatility cyber, it will show you the tool with this logo. Yeah, it's a tool for identifying malware analysis, right? So you can copy the dump of your memory RAM and put it here. We can give the application saying that calculator.exe. If there's a virus inside the calculator file, this application can individually dismantle and say what is inside there. It's typically like an X-ray machine, right? So, but you need to have not only C, Java or Python, you need to have some extended level of understanding about the coding, right? You talk about some assembly level languages, right? Microcontroller, microprocessor, push, pop, right? Those level codes, how to read instructions, right? The extended version of that things. So volatility is a tool, free tool used for memory forensic. We use it for memory investigation. And again, in real world, current day, we use it for malware analysis. Fine. Okay. The 9th one, Hashcat is an online tool used for, right? We discussed about password cracking, right? Hashcat will have a crack engine which can calculate the passwords and the corresponding hashes. MD5, SHA-1, SHA-2. If you're having a username and password, your college you have a username admin, you have a password admin. You can easily crack using an application called Hashcat. There's a tool called John the Ripper. Yet another password cracking tool. There's a tool called Cain and Abel. Another password cracking tool. Again, this tool was named behind the historic characters Cain and Abel, right? Cain and Abel password. If you type, it will show you the password cracking tool. Yeah, so the tools looks like Cain and Abel password recovery, password cracking tool. Then final thing is Kali Linux. As I was mentioning about Kali Linux is one of the common Linux operating system. So-called hackers OS will have all the XYZ tools inside that. Then there is something called Metasploit. It's yet another OS, right? Metasploitable, which is going to have the whole of exploit DB inside. So you give the target, it will do all the attack. The whole of the exploit DB, viruses, scripts, everything will be inside. It know how to select the virus. It know how to send the virus. It know how to get an attack. The real world so-called hackers tool, Metasploit, is one of the offensive tool, bad tool for doing an attack. Fine. So if someone claims that I know cybersecurity, at least we see Wireshark, Nmap, Nessus, Metasploit, Kali Linux. Again, randomly putting the name in the resume is dangerous. The interviewer who sits will be 10-15 years experience. We will clearly ask about what version of Nessus you are using, what command in Metasploit you gave, right? You cannot randomly put the tool's name in your resume, right? That will create a problem. So the last 6 topics are assume each and every topic when a candidate or a student studies, they just spend let's say like 45 to 60 hours. That's how we give credits in college, 3 credit, 4 credit, right? A single course or single topic, they study something, they do some hands-on, they do some project, they'll be ready for that job. Either a job on GRC, a job on incident response, job on threat intelligence. Some of the jobs might be for freshers, and some jobs have some limitations. They require minimum 2-3 years experience and on. So today, the final day, we are going to discuss what are the foundation basics we want to cover is already done. Let me repeat, we need to know about basic hardware, networking. We have not covered something on operating system, data structures, right? So these things are also has to be a part, at least students has to define. If someone says data structures, right? Stack, queue, heap, FIFO, LIFO, binary trees, different types of data structures. If someone says operating system, you talk about virtual memory, paging, segmentation, deadlock, different types of storages, and on. Right? So again, many of the colleges, those who offer cybersecurity, right? Even I do run for some of their board of studies. So they have a course called Cyber Laws, right? A credit course, preferably in the last 2 semesters or the last year, right? Called as Cyber Laws. Typically 1 credit or 2 credit, sometimes even 3 credits, right? So, but keep in mind, we are just training a candidate for a engineering or an arts, typically a technical guy, right? So if you are just going to teach them cyber laws, that's well and good. I remember 10, 15 years ago, I was so fascinated about the cyber laws. I want to get into courts for being a cyber lawyer and on, right? But even now we get into court as an expert witness. That's a different thing. But cyber laws, if you offer as a course, it will be so easy for students to know the cyber law sections, write a 2-mark, define, differentiate, that's well and good. But industry, very few, like 1 in 1,000 might be interested in this course called cyber laws, right? But others, if you say like your student knows something about cyber laws, well and good. I believe he knows 66A, 66B, of IT Act or some IPC laws, that's fine. But industry might not be showing much interest on the cyber laws. We have it, not sure, like because of you might have made a syllabus from another university, they might have made a syllabus from another college or university. A chain goes on like that, right? The first one might have given an importance to cyber laws way back in 2010 or 2015, right? So this can be a course, but it's not recommended to be for an interview recruitment process or something, unless and otherwise a law firm is recruiting a cybersecurity engineer, they might be interested in this course. So we'll be seeing from this cyber laws till threat intelligence, the whole step we'll check. Cyber laws, as I said, I'm not going to go in depth, right? We'll see cyber laws in India. Again, cyber laws have a different scenario. Indian cyber laws is different. The US is different. Australia is different. Singapore, Malaysia is different. Each and every jurisdiction, typically country-based, they'll have some different laws, right? In India, laws, IPC, Indian Penal Code, right? And we have different jurisdiction in that. So cyber laws in India is foundation or backend by IT Act, that is called Information Technology Act, came in 2000, that was established in 2000 year. Then it was amended, IT Act amendment in 2008, and even recently some changes was made to this, right? So cyber laws, when we talk about cyber laws, what is the need for cyber laws? We are going to discuss about cybersecurity, attack, defense. An attack happens, you want to go to the courts of India and put a lawsuit against someone. You need to say them, hey, this guy have done a fraud or forgery. Everyone knows the fancy number, right? This number. Let me down to today's. So everyone knows IPC is Indian Penal Code. We have a fancy number 420, right? 420 means committing a fraud. Someone commits a fraud, right? We call them 420, right? The 420 is just the IPC section, which you can file a case against them when they commit a fraud, right? So that is on this, right? Same way, IT Act, right? IT Act have many sections. You have 66 is the majority section, which is going to talk about hacking, an offense, right? In which people lose money, someone do an attack, right? So 66A, B, C, D, E, F will be there. Then you have something like 67. Just a minute. Fine. I hope I'm audible. You're able to hear me. Again, there were some interrupts.
Yes, sir, you're audible.
So we're discussing about IPC 420, traditional laws. When it comes to cyber laws, it's called IT Act, Information Technology Act of 2000. That was lately amended in 2008. Even in 2020, we had some changes, right? So if we claim that someone have committed a fraud against you in terms of monetary terms, physically, you file a case against them in IPC 420. If someone have committed a fraud against you in so-called hacking, right? Right, OTP frauds, SMS frauds, link frauds, any of the cyber digital frauds, right? We'll file them a case against any of these sections. 66, right? 66 Act, 66 A, B, C, D, E, F. It goes on, right? 66A is no more. It has been removed by Supreme Court in 2014. But B, C, D, E, F, it works. Fine. So let's check the basics of cyber laws. You see 66, 67, And 67 is typically a specific cyber law, which is related to punishment for transmitting, storing, retrieving something related to abusive material. Typically, in sexually abusive material, it can be an audio, video, photo, or even a text message, right? So that can be filed against in 67. So in this example here, 67 is given, fine. So let me show you some real world examples. T Act 66 B C D E F. I'm randomly opening some sections from 65, 66. Yeah, this should do good. Let me check. Okay, 65 is tampering, leaving. 66 is hacking with computer. The definition of hacking was different in IT Act 2000. It clearly changed in 2008, right? Because in 2000, computers was a big box, right? You have a cabinet, you have a monitor, you have a keyboard, mouse. But in 2008, 2010, computers means even your mobile device, your tablets, your PCs, your CCTV cameras come under computing device. Any device which is capable of storing, retrieving, and transmitting the information will called as a computing device, right? So hacking computers was the older definition on 66 Act. You see 66B, receiving stolen computer. Someone, let's say you are receiving, you're not paying a license, let's say for Microsoft, you're getting a cracked versions of Microsoft software. If Microsoft finds or any company finds, they can file a case against you or your organization in this section in India called 66B of IT Act. Receiving stolen computer or communication devices. Previously, it was only hardware devices. Later, it was extended to applications and softwares also. 66C, using password of another person. Someone hacks your Gmail or college mail ID and logs into that. If you have a strong proof, digital evidence, right? So you can file a case against them in this act called 66C of IT Act. Password misuse. 66D, cheating using computer resource. How to cheat using computer? Someone who created a fake profile in your name. They started sending messages to your friend and collecting money, right? Cheating by impersonation. Impersonation is, you see here. Yeah. Impersonation is someone is pretending as if they are the other person. 66E, publishing private images of others, right? 66E. 66EF, it's cyber terrorism. 67C, okay. See this act 66EF, cyber terrorism. I'll give you a couple of sections. Maybe even if you want to do some research in cyber laws or at least for general public, please. Something called cyber terrorism is there. Then there is something called child pornography. Everyone knows pornography is obscene or XYZ materials, fine. Or else they call it as sexist materials. But child pornography is any of these materials, there is a child below 18 is involved. Can be audio, video, photo, or even a chat message. So if you know, right, you are responsible for your mobile, you are responsible for your Gmail, your college is responsible for all the computers available in the college, right? Same way, so if your systems or digital assets has anything related to cyber terrorism or anything related to child pornography, it's a highly offensive crime. Not only in India, globally. In India, these crimes are non-bailable, at least for the first 3 months, right? They find you against having a child pornography evidence, or else if they find you against sending or receiving a message related to cyber terrorism, right, against the sovereignty and integrity of the nation, they can, without any question, they can arrest you and put you behind bars, right? Bringing a lawyer, asking for a bail, and other things are later, right? So keep in mind, you or your organization. Again, that's what we recommend: regularly auditing the computers, right? Because regularly auditing will let you know anything, something like that abusive is here, right? So that is on 67F. So I'll just give you one section. Maybe we'll discuss about one section, 66B of IEA, right? Sorry, 64B of IEA. IEA is Indian Evidence Act, right? 64B of IEA. Certificate. Let me search for that. Yeah. Just open image in new tab. Let me open this 65B. 65. Previously, some sections was changed, so there was a confusion. 65B of IEA, right? Section is called 65 subdivision B of Indian Evidence Act. We'll say like, let's check what is this. Let's search for the AI mode, what it says. Cool. 65B. Let me open that. Yeah, you see here. Now we got the number right. 65B section of Indian Evidence Act 1872 governs the admissibility of electronic evidence in the court of law. Right? In current day, right? Any case, irrespective they are a civil case or a criminal case, right? They involve some electronic evidence, starting from a phone call, a photo, audio, a video, an email, or anything, right? So if you want to prove something as an evidence in the court of law, that should be something that IEA, Indian Evidence Act. So if you want to prove an evidence, there is an electronic evidence or digital evidence, right? So they need to pass this, right? 65B of Indian Evidence Act says it's like a certificate given by organizations. It can be given by a government lab. It can be given by an investigating company. Even we give this certificate for some of our clients. Last week, a client came. He was running a school, right? So in which some opponent party came, broke the school, and took the CCTV box, recording everything. So he had the recording in his mobile. So we gave a 65B certificate. The equivalent, I'll let you know the new name, new number, right? So because that was the video that was taken from CCTV to his mobile, and he wants to prove it in the court of law. Someone came, they broke, they took everything, and he asked this digital evidence recording of the CCTV from his mobile login. I want to restart. Okay. So that is on this 65B of Indian Evidence Acts, right? So this is related to IPCR. You remember, if you can remember, here couple of years ago, government have just changed something on the BNS laws, right? Indian laws has been the same laws, something in the updated version, right? Bharatiya Nyaya Sanhita, right? So the laws has been coming in the different forms. You see, like this 65B, which we are talking now, Indian Evidence Act, in BNS laws, the new laws, it is in the section of 63-4C. So we are giving the certificate in this name, the digital evidence certificate. Now we are giving the certificate in this name. The content will be the same, only the sections and some changes will be there. 63-4C, right? So this is the name of 63-4C certificate. You see 63-4C certificate. Check onto the images. Let us check what is there in the certificate. Let me open a new tab. Okay. See certificate section 63-4C certificate part A. There will be two parts. Part A to be filled in by the party. You are coming to me and giving your mobile device. That is to be filled by you. I'll give you, if I am a forensic investigator, let's say our company, we give certificate for part B. Part B will be saying that, say you gave a mobile, make, model, what is the mobile, everything. We'll take the hash values. You remember MD5 SHA-1 hashes for integrity check and put it in the certificate, right? So this is the certificate for submission of electronic evidence in the court of law. If at all you want to submit something in the court of law in India, right? So obviously the judge or jury or the opponent lawyer might ask for this certificate. Hey, wait, I accept. You have a mobile, the photo was there, it is deleted. You have a hard disk, the CCTV recording was there, that is fine. You have a pen drive, some evidence was there, that deleted. You have an email, something was deleted. Every electronic evidence we accept, but something has to be accepted in the court of law. If they demand, obviously you need to give the certificate. You see here the older one was 65B certificate. The current version, the upgraded version is 63-4C of BSA, Bharatiya Sakshya Adhinam 2023, right? So these are the things. So if you talk, I remember like when I go for some college, universities for visiting and other things, they'll give me a paper on the same thing, 2 credit course on cyber laws to be covered in 3 days or 5 days, right? So the majority of the things will cover traditional IPCs. It will cover the Information Technology Act. All sections will discuss in detail. We have some example for each and every section, the case which we handle, some benchmark cases on the internet, right? Then we'll say them what all the important things, cyber terrorism, child pornography, what has to be taken. Then the older versions and current version. So these are the things which we need to know if we claim, or else if your student claims going out to the industry saying that, hey, I had a course and I had a 1 or 2 credit course on cyber laws, right? Obviously, they need to know this, right? But I've seen some syllabuses like in which the cyber law course is so broad in the sense they'll talk about Australian cyber law, they'll talk about Singapore cyber law, they'll talk about US and UK. Fine, that's well and good. But that will cover 1 chapter or 2 chapters, right? So when I go for board of studies, I recommend them to cut short that crisply cover cyber laws in India. Believe our students, those who are going, they might hunt or search for a job, something relevant to them, right? So again, as I already gave you a disclaimer, right? The cyber law course might be there for 1 or 2 credits for students to get an idea of what is cyber law. Implementing that, really a guy who have done LLB and going on, can implement or practice cyber laws. People like us, right? You see, as I said, we used to go to court as the expert witness. So we might have made a report for our client. The client will give it in the court. The court will call back, hey, bring that guy or company who have given you this report. We'll go and say the same thing which are there in the report, sir. This was the CCTV. There was a DVR. In the DVR, there was a hard disk. This is the DVR file system. This is the hard disk file format. This is the software version. There was recording for 7 days. There was 2 recordings that has been overwritten. Before 7 days, we used this recovery software, government approved recovery software, and or NIST approved recovery software, and we are able to recover the older video. That was 1 hour video. Take the complete video, take the hash of the video, then clearly say which portion is required for the case, right? So that's how it goes on. That is called expert witness. Someone who's called to the court of law for explaining what they have done, right? So that is on this first part, cyber laws. The second part, the second topic is called hacking or ethical hacking. As I already said, I don't promote this stuff, hacking or ethical hacking. That's what it's given as ethical hacking, ethics, right? So, but nowadays, many companies, colleges, or even training institutes promote this, right? It's a need of the heart. They say, like, you need to know hacking to defend that. Fine, that's one of the facts, right? But we'll see what exactly is there in this. You remember this? If anyone can check or go back what we have seen yesterday or day before, cyber kill chain, reconnaissance, fine, weaponization, delivery, command and control, action of objective. This also covers this. It is overlapping. So that is cyber kill chain. If you talk in terms of ethical hacking, a hacker wants to do a reconnaissance, scan the target, gain access, so-called exploit, give it to the system. They click it, they open. So-called hack is done on step number 3, gaining access. 4th one is maintaining access. Every time they don't want to go back. So they will open a random port number 777 or 7777. Finally, covering tracks. Whatever activity is done by the hacker, no network is 100% secure and nothing can be completely removed. The evidences. So whatever best possible things, you walk, footprint is there. You take a cloth and wipe it. Same way, covering tracks is covering the footprints, digital footprints left by the attacker in step number 1, 2, 3, and 4, right? So this is called as the 5-step in ethical hacking. I know, right? I used to be an instructor for one of the leading ethical hacking master course, global certification, right? So whenever someone comes to us, right, in the interview and say, sir, I have this ethical hacking version 12, version 13 certificate. I am a certified ethical hacker. Fine. So we'll ask them, hey, fine, how many modules are there? We're able to clearly say, sir, there are 20 modules. We'll accept, okay, we have studied, we have known something. Fine. First module says steps in ethical hacking. It will say these 5 steps. Just like we talk about saying the ISO ISAIS 7 in order, we'll ask them, hey, here are the steps in ethical hacking. If he says 5 steps, we have to say 5 steps. We'll ask, share the 5 steps in order. We have seen like 80% of students who claim they know hacking or ethical hacking, done a certificate or done a self-study. They won't be able to say this in order. They'll say that there is gaining access, maintaining access, covering tracks, scanning. They might miss reconnaissance, a lengthy word, right? So that is on this ethical hacking. And you see, recently Cisco introduced a course, a free course, if I'm not wrong. I've tried, asked my team to try that. It works. 60 or 70 hours course on ethical hacking, right? So again, this course is interesting. Why? Because like they just give a timeline. See, you are an employee of this Protigo company. Fine. Your client is a Pixel Paradise company. They have given a scenario. When you start the course itself, they have given you are a so-called hacker or ethical hacker, right? Your company details, your client company details, right? And you're going to do this so-called ethical hacking. They get a disclaimer. Yes, I accept. Fine. Because common disclaimer for accepting the ethical grounds. Then module 1 says what is ethical hacking and pen testing, right? So there are 2 overlapping domains in cybersecurity or topics: ethical hacking and another thing we call as VAPT, right? VAPT is vulnerability, right? Assessment, ASS, vulnerability assessment, and penetration testing, VAPT, right? So companies, you see like any company, even big companies, fancy cyber companies, they won't give you an ID card called ethical hacker. They'll give you an ID card or job role called as security engineer, security analyst, or VAPT engineer, red teamer, blue teamer, and all, right? So the same thing, like we encourage students to do something on the VAPT stuff. Nothing difference. The same thing is done in the different label. Fine. The same Horlicks in a different box. Same way. Fine. So ethical hacking and VAPT are overlapping domains. Fine. So that's what in this course. Yeah. They're given understanding ethical hacking and pen testing. See, you remember they might have discussed the same thing. We discussed about what is a vulnerability, what is penetration testing. Why do we need pen testing? Why company needs pen testing? What are all the carriers? After completing this, where they will get the job? Which 3 internet job boards or few job positions? Right? Let me randomly select something. It works. Fine. Same way. So it will have each and every module. Threat actor, you remember we saw threat actor. It can be a hacker or a virus. Here, threat actors are called hacktivists, state-sponsored, insider attack. They are giving the different types of threat actors. Fine. Then what is pen testing, right? What is the need for penetration testing? Fine. Network infra. Pen testing is typically VAPT, finding vulnerability, doing an attack. That is vulnerability assessment is finding a vulnerability. Penetration testing is proof, showing the proof saying that hey, the attack is possible. PT is the actual hacking phase, right? So you can do pen testing on a network. Your college has 100 computers. It can be done. Your college has an application, college management system. It can be done. Your college uses cloud. It can be done, right? So pen testing or VAPT can be done on an infrastructure. Infrastructure can be a network. It can be an application. It can be a cloud. It can be a source code, right? Anything. So then unknown environment, known, partially known. They are given some different names. Traditional names for these are, we call it as black box, fine, gray box, and white box. You might have taught this in a traditional software testing course. In pen testing or hacking, black boxes, you give me an information, sir, do a security testing on my college website. I just know your college name, college of engineering, or your college.edu.in. Black box, only just by knowing the victim's details, you get some details, you gather some details, you follow all the 5 steps in ethical hacking, or else you try the first or second step, right? And you do some report. Gray box is the college will have a college management system, right? aums.edu.in, university management system, right? And then they'll give you a demo login, demo user, demo pass, right? They'll give you a username and password for demo user. White box is the actual page in which, imagine an employee, a worker inside your company, inside your college is a real hacker or it's an attacker. So white box is giving the admin username and admin at 123 or admin passwords. So it's gray black box without any knowledge, just by knowing the target, you do a report. Gray box, getting some basic demo details, logging in and getting the code. White box is having a complete control. Assume you are the owner of that institution. You have complete rights. Anyone captures your username and password, what attack they can do, right? That will be categorized. That's what is known as unknown black box. Known, obviously, it's going to be white box. Partial is gray box. They've given it some different names. Fine. Okay. See there, I'm just quickly walking you through this code. If you have read each and every line, the question will be based upon the line. See, the company you are working have contracted to do a network pen test on broader pen testing engagement. What will be the target in this test, right? So you want to do network infrastructure pen testing, fine. IPS, virtual machines, switches, digital front store. Choose 3 that apply, right? Intrusion prevention system, switches, replay servers. I hope it's right. Fine. I'm seeing this for the first time. Fine. Okay. So that's how it will be evaluated. Each and every module will have something. Fine. The survey different standards and methodologies. You cannot randomly say, I'm giving you a pen testing report. That's a standard. Exam means question paper should be like that. Answer sheet, the answer should be like this. That's a standard set by your exam office, right? Controller of examination. Same way, that's a standard, global standard. You remember we saw first dot standard, CVE, CVSS, METRE is one standard, OASP is one standard, NIST 800.155 standard, OSSTM, it's an open source standard, PTES, pen testing execution standards, information security assessment framework, different standards. It will say like how to do a pen test. They'll give you a sample document, how to start the work, how to start the first work, who are all the team members, who need to do what, how the report should be there, how to be submitted, a complete walkthrough. Let's assume you're going to start a college. Someone who has an experience in college will give you a document. If you want to start a college, buy a land, do these documents, register to government, put a thing, get an admission, all these things, right? In pen and papers, they'll give. Same way, if you want to do a VAPT, these are all the standards which will let you know how to make a VAPT report. And there are some lab components available, fine. Information gathering in METRE attack, fine. You see here, reconnaissance, yeah. Reconnaissance is the other name of information gathering, fine. It goes on like that. See, we have seen first module, Introduction to Ethical Hacking. It's a lengthy course, maybe like 50, 60 hours course. Planning and scoping. So everything has to be done with a plan. Hackers do something X, Y, Z. But VAPT or pen testing or security audit has to be done clearly. If you call me to do a pen test, I won't directly do on your college website. I'll ask for a mail, we'll sit for a meeting, I'll make a document, service level agreement document. I want your college higher level officials, a principal or registrar or HOD or the top level management to sign the contract. Then we will start the security audit. Right? That's the difference between so-called hacking or ethical hacking and professional way of security audit or VAPT. So there is a domain called GRC, governance, risk and compliance. We'll see that. Then importance of scoping, how to create a scope document, rules of engagement. Then module T, information gathering. Using passive active information gathering, it works. Let us system. Let me expand this. Okay. So module 4, social engineering attack, exploiting wired and wireless network, application vulnerabilities, OS comes into place, cloud vulnerability, mobile vulnerability, IoT vulnerability, post exploitation. There are some documenting for post exploitation, how to make a report, what are all the tools and codes available. I hope at the end it have a project. I have downloaded that, right? You see here they have a capstone project to complete this course. They'll give you some tasks. You remember whatever we have seen in the first 5 days, something might be here. You see here, we're able to see a SQL injection attack, challenge 1. We're able to see a directory traversal, right? And Samba, SMB says share. Wireshark, the first day we saw this too, right? So they are giving some 4 challenges for you to solve and make the report for completing and getting the certificate for this course, right? This. Fine, that's on the second topic. First, we have seen cyber laws. Second topic is so-called hacking or ethical hacking. The next topic, red team, blue team. Nowadays, this name is getting fancier, right? Red and blue, fine. You know, police and thief, red team and blue team. As the name goes, red team is an attacker who do something offensive. Blue team is a security professional who do something in the control environment. Imagine like a red is thief, blue is police. A company hires you to safeguard your company access infrastructure. Sometimes they want you to attack on the other company. That's against the ethics, but companies used to do, right? So red team is typically offensive. Offensive means doing so-called hack for a cyber attack. Something like a vulnerability is there, you are a threat, and you do some risk activities. Fine. Blue team is we discussed, right? Security Operations Center, IDS, IPS, firewall, SOC, right? SIM/SOAR, right? So that is blue team. So nowadays companies are hiring for this role, but they don't hire freshers for this role. At least they should have worked 1 year, 2 year in basic cybersecurity roles. Then they will be allowed to migrate to these job roles. Red team engineer, blue team engineer. See, red team is offensive, blue team is defensive. Red team has serial hacking, pen testing, black box, social engineering. Blue team has damage control, incident response, threat hunting, digital forensic. And you remember this? If you are seeing it again, this is the cyber kill chain. Recon, weaponization, delivery, exploitation, installation, CNC, action of objective. How the red team will work. Red team had to, from step 1 to step 7, the red team had to completely successfully complete all these so that the red team activity is done. They have done some hacks, right? Blue team labs, try hack me. I will show you some of the labs which are available. Okay, that's a try hack me. That's a website. They have some free courses and paid also. See, I've just come to the intermediate level. The first level will say, if you remember, we discussed knowing what is cybersecurity, Linux, then HTTP, DNS, then network packets, ISO model, LAN, networking, knowing all the basics, starting with defensive security, prevention, offensive security, right? See, there is, let's check what is there. This defensive security and offensive security. Okay, let's start with the offensive security. Let me resume the lab. It's in halfway. Some of my team have tried this. 15 minutes of lab. Hey, welcome. Find what does that mean? Which of the following options represent the process where you can hacker, right? If you are a hacker, obviously it should be offensive. Offensive means for bad purpose or attacker's purpose. Submit. Obviously, it's a same way. Hacking your first mission, they'll give you a fake bank-like website. See, this is a fake bank, looking like it's a fake bank. You see right side, the virtual machine is opening, right? So this is the free course, right? Free in the sense, some levels of the TryHackMe are free. After going for advanced levels, you need to pay and get it. But some beginner level of this website, TryHackMe, if you're hearing this or seeing this for the first time, the website name is tryhackme.com. You can go and create an account. I hope they have some discounts, privileges for academic accounts, college accounts, fine. See, TryHackMe, they'll have the whole modules free and paid. Okay, hacking your first machine. You see what is saying on the step. Hey, there's a bank website. Fine. So they are just typically see that's the difference. Why this websites like React Me, Hack the Box got familiarities like they teach something with the concept, the hands-on that is expected for the recruiter for the company, right? So when you see this, right, if you're teaching the same VAPT in your traditional classroom, we'll feel the difference. Student will write a 2 mark for VA, 2 mark for PT, an example, fine, but they won't be able to simulate this, right? You see here the virtual machine is loaded on the right side. Let us check. The machine is loaded. Okay, it's a Linux machine. It has a terminal. Fine. Okay, you see here on the left side, there is a website, right? There's a fake bank. I'm opening that. Instructions will be step by step. When you go to intermediate and advanced level only, you need to think and write a script or something. Beginner level, it is so easy, right? Just see the instructions and follow. See the fake bank. Mr. G. Benjamin has a bank account. Fine, this much amount is there. You remember the first class we discussed about confidentiality, integrity, availability with the bank example. Fine. So then you see here. Okay, refresh the Firefox page. Left side, instruction by instruction, it may be given. Fine. So okay, you have a bank account. Fine. Step one is done. Open the terminal. You see the terminal is this one. They're asking you to open the terminal. GoBuster-U, PegBank, word list, GIR. They have created a password list. And using the terminal, they are just trying to simulate an attack. This attack is done. You see here, you are able to get some PegBank.html, threads, word list, right? Status code, error code 200, 204, 301. Fine. The result is you got a status code 200 saying that you have found a hidden page in the bank website, right? Let's go back to the thing. Just a moment. Let's go. Fakebank.thm. What I'm doing, the attacker have found a hidden page. I'm typing in the URL bank-trans. Yeah, nowadays banks are not this much easy to hack, right? They have a several things. This is for beginner level to learn a pen testing. That's an admin portal, right? Send from bank account number. They'll give you instructions, right? Mission is to transfer from bank account number 2276. Send to bank account number. Your account number is 8881 in this virtual machine. You want to send $2,000. Imagine like this gives a look and feel saying that you are hacking the bank website and you are the bank manager. You are transferring money from one account to other account. See, transfer is successful. Fine. So this is the first step, right? They are showing how to do this pen testing in this lab. So in this scenario, this is like an intermediate level. Before that, we need to know how network security operates. Again, we need to know how HTML works. See, I am right clicking and view page source. It shows the source of this page. You know, right? Traditional HTML, XML, right? Our languages to create a web page, right? So attacker might find vulnerability in any of these things. Okay. Fine. This is on something called Try Hack Me. Fine. One website which gives, as I said, there are some 100 courses, 20 courses will be free, right? All about cybersecurity related courses starting from the network foundation, right? So there is another website called Hack the Box. When I was there at the university, I had an account in this. I recently checked that account. Fine. Hack the Box. Fine. Hack the Box is like you see a box. They are named it as a box, right? Each box, what they name it as each box is a system. It's a network. It's an infrastructure, right? So boxes might be vulnerable, right? Virtual machines might be. You see how many boxes they have? 6,684 virtual labs, right? So that the attacker you can just try all the labs. You see here, right side, a Python code is running simulator. Fine. So if you run this, the environment, obviously, you'll be able to try. See what is the thing. Starting, it'll have a easy, medium, rank. See, nowadays companies start recruiting something from this. Company just ask the first and second round of interview saying that, hey, what is your hack the box ranking? Or what is your try hack me level? Fine. You cannot do this, or students cannot do this the day before the interview. They should have practiced it over at least 1 month, 2 months, or 6 months. They'll be able to give the hack the box ranking. they'll be able to give the triacme levels, right? So this is one nowadays many companies, core cybersecurity companies are recruiting something like that, right? So no more traditional tell about yourself GD interviews, fine. So that is on this topic, red team and blue team, a fancy name given for ethical hacking, pen testing, VA or DON. GRC, it's one domain in cybersecurity. We call it as governance. Sorry. We call it as governance, risk and compliance. Fine. See, I'll show you. Fine. See, there's a domain called GRC. I'll give you some companies, right? So, big four IT companies. When I was there at the university, right? So, these companies come, there are 100 students, 80 students will be acquired by this company. I'm talking about cybersecurity companies, right? Sorry, cybersecurity students, BTech cybersecurity, MTech cybersecurity, fine. So, these four companies, right? If I'm not wrong, their names or they're called as big four companies, right? They are KPMG, Deloitte, EY, Ernst & Young, PwC, right? So these four companies, I remember the past 10 years at the university, cybersecurity placements, majority of the placements were in these companies only because they need cybersecurity engineers for doing a specific activity called as GRC, governance, risk and compliance. What does that mean? You say like you want to go and apply for a driving license. Indian government has a protocol. There's an authority for that. There's an RTO office. You need to go, you need to apply, you need to pass the test, you get the license. From starting to getting the license, there's a sequential step, well drafted, right? Same way for a company, right? It can be IT company, it can be a production company, it can be any type of company. If they want to keep their data secure, this has to be followed, right? That's called as governance, risk and compliance, right? Let me show you one common example. When we talk about GRC, ISO 27001, it's a certificate, right, given to companies. So most of my students, my colleagues, right, they work as engineers, GRC security engineers for this standard, ISO standard. ISO 27001 class, international standard for ISMS, Information Security Management System. So any company who wants to get a big project, 2 crore, 4 crore, they want to get the project and do, the client will ask, hey, are you capable of doing it? Nowadays, clients are asking, I'm giving my data to your company. Is your company secure, or else will your company manage my data, the data without getting hacked or compromised? For that, this is a certificate given to a company, right? You cannot get the certificate just like that. Hope every faculty knows the pain of preparing documents for UGC and NAC, right? Same way, a company has to prepare documents, everything in the right way for a ISO 27001 certificate. And that is not one time, just like the audit comes every 4 years. This ISO has to be done every 1 year or every 3 years, depending upon the organization. But if your organization has this thing, let me show you the logo. You know, right? We are talking about NAC A plus grade, right? Same way, companies having this ISO certificate, clients will be so happy to give them projects so that they believe at least the company is following some standards to keep their data secure. Fine. So these and all things comes under domain called governance, risk and compliance. And you see there are many other standards. I'll give you some standards. Everyone uses an ATM card. It can be debit or credit, right? They come under a standard called PCI DSS. Payment card industry, data security standard, right? Images. For example, India has a standard, you know, right? RuPay. Recently, in the recent years, India got this compliance. Fine. RuPay card. Fine. So previously we were using MasterCard, American Express, Visa card, right? Now Indian banks, we created our own standard and we got it approved globally from this PCI DSS, right? So now most of our thing we are using RuPay cards, right? RuPay is the PCI DSS. It's a standard for payment card industry. It's a data security standard. Same way, let's say there's a hospital, they have a standard called HIPAA. HIPAA standard. Hospital have to store all the customer data in the right way, right? So they need to follow the standard called HIPAA. And companies have something called SOX, SOC 2 compliance. SOC 2, it's an audit compliance, fine. Just like ISO, company has to follow this. So this is the standard. See, for example, if you want to become a faculty, you need to write the exam and pass, right? So you have state level exams, central level exams, and all. Same way, companies have to get some certification standard so that they get some projects, they get approvals. So the whole of the thing is managed by a group of team called as governance, risk, and compliance. It's a broad domain categorized as GRC. Fine. ISACA, ISACA, right? It's a organization globally who's managing the standard. You know, right? IEEE, you know, right? UGC, NAC, same way. ISACA is a body organization who's managing the standard. To implement the standard, they have their certificates also. Just like we give BTech degree, MTech degree, they have CISA, Certified Information Security Auditor, SISM, Certified Information Security Manager, and all. Fine. You see, when you see the numbers of these salaries, it will be interesting. You see, ISACA, CISA, certified salary, yeah. But keep in mind, if you want to get a job for some good numbers, salaries, or something like that, you should be qualified for that, right? Randomly, you cannot get a high paid salary, right? But in cybersecurity, the salary is something in an exceptional order. I remember a student joins as a company as a software developer, 20,000 salary. After 3 years, it becomes 30, 35, right? After 5 years, it becomes 40. After 10 years, 20,000 to 80,000 in a duration of 10 years. I know my students or my colleagues, those who are done BTech, MTech, cybersecurity, right? So starting salary 30,000, 40,000. After a year, you get 60, 80. After 2 years, we go like 91, right? After 3 years, you get on to a double-digit salary, right? But you keep in mind, this is a expanding domain. You need to learn day in and day out. It's not like physics, chemistry, learning the theorems once in lifetime. You need to learn day in and day out for the CC here. Entry level salary for this, some survey online says 4 to 5 lakhs. For mid level, 7 to 15 lakhs. Advanced, 15 to 25 lakhs. This is per annum salary, right? Package per annum. Fine. Okay. And the same is applicable for you talk about BAPT, you talk about SOC, any job roles. There are some salary windows available. Fine. IAM and disaster recovery. As the name goes, disaster recovery. Let's say a virus has blocked all your college computer. You need to go pay and get the money. Remember, we discussed about ransomware. Right? So in this scenario, if your college has a backup of all the data, all the system data every day, backing up in another different location, they can just format everything and put the backup. Or you might miss only 1 day data or previous data. But we mostly educational institution, we don't have regular backup mechanism. Nowadays, we believe something is stored on the cloud, right? But that also has to be configured in the right way. When you're talking about this principle called IAM, Identity and Access Management, we need to correlate this principle. You remember day 1, day 2 discussed on this AAA principle, authentication, authorization, accounting. Just to implement this AAA principle in the right way, in technical terms, we call it as ACL. That is called Access Control List, right? So putting them in the right way using a software or an application, the domain is called IAM, Identity and Access Management. What does it say? Who has access to data, when they had access to data, what they did with the data, right? Complete thing. So IAM and disaster recovery are combined, right? Combo. IAM controls user access to the system. That is called IAM. Who can access what, when, why they have opened the document, why they have edited the document, everything comes. Disaster recovery ensures business continuity. After a cyber attack, how much time it takes for the company or organizations to come back. Right? After tsunami, it took many days, many years to come. After an earthquake or a volcano, the country takes this much time to come back. Same way, after a cyber attack, your organization or your company, how much time or how fast it's coming back. We also call it as business continuity. We in cyber technologies we call it as cyber readiness, right? So that is called this IAM, Identity and Access Management and Disaster Recovery. Fine. Okay, we move on to another domain called Incident Response, IR. Fine. In layman terms, IR. Okay. It's called DFIR. That's called Digital Forensic and Incident Response. We'll see only IR, Incident Response, right? What does that mean? Incident in cyber terminology, it's not expected, unexpected, or else a hack. Incident is an attack. What response you do after an attack or during the attack or before an attack. Mostly incident response happens during or after the attack, right? So incident response is a structured approach to detect, analyze, and mitigate cyber incidents, right? So you're detecting the attack earlier. Let's say you're using a firewall, IDS, IPH is detecting. You're analyzing the SOC team, you're analyzing the network packet, saying that this virus have come into your system. It is infecting your Windows computer, it is infecting your PDF reader. Then you do a mitigation. CVE, CVSS, with all these things, you can give a mitigation for that. Fine. So that is called incident response. But incident response in real world is fast. What does that mean? We go for IR to many companies, right? They say, sir, an employee have stolen the data and run away. A hacker from outside have stolen company data. A competitive company have shut down this company websites. So we need to give them a solution within few hours. 4 hours, 8 hours, 24 hours, 72 hours, not more than 2 to 3 days, right? We get in, we do an IR, incident response. We have a general procedures, we have some standards, right? And we clearly say them, hey, this employee using this computer, they have stolen your source code and given to the competitive company. We have all the proofs. The proofs will be documented as per the standard. Then you see first vista cyber loss. If needed, you can give a 65B or 63-4C certificate. Fine. So the whole of the IR is going to be like preparing for an incident or preparing for the incident response. Identification. Let's say I remember like we went for a college for an incident response. The college management, the IT team, I know him, right? He called me, said that, sir, today in our college, many systems, there's a red color screen. We have not changed the wallpaper, but many computers, the screen is changed to some red color wallpaper, right? So he asked me, sir, I didn't change any wallpaper, but something like that is changed, right? When we dropped in, we really identified what is the red color wallpaper, right? Let me show you. This one, yeah. Let me open this image. See the college computer? The computer, the background, the wallpaper have changed it to some information, right? For example, yeah, the ransom note will be something like this. They give you some information. Hey, welcome. They'll give you an introduction. Welcome, I'm a hacker. I hacked into your computer. I hacked using that logbook. My name is ransomware. What happened? How to recover? I have hacked it. Everything is locked, sealed, fine. You want to pay me and get your data back. If you don't want your data, fine, you leave. Your data will be locked only in your computer. Fine. See, that's how the note you see here at the bottom. The background. Your files are encrypted with RSA 2048 and AES 128, right? And this. They're given a Wikipedia page. See, the hacker is teaching you, hey, I've hacked your system. You go and learn what is AES. It will say like how many millions years it will take you to crack the password. Only way for you to pay me and get your data back. Paying, you cannot pay in normal coins or normal money like a rupee or dollar. They'll ask you to pay in a virtual currency called Bitcoin. Hope everyone knows. Bitcoin is one of the most common virtual currency. There are many other currencies. You check like alternate for Bitcoin. There are many. You see LD, some different altcoin, different virtual currencies. So the attacker will just hack in your system and ask you to pay. So that's what happened here. When we went on to the preparation, the sysadmin sent us the screenshot. They asked us to come for an incident response. We said them, sir, your college network is infected by a ransomware. Out of 1,000 systems in your college, already 300 systems are attacked, right? For example, the attacker is asking $100 for one system, 300 into 100, right? Those many dollars you need to pay and get your data back. So what is it? These are all like mission critical. Let's assume today is Friday. System admin identifies this. He reports to the management. He calls us. We say, sir, Saturday, Sunday is weekend. We'll check on Monday. It won't work. Within Monday, the attack might have picked up the momentum, right? So incident response is hard real time. You need to do it within hours. And again, it's pretty costly. Keep in mind, a single IR report will be charged in lakhs, 50,000, 1 lakh, 2 lakh, or even greater. Identification, identifying what is the attack, detecting and confirming the security incidents. That's what we said, sir, your college is infected by a ransomware. When we called in, we went on, we did a containment, we found what is the ransomware. Fine. What is the ransomware? The ransomware is attacking a protocol called SMB protocol, SMB v1.1. Fine. So let us check what is the SMB protocol. SMB, I'll put SMB ransomware. SMB is not a ransomware, for your understanding I'm putting. Let me check the mode. Okay, SMB ransomware categorizes, they exploit, right? Exploit means a piece of virus code. Vulnerability is your weakness in your system. So exploit the vulnerabilities in a protocol called server message block. SMB protocol is a common protocol used in the networks. If you want to transfer data from one system to the other system over the network, SMB has to be in place. Just like doors and windows, SMB has to be in place, right? So this SMB protocols, by default, they operate on port number 445, right? So what recommendations we gave them? Sir, your college have a firewall. The firewall write a rule saying that port number 130, 135, 137, 445. Write a rule in your firewall, block all connections coming from 135, 138 and 445 to your network. So after that is written, what happened? That is not done. We have just done a containment. The attack is happening. The incident response, our security team have isolated the system to prevent further damage. Fine. Then eradication. We'll take a sample system. We'll take a sample system that is infected. Then we'll start reading it. Remove the malware, find what attack and how to overcome that. For removing this and other things, we have something called as, hope those who do some research, PhD or something, you might have heard of something called as VM, virtual machine, or else sandbox, controlled environment. Fine. So there is AnyRun sandbox. I'm opening a live website. AnyRun interactive online malware sandboxer. Get started. Fine. So this is an online virtual environment. You need to register and have an account. I don't want to log in now. Fine. Let us go and search for, yeah, it's there, right? Let us check this. AnyRun, what AnyRun will do? Let us check. In today's world of cyber attack, what they will do, you can give them a malware. In your college, the Windows 10 system, this version, this calculator application, someone have installed, or else this email someone have clicked. When you run, you see what's happening in the background. Attack is going, some executable is downloaded. The executable downloaded, you see the hash values of them. The executable is in the desktop. GET request is going on to the internet. DNS request is going to a IP in Russia or China, and finally the attack has happened. Fine. So this is a sandbox. Anywhere is one publicly available sandbox in which you can simulate the attack. What we did in this eradication phase, we have found the malware. It's a ransomware, right? We have contained something. Then in the eradication phase, we have removed the malware. We have known what are the attacks and what are the vulnerabilities. So why you are going to do this? Why you are doing this? Because we don't want the other systems to get infected. We want a permanent solution. Temporary solution, turning off the computer, disconnecting the network is a temporary solution. We want a permanent solution. Recovery. So we need to restore the system, right? Or else remove the virus and restore the system. Or else if there's a backup, go to the backup system and copy the backup and put it here. So after that, the IR team, the incident response team, will make a report that is called incident response report. We'll have a clear thing from when you called us till the final report, what we have done. It may be done for 1 hour, 2 hour, 1 day, 2 day, or even greater number of days. The attack is in a mammoth manner. Fine. So this is called as IR, incident response. Fine. Let's see the steps. Detection and analysis. Sorry, we'll start here. First step is preparation. Team is getting ready for IR. Detection and analysis, detecting the attack. Containment, containing the attack, moving further into the network or system. Eradication, removing the virus or malware. Recovery, putting your data back. Post-incident, making a complete report what to do. The same virus is going to come next, or else multiple attacks are happening now. Post-incident will say like how to prevent something in near future. Fine. Again, post-incident report will have the complete detailed report of the activities. Digital forensics. Okay, so we have seen this topic. That's what I said. DFIR. IR means incident response. DF stands for digital forensics. And again, this is my research area. Over the past 10 years, right? I do research on this. My PhD is on this. We work with police. We work with law enforcement. We give this as a service for public, right? Everything on this domain called digital forensic. And it's not only digital forensic. We call it as DF and IR. That is digital forensic and incident response. In layman term, we call it as, everyone knows that, cyber crime investigation. It's a fancy name, right? But in technical terms, it's called digital forensic and incident response. Let's see what is digital forensic. Digital forensic is the process of identifying the evidence, hard disk or pen drive or cloud, preserving the evidence. As I said, 65B, 66C, right? Cyber laws. You're solving the case or not, that is secondary. You get a pen drive or a hard disk or a cloud data, you need to preserve the data at first, right? So that's an important rule, or else it won't be accepted in the court law. So identify the evidence, preserve the evidence, analyzing using tools and techniques. Then finally presenting, making a document, going to the court as an expert witness. This step-by-step order is called digital forensic. Identifying, preserving, analyzing, presenting. And the important thing is you're working on the evidence. You need to do all these things in a manner that is legally admissible in the court of law. You cannot randomly do. Say like you have a mobile, photo is deleted, use a recovery software. You recover the photo, but you want to prove it in the court. That's a lengthy procedure. Get the mobile, acquiring, seizing. The mobile has to be there, documented. The mobile photo has to be taken. That has to be documented. We call it a chain of custody document. Then take the hash of the mobile, make a copy of the mobile into another file. Then analyze only the copy of the mobile. We don't touch the original evidence. Right? So that comes under this whole steps. Checking the integrity. The file is not altered or modified. Chain of custody, like your attendance, it's a detailed log. It will be verified in the court of law. It will be cross-examined in the court of law. Confidentiality of your data, legality, repeatability, and you see this forensic process should be repeatable. I cannot claim that, hey, I am an expert, I do investigation, you accept in the code. You are doing an investigation, you are recovering the data, you are recovering the tool. Another competent investigator, the same tool should be recovered the same data, the same number of emails, same number of photos, right? So that should be accountable in court of law. Identification, preservation, collection, examination, analysis, and presentation or reporting. Autopsy, volatility. Let's see the tools. Fine. See this tool called autopsy, AUTOPSY. Autopsy is a medical term, everyone knows. Fine. After someone is dead, you do some, the doctors used to cut the body and then say what is the reason behind their death. Same way, autopsy tool in digital forensic is a tool used for analyzing evidences. It's an open source tool. Mostly in academics, we use this. You see, I will give you another tool called the EnCase tool. This is the same tool like autopsy, but it's a paid tool. Highly paid tool. It costs in lakhs, right? And again, everyone is connected here are faculties from academics. If you want to do some research on digital forensics, PhD or research or project, I'll give you some useful websites. CFREDS NIST. Computer Forensic Reference Dataset, the project by NIST. Everyone knows NIST. Fine. Dataset types, different datasets, hacking case, data leakage case, drone images, mobile device images. This website has sample datasets. Sir, you're talking about investigation. I don't know how to copy a mobile. I don't know how to copy a hard disk. So this website has sample datasets to try digital forensic and incident response. Fine. So NIST website called CFREDS, Computer Forensic Reference Datasets. NIST, I'll take the other website, NIST dataset. NIST Cyber. Yeah. They have two versions, maybe. Go.in. See here, they have NIST data repository, data.nist.gov.in. Have different data sets. You see here. Same way, if you talk for cyber, they might have some specific data sets for cyber related. Fine. Trojan detection software challenge. How to detect a Trojan. They might have got a data set for that. Then I'm talking about NIST. They migrated this website, so NIST CFRDS. So this website completely has the data set for thing. And there is another website called CFTT NIST. Computer Forensic Tools and Testing. I mentioned, right, to do a mobile investigation, to do a hard disk investigation, they have a recommended list of tools to use. Again, we don't have, as such in India, we don't have a standard. We use NIST standards from US and UK. Fine. We don't have a well-drafted standard here. It's in progress, right? Indian government is working on it, right? But currently we follow the standards from NIST, US and UK standards. CFTT, Computer Forensic Tools and Testing. They have a catalog. You go to a supermarket, you have a catalog. Same way they have a catalog. They accept the cookies. Fine. I'm going to search for something. Fine. See what you want to search. So whenever we go for an investigation, hey, I'm going to come to your college for an investigation. Your college has Windows 10 computer. You are using a Foxit PDF reader. Your attack happened on your SMB. Fine. Some basic information. I cannot randomly use the tool which I am having. if that has to be produced in the code of law, I need to use the tool that is accepted, you know, right? Tablets that are accepted by medical council that can be sold, same way, right? So you see here, I'm going to do something called as deleted file recovery. Deleted file recovery from, let's assume your college is my client, fine. I want to find all deleted files, right? So I want to find it from your Windows 10 computer. The file system is a current day Windows 10 users NTFS file system. I want to identify overwritten files. The file is overwritten. I want to identify. When I search, it will give me a recommendation. Hey, welcome. See, the first tool is coming. It's called Autopsy. You can use Autopsy tool, but you are using it's Autopsy is completely open source tool. Sometimes when you use a complete open source free tool, in the court of law there will be more questions. You need to prove the integrity of the tool. Fine. Ballistic imager, bit recover data, Celebrate Inspector, data recovery systems. Say they're giving you quite a good number of tools. You need to use any one of the tools that is recommended by this, so that it can be accepted in the code of law, right? The cyber attack or something that can be documented can be accepted in the code of law. Same way, let us check mobile device acquisition, because nowadays every crime is coming is under mobile. I am using a, let's say, Mac device to support data analysis, to import and analyze. Select Mac or Apple devices. Very few tools are available for Apple and Mac devices. Fine, this category doesn't pass the tool. That's not available. See, video format conversion, video analytics. Recently, we did an investigation. We were working on a Windows computer for a CCTV. The DVR was there, right? The DVR was there. And then search. So if you want to prove it in the code of law, you see this is the only tool that's accepted by NIST. The database may be outdated. Amped Software, leading software company, forensic company, who's selling tool, forensic tool, DFAR tool for image and video forensic analysis. Amped 5, Amped Authenticate. We use it in the industry. Fine. So autopsy cyber. If I normally search for autopsy image, it will pop up medical images. I don't want that. Okay. So if you want, I'll show. Let's check whether no, lately I have removed from this user. I have uninstalled the software from my system. Give it. Okay, what's autopsy tool? Calm down. Let me open you the screenshot. Fine. Okay, XP inbox. Okay. See, they have taken an image in forensic is the copy of your evidence. XP SP3, a copy of your hard disk is taken. As I said, we don't touch the original evidence. We make a forensic copy of the evidence. It can be a hard disk, it can be a pen drive, it can be a mobile. Only the copy of the evidence we will investigate. That's what we are using this tool, right? So after investigating, it says bookmark, cookies, web history, deleted files. And in real world terms, the data will be stored something like this. Hard disk will store data something like this. Left side page, you imagine like a seat number 1, 2, 3. Center one, the hexadecimal value is the actual data. The right side is the ASCII equivalent. Starting from the first C colon till whole data you store in hard disk. If you want to put it in an X-ray machine, something like that, it will look like this. This is how the data is stored. The left side page is the offset, the location. The intermediate is the hexadecimal value. The right side is the ASCII equivalent. Fine. So this tool clearly splits and says what is it and how it works and all. So let's come back to our. We have discussed something on digital forensic. Fine. Autopsy tool, volatility. Volatility we have already seen. Fine. Threat intelligence and OSINT. See, nowadays cyber team companies don't want people to do some investigation on the attack that happened last month or last week or even yesterday. Companies want something called as a proactive approach. They want to hire your students, give them a security engineer job for them to defend an attack that may come in near future, right? Finding and identifying the attacks is fine, that has to be done. But nowadays, companies are migrating to a proactive approach. So that's a domain called threat intelligence. As the name goes, intelligence, you'll have an intelligence about the threats. Fine. OSINT is all about open source intelligence. Yet another small domain which says, you know my name, just by knowing my name, if you are able to find my address, you come back to my office. That is called OSINT. Collecting publicly available information of someone or a company or an individual. In your college website, your name will be there, your mail ID will be there, sometimes your Google Scholar profile will be there. With this, if I'm doing OSINT, free tool or paid tool, I'll be able to say where you are, from which city you are, what you are doing. If you are not so secure, keeping all your data logged, right? This data can be found on the internet, right? That is called open source intelligence, right? Let me take Intel Techniques. I'll show you some of the tools that are available on the market. Previously, they were free. Now they have converted into paid tools. This Intel Technique was one such. Earlier, it was completely free. Now they have made it paid. Okay. It's taking to the book page. No, not this. Fine. Let me check. Wait. Let me check off my some of the classes which I day 12. It is yet another course. Firewall. Here. Cyber kill chain. GRC. Searching for OSINT is here. I have it in the bookmark here itself. OSINT tool. Who is metadata to go? See, metadata to go is one of the OSINT techniques in which you have a photo, right? You can say where the photo was taken, who took the photo, just like by but if you are putting it in WhatsApp or something, the metadata will be removed. Again, metadata is the research area in which I do my PhD, right? So I work on this. So this is one tool where you can go upload a photo. It will say where the photo was taken, who took it, using which mobile. The metadata is not deleted. It will show you the whole stuff. Fine. Then let me take you to one tool called Multigo, because most of your faculties here. There's a tool called Multigo, a complete OSINT tool. They give free licenses for academics also. I'm not sure it's available now. I remember the previous institution, we got it 4 or 5 years ago. The tool Multigo. Fine. What is Multigo? You see here.
In the time it takes to pour your coffee.
It's a single tool. Fine. Let me show you the dashboard. Fine. See, just I know your college name. I'm giving your college name. Simple. Your college, abccollege.edu.in. You give to this tool. The tool will do everything. It will go and find what is the college name, where it is hosted, who is your principal, how many email IDs are there, where is your server, what are the files available. Fine. This is not a hacking tool. Montigo or OSINT tools are tool used for identifying publicly available data, right? It's a OSINT tool, open source intelligence tool. So they give it in a good looking graph. You see here, the graph, maybe the principal ID to the department HOD, the department HOD to individual IDs, or all your 6,000 student IDs, right? Everything will be put in a good looking dashboard. You can check it, you can compare it, how many matches are available for a specific name, a photo you are searching for, a person you are searching for. So it will give you the statistics on the internet, how many times it's available, right? See who are using this. This many government organizations, private companies, worldwide they use this. It's a paid tool, highly paid tool, Multigo. The common tool used for OSINT, open source intelligence. Fine. Yeah. So this is awesome. We'll see about threat intel. Okay, threat intelligence, as I said, company wants a proactive approach, right? You see, hope everyone knows the difference between this reactive. The attack happened, you do something reactive, fine. Proactive, before the attack happens, something has to be done, right? In 2010, or you say like in 2005 when I started studying, or in 2010 when I completed my BTech or something, company wants a reactive approach. They want the so-called hackers to do some attack and defense and do some reactive activities. But nowadays, in 2025 or even in 2030, right, companies want security engineers, right? Nowadays, right, we put a layer of AI. Who knows AI or who knows data science, something like that, right? So we need something called as a proactive approach, right? So for that, I'll show you a tool. Maybe that's a tool called threat intelligence tool. You remember the threat map which you have seen, right? In day 1, day 2 mixed, we saw the global world map. Attack is going, right? So that is an extended version of this threat intelligence. As a result of threat intelligence, they are able to show you a live map in the attack, how it is happening, right? I'll show you a tool called Cisco. Cisco has a threat intelligence platform called Talos. Let's say your college is regularly attacked by competitive college or something, you see under attack, fine. So you can just go and ask them. It's a paid tool, right? So you can go and ask them, like, for example, I'm getting an attack regularly from, let's say, www.example.com. I don't want to give a live college or something. It may throw some information. It's verifying whether I'm human. CAPTCHA, yes. Just a minute. It's taking quite a bit. It wants to verify whether I'm a human. Yes. Come on. Yeah. It verified me. See, this example.com, let's say your college is regularly getting a data from this website. If you have got this threat intelligence tool, right? Not a ethic hacking or pen testing or digital forensic tool, threat intelligence tool, it will clearly say, hey, in this country or in this state or in your place, this ransomware is regularly affecting. Your nearby college is infected by this ransomware, or nearby company is infected by this ransomware. They'll give you preventive measures how to overcome that. So that a week after or a month after and the same attack is coming to your company or college, we can prevent them, right? So that is the purpose of doing something called as threat intelligence, fine. Threat intelligence, the 2-mark definition, collection and analysis of data to identify cyber threats. Collecting and identifying past data or the live data, fine. Data collection, verification, analysis, actionable, ethics and legality. And this is not one time. Threat intelligence has to be done every now and then, continuously. Just like a heartbeat, right? They need threat intelligence so that in future, the attacks are identified and prevented. Okay, just a minute. This is OSINT, collecting details from press, podcast, processing them, analyzing them, giving it a single dashboard. Shodan OSINT framework. See this website, osintframework.com. I hope that's free. osintframework.com. Okay. It's open source intelligent framework. It's having a graph or something. We can search someone based upon username. I want to search based upon username from search engine. I want to search based upon username from names check. Click. Okay, it is taking me to the website. Another website. It's verifying CAPTCHA. This CAPTCHA is really interesting. Fine, even if you are not putting the tick mark, it will verify because I'm moving my mouse so that I'm not a robot. It have identified I'm an individual, right? So it have just passed. So I want to give Ashok Kumar Mohan. I'm giving my full name. Hopefully in the name I will be available in most of the social medias. So it's searching and I'll give the captcha, fine. See, it's searching for the websites or something that is available in my name. If I have a paid account, I can check the Facebook, YouTube, or something like that. See, one interesting fact, this OSINT or threat intelligence is, have you ever checked your full name on the internet? Fine. See, my system might have a cookie or cache, so because it regularly shows my interest, right? My interviews, my name, my meetup, where I went. On the second page, third page, different Ashok Kumar comes in. The results of my first thing shows like who am I and what I did and other things. And there might be some false information also. You see, this guy, my student, right? So he had a profile in which some of my name was tagged in. See, Ashok Kumar Mohan, founder director at Kriyama. So the in LinkedIn something has been mapped wrongly. So you keep in mind, like whatever you see on the internet, you need to get the data. When you're doing a OSINT or threat intelligence, you need to get the data and verify it. Right? Without verifying that, you might land up getting a wrong result. Fine. So that is on this OSINT. Names checker, fine. Go back, go back, go back. Click this. So you can search for a name, you can search for an email address. You can search for IP address and MAC address. You remember we discussed about IP MACs. You can search for social networks. You can search on LinkedIn. You can search on Facebook. Let's say I'm checking on LinkedIn. You can search on LinkedIn, Recon tools, Scrappy, Inspire, Raven, different tools. Sometimes it might be a Windows tool. It might be a Linux tool. It's a GitHub code. So you need to download and put it in Linux and run it. Then public record, business record, geolocations, forums, digital currency, dark web. Dark web, if you are hearing this for the first time, the internet, the darker part of internet where some data is stolen, dealt. See here. I'll give you with a single photo. I'll show the example. Dark web, iceberg, 4%. Images. There should be a photo with some numbers. Let's check. Let's check. Okay, let me open this. Only this is available. And I'll open this also. Okay. See, this is called dark web, right? So we know all websites, right? Your college website, your company website, my website, Google, Facebook, everything. The normal websites that are available on the whole of the internet is only 4%. This is as per the definition of dark web, right? Percentage might differ, right? 4% is the surface web we see on the internet. And the second level is deep web. Dark is at the bottom. Deep web is the intermediate place where the hacked data is available. Legal document, government record, academics record. Fine. You see here, I'll randomly type, right? Dark web, data leaks, Coimbatore college hack. Some random thing. I'm typing some random news. I'm not targeting any name or college. Let us search for some images. You see here, just a moment. Dark web data leaks page. Yeah. Fine. See, this is data of 1.5 million users are left. See, this website is hacked and the hackers have put something online. The black portion is maybe the username, password, or something like that. So in dark web, what you will find all hacked data, leaked data. Fine. So that you will find it on the dark web. the bottom portion 6%. But the majority data, the hacked data will be available on deep web. So surface web, normal web, deep web, the actual stolen missing data. Dark web is the actual dark market where this data is sold. You do a trade, right? Go to Amazon and Flipkart and buy something. Same way people go to dark web and buy offensive stuff, right? Hacked, leaked data and on. Fine. So that is on this. So because like you want to monitor your network or company wants to monitor their company because attackers are not available on the surface web. They are available on everywhere. So I remember last month the college in Coimbatore, that's what I typed, right? So during the admissions, their college database was hacked. The hacker put the database on the internet for sale for $5, right? You know, right? $5 in Indian rupees is 440 rupees. Fine. So the college website, the database, what it has the complete database of last year or the current year, how many admissions are there, what is the student, what is the fees, what was the concession, student name, parent name, Aadhaar ID, the whole Excel sheet likewise is completely leaked. And if you are a parent or if you are a faculty, right, you know the heat of the management, right? That really affected the placement, that really affected the reputation of the college, admissions and all. Fine. So that's what we need, cybersecurity at all levels. Fine. So I hope we are on the last 10 minutes. Let me go back. We'll see this. I regularly use this notepad so that it will be interesting to refresh it. We saw keylogger, hardware, software, IP address, MAC address, ports, protocols, then private, public, NAT, subnetting, Linux permission, Windows command, Linux commands, three-way handshake, firewall, SIM, SOR, I love you virus, system admin, password to HOD, common passwords, how to keep a password, authentication, types of authentications, public key, private key, cryptography, hashing, meet me at 6, meet me at 9, MD5, SHA, crypto, my ATM pin, how it looks like. We did a stego and tried. MaduraiCollege.com, MaduraiC0LLEGD.com, phishing page, SQL injection, fine. Then password, passphrase, session hijacking using the website URL, digital signature, digital certificate. We clearly saw the difference between what is a digital signature and what is a digital certificate. Then something different. Okay. Yeah. I've taken some random passwords here also. Sample passwords. Okay.
Thank you for completing this course. By now, you have got a fair understanding of what cybersecurity is all about. To enhance your learning journey, please visit our channel, and for more information, I would request you to subscribe to our channel so that you don't miss out on any of the important updates. Thank you.